Good morning. Welcome to the Artificial Intelligence and Future of Houston Conference. Taking part in this event means you are interested in the future, in how to be part of something new with great opportunities. Indeed, many experts are saying that what is happening with artificial intelligence today is the genesis of a fourth industrial revolution. To see how, just look at your iPhone. Face recognition, speech recognition, language processing and translation are just a few recent advances in AI that most of us now can't live without. Even Siri now has 6 different variations of English speech. Some people worry that AI will cost jobs and harm the global economy. This is what was said in the past about automobiles displacing blacksmiths and livery stables. But we now have millions employed in the transportation industry, and we certainly have an ever-growing public parking garage industry. People worry that computers are going to replace office workers. And we know now that in spite of the tremendous productivity gains, we employ millions more office workers than before. Time and time again, we find that a technology revolution, a paradigm shift, does not eliminate jobs, but it does change the skills needed for jobs. Artificial intelligence means more jobs, not fewer. According to a recent World Economic Forum jobs report, AI will create nearly 60 million new AI-related jobs across the globe in the next 8 years. And much of the infrastructure for building and deploying AI remains to be built, requiring even more jobs. Nearly every field imaginable, science, engineering, space exploration, medicine, transportation, communication, commerce, and many more, has benefited from the application of artificial intelligence. We have seen amazing advances in those fields and have benefited from the resolution of long-time problems. That's why I am excited that we're here at HCC and we're working to educate and train a workforce that understands AI and can harness its capabilities. Today, you'll hear a lot more about AI from the great organizations and sponsors represented here. We are grateful to each of them, and we look forward to hearing their exciting ideas and viewing their demonstrations and exhibits. So on behalf of the HCC Board of Trustees, HCC's faculty and staff, I thank you for taking part. Please enjoy the conference.
Good morning and welcome to the Houston Community College inaugural Artificial Intelligence Conference. I am Dr. Madeline Barulo Hopkins, Vice Chancellor of Workforce Instruction for the Houston Community College System and President of Houston Community College Southwest, home of the Center of Excellence for Digital and Information Technology. I'd like to start by giving special thanks to all of our sponsors who supported us being here today. We could not have completed this event without your help and support. Early in 2017, the faculty and instructional leaders of the college forecasted the increasing need for a talent pipeline with skills and competencies in the field of artificial intelligence and machine learning in support not only of the regional economy, but that of the state and of the nation. We saw AI as a game changer in our society, having fast impact in today's workforce. We are at a point in history where all industry processes, data analytics, customer support, and production are being transformed by AI and machine learning. Similar to over 100 years ago, where the demographics of the workforce were transformed from an agricultural society to an industrial economy. Now is the time when we're going through another major wave of change, driven mainly by AI and machine learning technologies. To accomplish these changes in the workforce, we have to do this together in partnership with industry leaders in technology and education. According to the Lincoln Emerging Jobs Report, 5 of the 10 emerging jobs in the USA will require specific AI skills. So as we develop the program at HCC, we focus on building a high-quality, hands-on program focused on the emerging technologies and real-world simulation and applications of AI in different industry sectors, such as manufacturing, healthcare, process technology, and others. We also focused on embedding industry credentials in partnership with technology AI leaders that will demonstrate competencies employers are seeking in this field. As a workforce development leader college in the U.S., HCC saw this as a priority for the college. Most importantly, from a diversity and inclusion perspective, we realized that the program development of this associate's degree was critical to continue our focus as an institution of higher learning on expanding access to 21st century technology skills and competencies that could provide upper economic mobility to the diverse population that we serve. So after much research and preparation, HCC launched the first Artificial Intelligence Associate's degree in the state of Texas in the fall of 2020. HCC was indeed the second community college in the U.S. to offer such a program. The college is proud to have partnered with Intel in the faculty development, as well as with Microsoft, AWS, and NVIDIA. This allows the program to teach what is relevant for employers and using the technology that students will interact when they move into the workforce. As of the end of fall of 2021, we had over 80 students majoring in the program. And I am extremely proud to report that 4 of the initial class members will be graduating this May of 2022. 2 of them have been the force and visionaries that led to this conference. Not only have they excelled academically, but they have demonstrated leadership skills as leaders of the Computer Science Student Association and in working with the college administration to bring this conference to you, to all of you here today. So we have planned a 2-day conference, bringing together leaders that are involved in the rapidly changing and evolution of AI, automation, and machine learning. At the recent Greater Houston Partnership State of Technology event last week, CEO Bob Harvey reported that venture capital funding of Houston companies has actually grown from $284 million in 2016 to $2.34 billion in 2021. He further reported that this growth includes a concentration of early stage funding, positioning Houston as the 3rd fastest growing early stage tech ecosystem in the country. Having a qualified, skilled talent pipeline in AI and machine learning is crucial for the economy of Houston and for the state. ACC is a leader in technology education, from computer programming, cybersecurity recognized program by the Homeland Security Administration, app development, network administration, AI, and robotics, among others. Our plans are to bring this conference annually to Houston and see you attending the event every year. So for now, thank you for being here today. Enjoy the conference. Good morning and welcome to the
Good morning, everybody. So we have a wonderful day ahead of us. My name is Samir Saber. I'm the Dean over Digital Information Technology, our Center of Excellence, and I'm also the advisor of our Computer Science Association. So yeah, we're very excited about today. We're a little bit behind on schedule, but that's okay. We'll eat into lunch and some of the breaks. So I'll be your MC. And the first presentation that we have is from Rajdeep Biswas. He's the head of data engineering and analytics, VP for GEP worldwide. So please give him a round and we'll have him come up here.
Am I audible? Yeah. All right. Just 1 second. They're gonna project the slides. Okay. Yep. So, firstly, thank you, HCC, for having me here. What a great honor, and can't seem to feel enough lucky for this day and this opportunity. A lot of cool stuffs about me, but really, the way I got thirsted in the world of data and AI was back in 2006. My first project was for a small company named Apple. It's called MobileMe. I was working as a back-end reporting engineer, stitching together all sorts of data, pre-Hadoop and Spark days. That particular product is now known as iCloud. And from that day onwards, I've been hooked onto the world of data, right? But had been a techie all my life. Love to write code, blogs, present. So again, glad to be here. But really, this is for whom I do what I do, right? These are my peeps, my family. They're all in Houston right now, my parents. They just keep me going, right? Even at difficult times, when things are not the way as it should be, they just keep me going. And so you need to find out who keeps you going. That's very important, right? Your family, your friend. Without them, we are nowhere, right? We are nothing. And I hate being transactional, right? I see that Ayman Hussein, the person who recruited me in Microsoft, used to work for Microsoft before, awesome relationship. I requested Ayman, come, let's do this together. And he said, heck yeah. So the relationships that you are building, the good people that you are meeting, try to stick to them. It helps. All right. So a little bit about data science career options. I'm not going to read through this, but, and by the way, I'm a walker. I would walk around. But really, you will see in data science, you have a full platter of options, right? Back in the days, I was just telling someone, early 2000, 2006, 2007, data engineering and data science, they were not married together. Data science was only done by some brilliant folks in an university setting, right? Always experimenting with no return on investment, right? And data engineering, people are always crunching the data. There was no amalgamation between the two. But now, data science, machine learning, and AI, it has been democratized thanks to the efforts of Microsoft, IBM, AWS, and Google. Um, and so now anyone can be a data scientist, anyone can be an AI engineer. Of course, you can go to a more involved, hardcore data science building, in terms of being a statistician, having that formal education. I did it myself because I come from a data background. Went ahead and did a master's in data science because I needed to know the maths behind it, but you don't need to, right? There are multiple options where you can use data science and AI and infuse them in your application without necessarily knowing how it is built, right? And I'll come to that. But, on that same note, I was talking about applied AI models, right? Where essentially you can infuse in your application, in your websites, human-like intelligence. You can mimic human abilities. This is some of the capabilities that gets exposed to Microsoft cognitive services. But the idea is, at the end of the day, you are going to do API call, and you are going to get these things out of the box. And when I say out of the box, this is a little bit more than off-the-shelf application because you can customize and tune this to your need, right, with your data. So this is one easy way to get started. Let me actually go back. I remember meeting a high schooler here. I just wanted to give you guys a little bit idea of the options that are available, right? I think today the problem is not the lack of information, but the abundance of it. So how do you know where to go, where to start? Having that structure if you're trying to learn something, right? So let me just, so for example, right, this is Microsoft. I used to work for Microsoft. I already told that. But for example, let's say you want to become a AI engineer, right? You can go to this place, right? AI Business School, just being with Google, and you need to log in here. Based on the role, you have essentially a structured content which you can go through with hands-on labs and whatnot, and start your journey. You need to start somewhere, right? And I think this is a great place to start. I learned a lot using this, right? And at the end of the day, some certifications after this, and I wanted to learn more. I did a master's, and then I want to do a PhD. That's me. You don't need to do that, right? But it's important to get started, at least to know whether you like it or not, right? Without any investment. This is all free. And Google and AWS also offers the same, right? Or similar. But I also want to urge you to look at Kaggle and KD Nuggets and sites like this, just to keep you abreasted with the latest happenings. Very important, right? It's important to know the art of the possibility so that you can innovate, right? So keep checking some of these websites. And another thing, for example, in Kaggle, I cannot emphasize enough the need of hands-on activity, right? So you can be part of a hackathon team, regardless of your strength, right? You don't need to be a data scientist. You can be a good PowerPoint builder. That works, right? You can be a good orator, good communicator. You can write a story with data. That works. But when you're part of these hackathon teams, it gives you that practical knowledge, right? So I cannot emphasize enough for you to do that. At Microsoft, when I used to work there, we used to do a lot of hackathons because we believed, and I still believe, that you learn the best by doing things with your own hand, right? All right. Moving back and forth. But so I was talking about applied AI models, and I just wanted to show you, again, the art of the possibility, things that you can do just by mixing and matching some of these pre-built AIs, right? All right. This is just a demo application. But all the AI stuff, school machine learning stuff that it is doing, it's not custom models. It's just API calls, right? REST API calls. So let's start with this is my favorite one. Hold on to change the camera, the front. Okay. All right. So just think about your kid or your friend driving interstate late at night after a party, super tired, not drunk, but and you are concerned about the safety, right? So this is a real-time driver monitoring app. So let's say the person is using a cell phone, right? So you'll see the distractions. There's a distraction that will get captured right over. And by the way, guys, this is real time. It's not a cooked off demo. The data going to Azure. It's inferencing it frame by frame, sending it back here, right? Your head pose, eye aperture, right? If you're tired, your eye aperture changes. Sleeping, your head pose changes, right? So again, cool stuff. Few clicks, few REST API calls, you can just build it. A lot of things actually is beneath the covers, right? For example, accelerated hardware. I know this computer vision models are running on field programmable gate arrays, FPGAs. You don't need to buy them. The cloud vendors already have that. Call it. You're gonna get the result in millisecond, and see that's the millisecond latency. It also identifies me because I used face API to train it to identify my face. Again, super easy. So just wanted to motivate you and show you some of the art of possibility, and that's why I insisted to use my laptop, because I had to build this app. All right, so let's see what else. There are some more fun ones, but this is another favorite one for me. This is the optical character recognition, right? So just think about the return of investments that some of the traditional Fortune 500 companies can get. Have an array of documents, boatload of documents. You just need to scan it, put it in PDF, and suddenly you can get the data on which you can have actionable insights, right? And at the end of the day, it's all JSON. So when you call the API, it returns you back the result in JSON format. It's super easy for you to embed it in your application and reason over it, right? All right, let's, what else? Okay. So this is just gonna take a picture of me and will assess how old I am. Almost. I'm a little younger than that, but almost. All right, let's go to another one. Okay, I don't know how it will work because, lighting and all those things, but it's a real-time crowd inside. Okay, at least it's, oh, someone is laughing. Yeah. Yeah, it has its moments, but again, it detects the emotion, right? Face API and frankly, this is not even cutting edge. It has been there for quite some time, right? But yeah. If anyone wants, they can come in front. Yeah, but think of the application of it, right? It's a fun demo, but you can apply it in a stadium full of people, right? Of course, maintaining the privacy and all those aspects. None of this data is cached anywhere. We send the data to the cloud, it does the inferencing, sends you the results back, no storage of data, right? Although you might not know the internal, every nitty-gritty of how this neural network model is working, you still need to know how the data is getting handled. That's very important. All right. Let's go back to the So, talking about how the data is getting handled, right? So you have all this power, right? Without knowing a lot, you can infuse AI in your application, right? You can create a chatbot, any application, right? And it can do a lot of stuff, right? But it is very important to understand, just because Microsoft or AWS has built the models and have exposed it, if you are using it in your application, you're still accountable for it, right? So the accountability of the person who is using it for making this world a better place, still it applies, right? The fairness of the model, the transparency, that's a very interesting topic. All these models, right, neural network or not, it needs to be easily explainable. How did it arrive at the conclusion of a loan application, right? What are the factors it considered, right? It cannot be, in today's world, we cannot just say, oh my God, it's a black box. There's an input, there's an output. No, you are accountable for that black box, and that black box has to be transparent, has to be fair, has to be reliable. Inclusion is another interesting thing. Let's say it needs to consider the edge cases, right? For example, the application you are building, it needs to consider person with disabilities, right? Just because it's an edge case, just because it's 0.001, you cannot just let it go, right? Privacy and security, I just touched a little bit about it. I'm showing your faces, but I'm not storing it. Going to the cloud, giving me the results, poof, no one is storing the data, right? It's very important to understand this subtleties on when you are using this AI application. Subtleties it comes along, right? So with great power, comes great responsibilities. So that's what I had. I would definitely take question answers, but before I end, I wanted to tell you that double click on the fact that I had been lucky to be almost at the right place at the right time, and so are you guys. You guys are at the right place and at the right time. Being in Houston is awesome as well, because I think it's going to be the new tech hub, especially after COVID. For example, me, I work from home, right? I work for a global company, but I work from home. So, and I guess, because of the cost of living, awesome food, Houston is the best place to live, right? So make the best out of it. Thank you. I think I have some more time to take some questions, Aro, if you want that.
This thing on? Test 1, 2. 1, 2.
Yes.
How you doing? I want to know, what would you suggest for students who may not know how to get started in data science and AI? I know you brought up the little workshops that Microsoft has where you got your start. Are there more like open source and free resources for students to get involved in that? And what would you suggest?
Right, that's a great question, right? Again, I will. So, as I was saying, the field is enormous, right? And every subsections of those field is has a lot of depth. So it's important to understand what you are passionate about. The high schooler that's here, she's passionate about graphic designing, right? And that's awesome. But she also loves business. I'm like, okay, if you can merge these two, that's awesome, right? So graphic designing, suddenly, it's not only graphic designing. You can go to NFT, you can go with data visualization, right? But you cannot do all. So then you become jack of all and master of all, right? Or did I say it wrong? but so it's very important to understand what is your passion, and then kind of identify your niche. And then, honestly, once you do that, there is no shortage of material. If someone says me that I want to learn something and I'm not finding it out in the open, that's probably not right, right? But also that makes me talk about formal education. My formal education actually helped. And I know, in US there are so many success stories, and it's still controversial, where you don't need to go to a college. And I believe that you don't need to, but mine did help me. I learned a lot, at least when I was doing the master's, when I was working for Microsoft. It helped me to go to the edges and those nooks and corners. It forced me to learn master's level statistics, right? So that's the answer. Right, any more questions?
How are you doing? My name is Ian Alonjung. I'm currently a student at Texas Southern University. I'm a computer science major, and I'm really interested in machine learning engineering. And I was wondering, would you suggest doing a master's in machine learning or certifications? Like, which one would you recommend?
That's a great question, right? So masters is a commitment, right? And certification is also a commitment, don't get me wrong, but masters is a more longer term commitment. There is no harm in doing a master's, and it allows, you can do a side gig, right? Do an internship in a company, and so learn while you're doing the master's. Certifications are great as well, right? It does helps to show the prospective employees, your strengths, right? But as of today, the job market is wide open. There's just too many vacancies and too less, qualified candidates. So if you're really interested, I think you will have opportunities to get into an internship, and parallel you can do masters, right? So that you are gaining that practical experience, right? And also, because once you do the masters, suddenly the PhD option opens up. You can go to research, right? Without doing that, I don't know, even if you can go that side of the house, but I guess it just gives you more options.
Thank you.
Over there.
Hello, my name is Giovanni Thompson, Texas Southern University. I know you spoke about the black box principle, essentially about the ethically and reliability of AI. So how do you seek like enforcement and kind of the private industry of that? Because we know that there's ethical considerations of like cleaning data and understanding and analyzing kind of the implications of how that data was collected, and some marginalized groups are not represented equally. So how is that enforcement aspect going to be pursued and enforced in the private industry, and both on research and academia?
Right. Great question, right? So, you're talking about how we can enforce the privacy aspect of it, the ethical AI on the ethical AI side. So a couple of things, right? You touched about on the data also. So we have this saying, garbage in, garbage out. Okay? So bad data will not produce good results. Still, the onus lies on the person who is using the model, right? Luckily for us, there had been a lot of development on the ethical usage of AI. For example, one library that comes to my mind is FairLearn. You can Google it out. That Microsoft developed in collaboration with Facebook, and it's open source product. You can use it, and it gives a way to transparently expose the underpinnings of your model to a layman. So, for example, the business folks, right? So the VP of business comes to you and say that, okay, there are too many rejected loan application or too many approvals. How do you come to this conclusion? So that library essentially says you, okay, income has 20% weightage. Staying in Houston has 80% weightage, and things like that. So they can understand easily, and when there are regulatory bodies that comes after them, they can expose it. So that's the transparency aspect, right? But there are, so you can read about GDPR. California has a lot of acts as well. So there are governing bodies who tries to enforce them, right? Especially when AI has been democratized to such an extent.
Hello, my name is Manisha Singh. I am a manager in IT. And so I'm wondering, you showed really good examples to use data science. Can you give us some details on the technology or like programming things person needs to know?
Right. Great question, right? And we have a boatload of them. So I will be to the point. If there is one programming, and take it with a grain of salt, but if there is one programming language that you need to know is getting used very heavily, that is Python. Right? And I come from Java and Scala, all those things, but Python is awesome because it's not only you who are writing the code. After you leave that organization, someone needs to read it. So the readability aspect of it and the maintenance aspect of it. And most of the machine learning, open source machine learning libraries, they have a Python implementation. So that is absolutely important. On the big data side of the house, so Python kind of covers not only the language, but the machine learning library implementations as well, right? And on the big data side, again, take it with a grain of salt, I guess, if there is one technology that someone needs to learn about is Spark, right? Very heavily getting used, that essentially will help you understand the paradigms as well. So Spark and Python would be a great place to start if someone wants to go deep down, right? Yes. They did it intentionally.
Looks like. Well, my name is Shilpa Fanse. I'm a programming faculty at HCC, and I have a question. Do you have job prospects for associate degrees in data science or AI for our students? Like, do we see a pipeline going forward? Houston, especially.
Yeah, so that's what I was saying, that now staying in Houston is actually awesome because we can still enjoy the low cost of living, right? And we can apply to all the companies in the world because most of them, right, they will allow remote working, right? So definitely with an associate degree, there would be a pipeline provided, this is very important, the students want to get noticed. right? So a online portfolio, for example, right? Some online presence, might be in LinkedIn. I think LinkedIn is awesome, right? Because it's very professional still, right? Where they are sharing what they are doing, their work, and there are a boatload of recruiters. You know, the last job I had, even in Microsoft, I did not apply. The recruiter reached out to me because of my activities in LinkedIn, right? So I am a testament to that. So, but definitely there are a whole lot of prospects, provided the person is willing, right? They need to show that they are there, right, to get noticed.
Thank you so much.
All right.
Everybody give a big round.
Thank you. Thank you so much for the opportunity.
All right, everyone. Hello, hello. Okay, we'll get started in just a moment. Please have a seat when you can. So everyone, we have a wonderful panel this morning. It's AI and IT. These gentlemen are incredible, so pay attention. So I'll start with quick intros, starting with Paul here.
Morning, everyone. My name is Paul DiCarlo. I lead our data and AI team within developer relations at Microsoft. Been working in roles like that for about the last 10 years and focused on seeing a lot of the changes that have been coming up in artificial intelligence over the last few years, and really excited to be here chatting about some of those advancements.
Excellent. Hey, good morning. My name is Ayman Hussain. I have the privilege of working at Microsoft as well, alongside Paul. I focus on the day job perspective on the enterprise and commercial business, where we bring to bear solutions that are built on AI and data and ML and whatnot to make sure that customers that use it are productive and benefiting properly from the data state they have. Been with them for about 4 years now, and I've seen a lot of growth in this space. So very happy to excited and to share that. And as Rajdeep mentioned, he and I worked previously together, so there's a lot of good stories to be shared. Excited to be here. Thank you.
Hi, my name is Roy Keys. I'm currently an independent consultant. I've been doing data science and machine learning work for about 10 years, doing hands-on stuff and also leading teams. And I'm also been taking up the habit of authoring some books that are related to some of this stuff. And I'm hoping that maybe some of my experience will be useful in this panel today.
Good morning, and thanks for attending the session. I'm Ramesh Prabhala. I'm the founder and CEO of Intellitide. We are a data management and data science startup. But we were founded back in 2017. So we focus on leveraging data as an asset across manufacturing, distribution, retail, and healthcare verticals. So really excited to be with you all and looking forward to a great panel session.
Thank you all. So a good way to kind of warm up this panel, let's discuss ways that AI is used specifically in your line of work, maybe some things you want to share. We'll start with Paul. You know, what do you see day to day in terms of AI?
Definitely the things that we're seeing nowadays tend to revolve around conversational sorts of artificial intelligence, which you've probably seen if you have a home assistant at home, those sorts of things, or you have a smartphone that can sort of pick out what you're saying, also being able to hear what people are saying, transliterate that into something that can then be parsed to determine intent. That would be one of them. And then the other one that we're starting to see quite a bit of interest in is in the realm of computer vision. So being able to sort of repurpose traditional cameras to basically act as sensors that can see, but not only that, they actually know what they see. Similar to how we're able to transliterate things from text, we're able to transliterate things from pixels that are coming in through video feeds. And when you think about giving technology those sort of sensory or perceptions, it really starts to open up the door into a lot of automation. So you start to think about how there's a lot of different practices in various different realms of industry. It could be anywhere. It could be in healthcare. It could be in manufacturing. It could even be in education. Down to anything can now start to be automated because we're starting to give those things the same perceptive abilities, essentially, that we as human beings have for technology. So the possibilities are endless. You're seeing that today with self-driving cars, various other different facets that are out there, and it's going to be amazing to see where this continues to head in the next 10 to 20 years.
Excellent. Hey, that's a good segue. So, and you think about what AI is true intention is, it's making a machine do things that you as a human can do, but faster, quicker, and with a little bit of smartness behind it. So in the commercial and enterprise space, in the real world, what we have is a lot of these large companies in all industries, all capabilities have a lot of data that they have. And if you want to make decisions faster, quicker, you actually have a data analyst that sits there and looks through it, and they have to be domain specific. If you're in healthcare, you need to know healthcare. If you're in manufacturing, you need manufacturing. So the intent of AI in a commercial enterprise space, that's where innovators like yourself will end up working, is to make sure those models can take the data that you already have and make something out of it. So that's what I see a lot of my customers wanting to do. It's like, hey, we have a lot of data. We don't have time to look through it. Can you give us insights and make the insights useful? And so that's the part where human beings become practical. You actually say, if these things look like this Therefore, it must be that, and let's go train the computer. That's what we call training the computer to do those pattern recognition. And if you, here's one of the things that you forget, like if you go to one of those websites that says, show me the bus out of these 5 pictures, or show me the traffic light out of these 10 pictures. What you're doing is training the computer to recognize that this is the bus, or this is a traffic light. It's also used for security, but the purpose behind it is you're training the computer. So when you do data science in an enterprise commercial space, you have to understand what the industry wants and what the industry needs. And you take those patterns and you train the computer models and you write the algorithm. That's where the education part comes in, right? You're taking something that is a formula in context and translating into what a machine can read. And that's where the programming part comes in. And some of these are becoming plug and play nowadays. You don't really have to spend a lot of time and then taking that insight to do a business decision making. No one wants data just for the academic purpose of it. They want some insights out of it. Now, you'll be surprised how much data there is out there that gives insights not only for the purpose of that industry, but for augmented industries around it, or around the context of it. There was a project we are doing at Microsoft where we are putting cameras in front of buses and capturing the picture of the road. Now, the intent wasn't for the bus. The intent was, let's capture the picture of the road so that when we see dips and holes and potholes, we're going to use a machine learning model to figure out how deep that hole is, how much square footage it is covering, and what street it was on, so that we can take that and send it to the public works department. And they can determine if they need to go hurry up there and put the hole, plug the hole. Can they do it in the daytime because that's a high thoroughfare? So imagine that cameras, just like Paul said, all it's doing is taking pictures. And then like how Rajdeep showed is they take the picture, somebody had to say, this looks like a hole. This is not a paper bag. Because if you have self-driving cars, one of the things people have to train the car to recognize is that a boulder or a brown paper bag? You don't want a car to swerve because a paper bag came in front of it, but you definitely want it to swerve if there was a boulder in the road, right? So you have to train these models. And that's what the commercial enterprises are doing today, is like, come teach using the data I have, the computer, so it can do faster, quicker, and we can adjust to the economies of the world. We have a pandemic, we have wars going on. So if you're in the business of making money and supply chain, those data points will give you the ability to get there faster, quicker, so you don't have toilet paper shortage. I mean, like that was a supply chain problem. It wasn't a toilet paper problem, it was a supply chain problem. So if you can get those insights faster, you can make decisions faster, and therefore you get viable. So when you're learning and you're trying to become in the practicality of, like, you learn the academic stuff and you want to go to the next level, this is the way to do it. This is what the insights need to do, is tell you the story of the industry where you are in.
I think that I've probably seen a few different categories of use, and that I'd put together as, like, there are what you might call the traditional uses of AI, which the big 3 are probably search, recommendations, and ad placement. That's the stuff that's been going on, for more than 20 years, and a ton of resources are pumped into that. And then there's kind of a second category, which is use cases that have been more recently established as very valuable and useful and more mature, which are things along the lines of robust forecasting for certain kinds of things. How much demand is going to come in for something, and you can get a lot of data, use all this. And then a third category I would say is a little bit more speculative, that we're still searching around to find some of these killer use cases for some of this new technology of AI. Coincidentally, I've also worked on exactly a project about looking at road surface defects with computer vision using cameras in cars. And these are the kind of things where these new techniques and models have been developed that can do this stuff so well. But then, you have to go from the technology and R&D to actually real world use cases where this is going to bring value to people. And that's where I think some of the biggest challenges are, is actually identifying where that makes sense. And there's maybe 2 things going on. One is there's a ton of hype around this. So people really want to do this, and they sometimes go in too early when it's not ready, or they haven't found the use cases. On the other hand, these techniques are getting more robust and also, in some sense, cheaper to actually use. So you've got sort of a push and pull there. And so we're starting to see a lot of really interesting things. But still a lot of stuff is focused on those early categories because people know that there's value, know there's value in search, know there's value in recommendations, and like it or not, a lot of value in ad placement.
We are in the business of data quality, so application of AI really pertains to that aspect. And what I mean by that is, just to give you a very common example, all of you have gone to Amazon.com today to buy stuff. It has, you will see Amazon has thousands of categories of products and millions of products themselves. Any product page, you're going to see the product has a lot of attributes like product description, its features, price. Any part of that, if it has a data quality issue, it will translate to loss of revenue. So, for example, here is a chair I'm sitting in. This could be, this may be listed on Amazon.com. If someone inadvertently lists this under table, you're going to lose sales. That's a particular taxonomy classification problem. In that space, if I can predict based on my volume of data and identify misclassified items, it translates to a huge potential, not only just potential revenue, but a prevention of loss of sale, right? Second example is chairs that we are sitting in. It could be sold individually or as a bundle. We have seen cases in our industry where someone, it's a human error, someone went and entered the price of one chair, but they are selling 4-pack chairs in a bundle, right? Now that goes from ERP into data management solutions, into e-com. It could have as well that data might have flown all the way into Amazon.com or your e-commerce website where you're listing your items, and no one would have caught it until orders are placed against that product. And when it comes to fulfillment of that order, that's when someone goes and realizes, well, I had a wrong pricing. This is an anomaly detection problem. Now, and AI can solve this. At least it can identify those anomalies to say, well, I am seeing a variance. I am seeing a huge deviation from what I think the predicted price should be to what you're listing today. Now, that doesn't mean AI is absolutely guaranteeing, our ML models are absolutely guaranteeing that there is a problem, right? You may have been selling a discounted deal where you're selling 4-pack for the price of one, but at least it's identifying an anomaly for a human actor to come and take some action. That's a classification of prediction problems that you're working on. So there's any number of problems like this, but it all ties back to data quality. That's this kind of set of, at least the use cases that we are, as IntelliTide, we are addressing at this point. And one more point is, it all again ties to the sheer volume of data, correct? We have customers like US Foods, American Tire, Honeywell. If they were selling 10 or 15 items across 3 or 4 categories, you wouldn't have them. But that's not the case. US Foods alone distributes 1 million items. American Tire, 300,000 SKUs. So when just multiplied by just the number of attributes and properties associated with each product, you're really talking about tens of millions of data points. That's when AI machine learning come into play in terms of classification, anomaly detection, and things of that.
Awesome, thank you all. So Houston is the energy capital of the world. Our mayor is very prone in making the city smart as well. So my question to you all is, so we hear a lot about edge computing, and edge computing is essentially you're putting sensors where it matters, right? Oil rigs, traffic lights, power plants, you name it, where you put sensors at the edge and it does the computing then, instead of sending all the data to the cloud, because it, makes more sense with bandwidth and all that kind of thing. So my question is, how does that look like in your world, and really what are some of the technologies that are used, but how can we tie that to education? Maybe some kits that we can use, or maybe if you have a small business, how can you even get started? What are some things you can maybe purchase, or some solutions that you see? And I know gentlemen on my left are very into that right now. So.
Sure. So that's a really interesting question about, I guess, the nature of edge computing in general. Why it makes sense is pretty apparent when you think about the need for real-time insights to create real-time events or possibly real-time interactions. So while there's definitely a large use case for data that's archival, for example, if you're looking at things like sales data that could have occurred years ago that could maybe predict current or future sort of buying habits or purchasing habits, there's different types of situations where perhaps you could be on an oil rig and maybe you have some sort of a situation where someone's not supposed to be in a certain area because if they were, they could get struck by some sort of piece of equipment. And this is where we start to see the advent of AI making a little bit more sense in real time, being something that needs to predict those events as they're happening, because the value of that data is most valuable at the time when the event is generated. It's sort of like a smoke alarm, if you think about it, isn't really good 30 minutes after the fire has started, but in that first second when that fire alarm goes off, that can certainly be the difference between getting yourself or your animals and that sort of thing out of the home or wherever you may be. What's interesting about this in the realm of edge computing when it comes to AI, they used to not necessarily be something that made sense, and part of that was because the computational power that's required for traditional AI, especially if you're performing inference in real time, would require something like a large-scale server, something with large-scale processing. And so traditionally where we've come from with AI is utilizing clusters or large-scale computers that are housed elsewhere that are usually looking at this data and typically after the fact. But the thing is, in recent times, what's changed is you now have the ability to operate and perform inference on small form factor devices that could be equipped with GPUs that are capable of performing the calculations that are necessary to produce real-time insights, really wherever it is that you need to employ them. And I think that when you consider that nexus of small form factor devices and solving these types of problems, that's likely going to be the harbinger of mainstream AI. The reason why I say that is it's one thing when you have AI that's happening somewhere else. It's another thing when you have it happening right in front of you, causing, I guess, benefits for you in your immediate vicinity. And that you think about this in terms of application of consumer devices. Imagine that you can tell who's pulling into your driveway because it knows which vehicle, so you know who's entering your house, or knowing things like who's going to be opening the safe because you're employing some sort of facial recognition right there in the moment that can activate those sorts of things. The last part of that question was really interesting, which is around how do you get started on some of this stuff today? And I want to say about 3 or 4 years ago, 4 years ago, more accurate, NVIDIA had started coming out with these small form factor GPUs, system modules that are essentially the size of a cell phone or even smaller that enable you to perform this. So if you ever look at the Jetson line of devices that they are manufacturing these days, and perhaps you're familiar with something like the Raspberry Pi that would be, a small form factor computer that you could utilize for CPU processing. Inferencing is now totally possible, and it's in a capability where it's affordable. So when you think about this from an education standpoint, you don't need a cluster of servers in order to accomplish these things. Just a few $100s for a small device can put something in the hands of a student where not only can they start working with AI, they can start working with it in front of themselves. And not only that, they can start performing the type of AI that can make immediate change in their environment. So it's a very exciting time. And would certainly encourage anyone that has that interest to explore those sorts of things to look at it, because this is something that's more or less a pioneering field right now, meaning the opportunity is ripe. And I'd say the barrier to entry is actually lower than you would think, given the amount of work that's already been done in decades before that's led us to what we can accomplish today.
So I'm going to start off where Paul left off on the learning part of it, right? You may not realize this, you're probably already doing that. You have Amazon Intelligence Switch at your home that powers your lamp on, or your thermostat like Nest. You're using an app on your phone or your computer to just tell it to do certain things. I'm away from the home in the daytime, so turn up the temperature, turn it down depending on what time of the year you are in. Hey, if dawn to dusk timers for your lights in the driveway or inside your house, so you're going to have illumination problems. So when you think of that, you're using a low-level computer in your iPhone, setting up some algorithms that is sending it to that device, because that device, even if it's not connected to the internet, will have that little bit of knowledge in there to do that. So to learn those things, there's many ways to get to the entry level of it. A Raspberry Pi is a great example. Raspberry Pi is nothing but a computer that, amazingly enough, is more powerful today than the 886 that I started on in like 1989, right? That's all it is. It's got a little bit of computer in it, a little bit of storage. It's got a little bit of a capability to do some high-end computing if you wanted to, and it's got a USB drive connector probably. It's got a Wi-Fi chip in it if you buy it such way. This is a small computer. What's not mainstream is you're not going to run Windows 11 on it. Now you could, but it's going to be a poor performance. So you have to kind of start thinking about the fact that when a Windows 11 or a Mac OS system, they're built for a whole bunch of stuff. And a Raspberry Pi, you don't need all that stuff. You don't need the overhead. So the education you have to learn yourself in there is like, hey, can I bring a stripped down OS version that is probably open source, that somebody from academia put it out there, to just install it. And once you've installed, what do you want to do? You don't need a fancy graphics card because you're not going to do mouse clicks. So you don't need a mouse driver to get rid of the mouse driver. Well, you need to do some input in that. So you need a keyboard driver. So these are the things you do to make that very edge computing device intelligent. And that's the learning you want to start doing, because in the commercial space, I gravitate towards commercial. That's what it is. It's just an industrial version of that is supported by somebody, that is going to be maintained by somebody, that could live in a space station, so it's environmentally safe and hazard protected. That's the difference between what you can do on a small form factor. Now, the reason we do edge computing in the world, both consumer and commercial, is to make those decisions real time, active there, without human interference. Think of it this way. Not too long ago, there was a guy standing next to a traffic light, a cop most of the time, with a switch that would turn green and red. It's almost 100 years old, but that's what they did, because that was the way. They would look at the intersection and say, okay, it's red, that one, green, this one. They would do that. Then we evolved to analog technology. They said, let's just put a timer on it. Every 2 minutes, it's going to be red and green. Got rid of the cop, right? But then they said, hey, that's still not good enough. So then they went and put some loops on the pavement to make sure that the magnetic field, when a big heavy truck came through, would indicate to that switch saying, hey, there's a car here, maybe you should try and turn the light faster. Well, that also didn't work very well, because more cars, more congestion started happening. What we are doing now was giving that traffic light the ability to decide based on a few factors. Still have the sensor on the ground. Maybe you have a camera right now. Maybe you have some sensors further up the road, like maybe cars are coming. And all we want to do is tell that little computer right there in the lamppost, is probably no bigger than like a chip of your size of your thumb, that says, hey, if these conditions happen, change the light. These things don't happen, don't change the light. Ever notice those traffic lights in the middle of the night when they go just flashing red? Nobody went and did it. It basically said, idle time. Let's not make people stop and wait for the green light and red light. Just let's go flashing red. So you just do a protected turn when you think you can. Now, that's easy to do, but imagine what I have to do if I have millions of traffic lights to control. I can't go to each one of them, program it with a little computer or an iPad, and then walk to the next one. I need a way to kind of send all these intelligence to it from a centralized location. That's the enterprise and commercial nature of it. I need to know all those devices, where they are, what they're doing, are they broken? So I need to put some logic gates in and say, hey, if you're powered on, tell me if you're not, I know you're broken, maybe something like that. Send a technician to go look at it. And that's the part of learning, is like, how do I manage millions of these devices across the world with enough intelligence that it can run on its own self and tell me back what it's not doing? So Samir started off talking about oil and gas in our energy field, right? We've had some disastrous experiences with refineries in oil rigs, right? People have died. Imagine if we had sensors that could do some intelligence at that level. We didn't need a human intervention. What if there was a blowout valve showing pressure buildup and we gave a computer right there saying, hey, if you see this threshold, immediately turn it off or evacuate or do something. And so that's what the industry is going. It's like, we're going to put sensors because they're cheaper. We're going to collect the data because storing the data is even cheaper. And we're going to look for anomalies. So in the oil and gas field, what we're looking at is, we don't want like the steady state, it's zeros and ones, so it's all looking good. We don't care. We won't even save that data. But the minute there's a spike of something, the anomaly that happens, I'm going to record an hour before, an hour after to see what is happening, what doesn't happen from different places. Maybe even finding out if there was a person on the rig, if there was, weather coming in. So there's many different ways to get that. But if I have to pull it all the way back to Houston, to a headquarter here before I send it back, which has happened if you read the stories about the blowouts we've had, which kill people, that's what happened. The decision-making was too delayed. I need the decision to happen right there so it saves lives right then. And that's what we're investing in. That's what the mayor wants us to do, is like find out how we can take intelligence down to that, including flooding. Like we have floods that happen in milliseconds. You've heard of those people. It's like, how ridiculous are you to drive in an underpass and die? I'm like, did you not see it? It's raining. Well, guess what? It happens so fast that by the time the cop realizes that underpass is going to flood it and he has to go bring that gate down, somebody's already driven there. Imagine if I had a computer there that immediately noticed that flood gauge is going up and that automatic gate just came down. We do that with the railway tracks. We don't see a guy sitting there at the railway tracks trying to wait for the train to come. The train is sending signals ahead of time. There's sensors on the tracks. And then it also has sensors on the road saying that there's traffic, so you better, slow down, or you better speed up, or it's, I live inside the loop and there's this train track that goes just through Westheimer, which is ridiculous, very busy thoroughfare. But you'll notice there's no trains between like 7:30 and 10:30 because that's the most traffic oriented. But if you ever look, if you're passing that train tracks, you look to the right and the left, you'll see the train with a satellite waiting. Well, somebody told it, said, don't go now. It's a very busy time. Just wait till the traffic stops. That person's not sitting there looking with his goggles to see what's happening. He's just looking at a computer that says, oh, the traffic's gone down. I should power up the train and move forward. So that's the edge computing. Those decisions making at the edge is important. Another thing we've noticed in autonomous vehicles, right? We want a car to drive itself, but imagine the amount of computing power the car needs to have. It will be so immense that you won't have but one seat. So you have a car with one seat. Well, that's practically not useful because the computer's going to be so big if you want to process everything there. But imagine if I'm a car, I'm driving down, it starts to rain, and my car computer recognizes it's raining, but there's a computer by the street light. It sends that information to the computer on the street light saying, hey, it's raining, maybe you should slow down. And there's another autonomous vehicle 5 miles behind me, gets a signal from the computer on the side of the street saying, hey, it's raining, you should slow down. So now I'm distributing the edge computing to devices around me to be more intelligent. Well, guess what? That's what Waze does. If you use it for traffic, you as a human and saying, there's a cop, there's a cop sitting here, you put it in there, it sends it to the computer, then it sends it to you. If you're on the road, it doesn't send it to everybody. It just sends it to people that are on that road for that moment, right? So that's one of the things that we need edge computing for, is like, you can't do all the processing in one place. You have to distribute it out. So if you're a car, you're autonomous, you need to know what's going on. You want to send it to the computer on the side of the street. It's much easier to maintain and manage. That can send it to the next one, and then you start distributing that. So the technology you have to learn is how these distributed computing is working. How are you sending models, updating them, keeping them up to date? And if you're in the commercial space, making sure that they're working all the time, because you may have lives that depend on it. And that is very rudimentary science. It's not very difficult. The things you're working on is how to manage, maintain, deploy, and keep that in check. So if you leave academia and then you go into the workforce, those are the skills they'll look for. It's like, I don't care about the model. We have a data science that's there. Can you just manage distributed computing environment? Do you know how to manage those systems and deploy the models to it and read back the data that's sent? And that's a whole different science on its own.
I'll talk about just some of the learning aspect. I haven't done a ton of this personally, but I've seen, I know other people have done a lot of it, but I think there's probably 3 main categories of things you can use to learn this. One is on your mobile phone itself. There are several ways to deploy machine learning models there, do AI. There are some dedicated systems. I have one that I'm not sure if they still make it, but from Google that cannot remember the name, but it's something like Vision AI, and it's a little cardboard box with a Raspberry Pi with a dedicated small GPU inside there, and it comes preloaded with a bunch of models to do some of the stuff that we've seen demonstrated here, and they have one also with voice, and then also you can go directly with like a Raspberry Pi and buy some of the add-on kind of chips to allow you to do some of the processing. All of those are based on some of the open source frameworks that allow you to take machine learning models and deploy them. So you have TensorFlow to do neural networks. There's TensorFlow Mobile, and then PyTorch has something also allowing you to deploy on these small devices. And then there's another, I believe it's a framework, but there's also a community called TinyML, and that's aimed at doing this kind of edge computing and low power device computing with machine learning AI stuff. So definitely a lot of resources out there, and some of it you can even do without having a device, just on the learning side.
Yeah, I'm going to focus on the learning side too. I think Paul covered the use case extensively. So we happen to be involved in a oil and gas project for a pretty big services company based in Houston. And they were implementing a well management solution. And a good part of it was edge computing. But part of that project was not just compute on the edge, but also getting the data off the edge, because ultimately you have to collect that historic information in one place and apply machine learning so pattern detection can happen. And whatever solutions that come out of it goes back into improving the solution or the application at the edge itself. So look at all the skills that were involved here. We had firmware experts, we had IoT experts, we had cloud experts. It'll warm your heart, Microsoft guys. It was Azure that we used at that time. We had visualization, Power BI experts, developers, .NET, Java. That's on the technical side. On the non-technical side, we had project managers, business analysts, subject matter experts. Again, it's very important to get subject matter expertise in that domain that you're trying to apply that problem to, right? So as a student, look at all the various skills here. Now, we did have data scientists, the mathematicians, the guys that were building the statistical models, the machine learning model. But that was like 2 people out of a team of about 25. So when we talk about AI, it's very diversified. There's a lot of learning opportunity. There's a lot of skills. So don't just focus on the math part of it, right? You can be a project manager. You can be a business analyst. You can be a data analyst. You can be a data engineer. You can be a visualization expert. You can learn Power BI, Tableau skills. You can be a project manager. So AI encompasses so many. It's a huge learning opportunity, a lot of skills, and this also ties into why AI is not going to be reducing jobs anytime soon. If anything, it's actually going to increase jobs. But as a student, you have a buffet of choices, right? The entire AI ecosystem encompasses a lot of skills in what you might traditionally have in mind. It's just Python. I need to know one thing or the other. No, you can be a project manager, for example. So that's my take. No question.
Thank you for all that. So last week, one of the biggest announcements from our chancellor at the State of the College, he announced that HEC is building a new Center of Excellence for Resiliency and Response. The city is looking for HEC to kind of be a trainer for the Gulf Coast region and public safety, rescue, drones, AI, ML, anything, you name it, right? And as you all mentioned, Ayman, I'm glad you touched into that. How does the edge work with the cloud? And Ramesh, you also talked about the different skills needed there. So and some of the thoughts that I have are, there's so much data that's being crunched at the cloud. There's a lot of innovations in processing and the cloud. So it's kind of simultaneously happening, but there's a huge need from industry. So what I'm getting to is, part of that resiliency center is we need a lot of insight from the industry, but I'm also wondering, how is the city involved? It's really involving all of us, right? So I don't know where I'm going with this. No, but the question, I guess, is more on how can we help the smaller businesses or just the day-to-day kind of to get involved. And you already touched into some of the skills, but I know it's daunting for everyone because they hear cloud, they're not sure what cloud is. Cloud is just, it's a fancy term for a bunch of computers that are just one giant computer. It's crunching all the data, and the other things we were talking about is the sensors that are doing it locally, right? But yeah, it's, I guess where are we headed with this right now in terms of how we work closer with the city? The governments are always behind in that. I'm sure they're lacking the staff, one, and you're probably seeing that shortage as well. But so I touched on different points, but if you want to make some comments on that, then we'll take some questions. And
Sure. So jumping on just the topic of smart city and I guess the things that enable that, certainly you've sort of laid out there that maybe there's sort of a divide in that we don't necessarily have the expertise to implement these things. I don't know that that's necessarily 100% true, given that if these things are successfully implemented in one locale, for example, things get tested in some city, and they're able to achieve some sort of success through deployment of AI devices. Maybe they want to do something that tracks traffic schedules or tracks pedestrians, or even the great idea about being able to detect flash floods and things like that. What's really nice about AI is because it is data-driven, it becomes a little bit hard to start in that you need to collect a lot of data in the first place in order for these things to work. But once you have that data, it's still usable for solving additional problems. And so you end up in a situation where if smart cities can sort of be proven in one locale, the same data that's usually feeding those things is usually similar to the use case that would be going on in a different locale. A good example of this is, say, elevators. Whenever an elevator goes out of order and doesn't work, it becomes a big problem trying to get those repaired, because believe it or not, even in a city like Houston, there's only a finite amount of mechanics that can service specific elevators. And this goes even more in depth if it's a different manufacturer and that sort of thing. Imagine if these things are equipped with sensors, vibration sensors, and those sorts of things that can sort of detect faults before they happen. What's really nice about that is, imagine you're at a conference and you've somehow thwarted that. You knew that this elevator was looking like it was going down, so 2 weeks ahead of time, you got your mechanic out there, you got the elevator serviced. What you've saved in that situation is people don't have to be inconvenienced by the elevator not working at the time when it needs to, but also by having that ability to front load the problem occurring before it does using predictive maintenance. You're able to contact these very, very hard to reach mechanics ahead of time in order to solve the problem. But the bigger thing about this is you think beyond just one facility with one set of elevators. Now that manufacturer, wherever their elevators are employed, can constantly be learning from the sensors that are employed in all of those elevators. And this is where you end up with sort of an edge cloud hybrid sort of solution, where you've got local devices that are collecting the data, perhaps coalescing that somewhere into the cloud, creating a generational model utilizing all of that data that can then be redeployed back down to the edge devices and makes them more smart. So what's really interesting when you talk about smart cities is it's almost like it's not really a competition. It's also not something that, if these people have it, we can't. If it gets solved in one place, re-implementing that same solution can actually make anywhere where those solutions are deployed better, just because of, going back to the original point, the aggregation of data becomes much more rich if we're able to share that across different use cases. And this is what leads to generalized AI models. And ultimately, the larger scale goal that when we sort of think about the sci-fi application of AI, which is how do we get to generalized AI? Things that, know everything basically, or things that know problems before they occur. This is how that happens. And that should be one of those things where if you think about it today, if you're solving problems, whether it's in Houston or even a smaller city, any of the problems that you are alleviating could then be lifted and alleviated problems in other areas. So you can think about that on a global scale. You can think about that in, first world, third world countries. All of that sort of thing becomes valuable. So if you're solving the problems today, don't limit yourself to them only solving the problem at hand. With AI and generalization, they can solve problems practically everywhere.
It's a great segue. So one of the things, if you think about the smart city initiative that the mayor wants, the resiliency, the key word of that is resilience, right? We know disasters will happen. We know we're going to get smacked with a hurricane, flood, or something's going to happen. It's how fast you bounce back from it and how fast you can get back to the routine is the intent of a resilient city. And the way you do that is incorporating technology at critical places that gives you the ability to come back fast. Like we are going into this microgrid context, right? One power line goes down and neighborhoods are dark. Well, what if we had a microgrid context? Well, microgrid is easy to speculate, but it's very hard to implement if you don't have the right infrastructure. But guess what? Just like Paul said, there are developing countries on the other side of the world where they don't have the liberty of grid lines like the US does. They have microgrid and they have perfected it. They have perfected micro energy generation using smaller windmills and the smaller gas generators. And if you think about that resiliency, there are parts of the world there's leapfrogging technology that we had the luxury of having. There are parts of the world that don't have landlines because they don't have good telephone infrastructure, but they have great 5G mobile communication, which is sustaining everything from banking to e-commerce to shipping. And think about that. They don't have power in a reliable case, but they have 5G telephone networks that can do all this very efficiently. So one of the things of building a resilient city is actually thinking about the things from a different perspective. I equate this to that movie scene from the Apollo 13 movie, if you've watched it, where the guy comes up and says, we got to change this square filter to this round filter with nothing but this, right? Because they don't have those in the spacecraft. So you have to do this with that. Resiliency and planning for it is essentially like that. So one of the things I advocate, even at the academic level in schools and institutions, is do this thing called the hackathon. Get all the people in a room, put the constraints on it and say, solve this using nothing but that. And when you do more of that, you will realize that you're solving not for a global footprint. I'm like, that's one of the challenges I feel in the enterprises. We try to solve it for the purpose of commercializing it, making profit with it. So if you don't see those lines of sight, we try not to do those investments. But if you are thinking from a hackathon perspective, from a survivable perspective, or from the perspective, hey, I can't do anything but with this, you'd be surprised how much innovation can come and give life back to technology that you may have otherwise thought were not necessary, like this edge computing. These computers are practically useless for day-to-day computing purpose, but because they're so small, they take small power, they have a small chip with only so many functions that you can do. You can now use technology that was invented 40 years ago to do something today because you have innovated using that hackathon mindset. Like, I'm going to use this, but that. A great example of this, all those spacecrafts we've sent into space that are like 30, 40 years old still talk back to us, right? Imagine the innovation that went there to design something like that. We have a helicopter on Mars that's flying around taking pictures. Keep in mind that radio signal takes 22 minutes to come back and forth. The guy sitting in JPL in California or in Houston here already told it to do something that doesn't know if it's happened or not till it's happened after the fact, right? So he has built enough intelligence in a small factor to say, hey, if it's windy, don't take off. If you don't have enough power, don't fire up your rotors and get going. But that person won't know until 22 minutes after that fact, that if it happened or not. So if you think of that, resilience is exactly that in the city's footprint. We can use existing technology that's already out there and do things differently with it. You know, you have lamps that have incandescent light bulbs, change it to LED, and LED is very small form factor with a sensor. These things doesn't need a lot of innovation to get to be resilient. Maybe you put a battery pack. If you put an LED lamp in the street light, maybe even a 12-volt battery at the base of it can power it when there's an outage in the city for grid power. So there's illumination in the neighborhood. It's not completely dark. These small technology innovation making a city resilient or smart does not take a lot, but that hackathon might then comes in. So when you sit together in a room, explore what you can do, you can solve these very easily, very quickly. And edge computing is just a part of it. That's the part we communicate. Cloud computing is a part of it. One of the things that in the world of AI, if I were to do a prediction, one of the things that people talk about is deep learning. AI is making a computer do human tasks. You tell it to do certain things in a predictable way. We've been doing it for a while. And then the next part of machine learning is make the machine learn itself a little bit. Maybe you can figure out based on a set of data, but we still control it. Deep learning or the reinforced learning is the computer itself correcting its behavior. It's like a child, a toddler. A toddler starts to walk, stumbles over a toy. Guess what the toddler is going to do next time? It's going to avoid the toy. No one told it, don't walk around, don't keep doing that. But that a computer robot will do it 3-4 times, then you need to build enough logic that says, don't do it next time, go around it. And that deep learning is what the future is, the reinforced learning, the ability to learn itself. And that's education. That no computer is going to suddenly wake up sentient tomorrow. So you actually have to teach it till that gets there. And so AI, making computer do stuff that humans can do under faster, quicker motion, machine learning, making the machine learn from a set of data points. So that's something that can make a city resilient, and then deep learning, make it learn on its own. Now that's the scary part. That's the science fiction part, because never know what that happens at that point. They had that story about those computers that talk to each other, and then like 2 weeks later, they're talking in a language they don't even know. Is that really gibberish, or is that real communication that's happening? So those are kind of stuff that education and schools like HCC with this resilience can start thinking about in the future. And I think that's the open territory that hasn't been, no one's fixed it. Like MITs and Harvards, they haven't figured out either. So it's great open territory and great place to be.
I'm a data scientist and machine learning engineer, and I don't know anything about resilient cities. That said, I've gone into several other projects the exact same way, where I didn't know what the topic was. And the key there has been basically collaboration with the experts on what's going on. So if we're talking about floods and hurricanes, or we're talking about other things that I don't know everything that's encompassed by the resilient cities. I know it's a lot bigger than that. I think part of the key there is how people work together to bring these kind of technologies and solutions. And it comes in a few different ways. One is bringing people who are the experts in these technologies in, but on the other hand, it's also helping to educate people who are the subject matter experts in what these technologies are and how they can be applied. So I think a place like HCC, or as part of this bigger effort, some of it is training people to be able to do the machine learning, artificial intelligence, but on the other side, it is helping everyone else understand what that is and what it can do, because it's usually going to be the subject matter experts who are the ones who recognize where you might be able to apply this. The people who are the artificial intelligence experts might also recognize something, but usually you have to meet in the middle to understand the realities of how this could and might work, and then work together. So I think it's, to me, the best case scenario is you have subject matter experts who know enough machine learning to be dangerous, and the machine learning experts who know enough of the subject domain to probably be dangerous. But then when you have both of them working together, then you can actually get real outcome.
Good point, Roy. Samir, I'm going to focus on the last part of your question. Does AI help small business? AI, business intelligence, advanced analytics, this is not the privilege of just large companies alone. I would argue, in fact, small companies need more AI than maybe the larger ones. We have a customer, sub $500 million annual revenue customer, pretty small, or mid-size customer. They have about 9 warehouses and 1,000 vendors. And these 9 warehouses are located in different parts of the country. One of them happens to be in Florida. And, come fall, Florida is susceptible to adverse weather, right? So they wanted to predict weather patterns that can help them reduce any adverse impact on their supply chain, number one. Number two, they have vendors sourcing products from different parts of the world. And now due to weather or war or whatever the case may be, supply chains getting disrupted. COVID is another contributing factor. So they're asking questions like, if I can predict a supply chain event before it happens, if I can predict which vendor will not be able to give my product on time, and by the way, this company distributes food products, so there is a lifetime component to it, right? They are perishables. They're asking, can I predict upfront so I can take a remediation action much before that event actually happens? Now, if this was a large company, a adverse event may not, they can survive an impact to the bottom line. Small companies probably just can't. All it may take is one event to negatively impact bottom line, and we have seen how many businesses during COVID closed, right? So I would actually argue the reverse. Small businesses need more AI, business intelligence, analytics than maybe the large businesses. So it's important all across the board. And small businesses generate a lot of data too. See, sensors and IoT devices are just one source of data. There are other sources, right? ERPs have tons of product data. CRMs like Salesforce have lots of customer data. I mean, collate all of that data. And even a small enterprise, you are talking about millions of records and data points to deal with.
Thank you for that. So if you're a small business, get with the experts, get with the cloud pros, get with the city, figure out how we can get your data, make sense of it all. So thank you so much for everything. At this time, we'll take some more questions from the crowd. In the back, Clark. Gentleman in the back.
Yes, hello. Giovanni Thompson, student from Texas Southern University. So my question is kind of relaying back to the smart cities infrastructure conversation. So is edge computing viable in the real world, especially when taking into consideration the current tech infrastructure? And then how can you mitigate security challenges of edge computing, since those microprocessors like Raspberry Pis are so limited in their computational efficiency and computational ability?
That is a great question. In fact, a lot of people, when they consider these edge computing cases, it usually falls under the realm of IoT. And people will always ask, well, what does the S in IoT stand for? Security. But you notice there's no S in it at all. The thing is, number one, with any sort of computer system, especially when we talk about at the edge, so right at the site of deployment where it's going to make sense. Let's use a traffic light as an example. There will be a machine there that is performing some sort of inferencing operation. And if that can be physically accessed, then absolutely that becomes a security mitigation. What we sort of see today, all the way down from the small single computers, even down to devices that are running tiny ML that might be on a microprocessor, is what we're starting to see now is like security down all the way in the BIOS level. So UEFI firmwares that can tell if anything's ever been tampered on the device code-wise, number one. Also, no professional IoT solution that I've ever seen is not going to employ some sort of secure transmission. If it's not, then you're in trouble. If you're submitting things in clear text or anything like that, then you're absolutely going to be facing some consequences there. And the other thing is looking at signature execution. So knowing beforehand that code that is running on a device has been either stamped with some sort of, basically you can think about it the same way that SSL works, saying that this code is able to be executed on this device. And in the instance where it cannot, it does not execute it. And what gets really interesting is when you think at the more powerful computers, you would think those could be more secure. That's semi-true, but let's jump all the way to the worst edge case where it's a microcontroller running firmware, and you're basically, if somebody attaches wires to it, they can probe it and figure out what's going on. What we're seeing now with Azure Sphere is one of the products that Microsoft makes that's specifically in that space. They start to look at whether there's capabilities that can be enabled on the device based on, again, that signature that's applied to the code that runs on the device itself. Meaning, maybe there's no need for serial access. So when that code executes on that device, if serial is ever attempted to be probed, the device will basically kick itself offline and say, you know, there's been a mitigation here. And this is where, again, some of the edge to cloud stuff becomes important. Is even if you're not wanting to collect data, you do at some point want to monitor your devices in the field and be able to say, like, what is the current running status of this? Has it been mitigated, et cetera? So what we generally try to do with any of these sort of solutions is have them tethered in some sort of way where they can be observed. And you can say, this is executing in the way that I ensure it to be. Now, while I've labeled out all of these solutions for how we get to security, they're not easy to implement. They're not out-of-box solutions. For the most part, they are things that generally you would purchase as a package solution or need to go to an implementer that's familiar with these types of things. But at the end of the day, if you ever want to punch that hole in, you know, is this device secure? If I can touch it, if I can grab it, you know, if I can go up to that thermostat and change the dial on it, then I can change the behavior of that device. And it's all about seeing all the ways of how, if we're going to utilize this perhaps in a public capacity, how do we mitigate somebody doing those sorts of things? It's not an easy problem. So while there are things that can certainly mitigate it, and I've gone through some of the more advanced details, I'd say security when it comes to AI and IoT types of solutions is probably one of the bigger, harder challenges of today. So if you do have an interest in that particular field, there's definitely, it's not something that's going to be solved overnight, and it's not going to be something that's solved one way. It'll always be different for every solution.
Yeah, well, one of the things, if you think from a city government perspective or even a state government perspective, we have enough bureaucracy that prevents innovation at the speed of light, right? So you have to get budgets, approvals, you know, commissioners and councilmen or women have to get together to do these decision making. And what happens in that space is some of that context that looks great on a white paper or academic research does not get implemented. And one of the things that I advocate, both in the commercial space and as the consumer space, is the need to change fast when something like that happens. And what I mean by that is, like, you could have edge competing devices that can be multiple brands and multiple makes. Now, in a legacy mindset, you would have to have a technician or an expert for each of those kinds. And we've seen this in the commercial space a lot. Think of the SCADA network, the protected network for electric power distribution or gas distribution. Because they couldn't solve a lot of things, they put an air gap. And what does that mean? They actually made these systems not accessible on the internet because they couldn't solve for it, right? So they created an air gap saying that, hey, if you know, foreign nation's going to attack us, they won't get the last mile because there's an air gap. Well, those foreign nations might find a way to get inside the network by using human assets to go corrupt it. And you know, we Americans have stories of doing that to our foreign enemy states, where we actually send somebody with a USB drive and then you corrupt that system. So when you think of that, the ability to change fast, the agile workforce is what is really important. So if I have 5 different computer systems in the edge scenario and I want to go really fast and change them out, yes, I need to know what they are. That's the easy part. But you can actually build some intelligence in it with some fail safes. We do these in industrial machines all the time. For example, if we have a light switch, an intelligent traffic light controller, and it hasn't been able to call back home for, say, half hour, we can build intelligence that says shut down. You know, shut down, change the traffic light to a blinking red, get a congestion, a cop comes over and realizes the traffic light is broken, they call somebody to go fix it. But if you build that intelligence in there, now you can have a resiliency of that smart device saying that I couldn't call home, therefore I'm going to shut down. And, or you can say, hey, I've been able to connect, but I haven't gotten an update for a certain amount of time. So after a certain amount of time, I'm just going to not do anything. I'm going to shut down. You put these fail safes in there to make this resiliency. But what does that mean from the workforce perspective, a technology perspective? You may have generation of devices and technologies that you have to manage and maintain. So the agility of how fast you can do that and keep up with it is actually where you invest time and money. Don't look at, I have 20,000 devices, I have to go call Dell and get all of them. You don't. Figure out what it is, the bare minimum that you need to do. And that's one of the things that we can today exist with iPhones and Android devices. It's a phone. We can call from one place to another. It's a smart device. I can do Twitter and Facebook and all that work. So think of a company like Facebook. They developed an app independent of the operating system on the other end. They said, we need to deploy changes fast and quick. Let's work on that. How fast I can do it. If you have an app like Facebook, you'll notice it gets updated every day. And you think about it, is that bad that you have to update it every day? No. They're making changes on it every day so that they can deploy it every day. It's not that it's broken. They're just making changes, color schemes, we had new Easter bunnies and stuff like that during holiday season. That is where the workforce empowerment comes from. That is a human capital experience. You have to be agile to be able to maintain these smart city devices in a way that even if 20 years have passed since the last one and the first one, the functionality is the same and the people that can go manage these fast and quick without getting stuck in a vendor locked device or a product that is no longer available. So resiliency in a cityscape has to take that into account. That I need to have a workforce that can pivot really fast with technology and learning and basis of that.
That was a great question. And I want to make a few comments on that too. If you think the big problem that you have there, it's a balance between processing power and security. It's always that, right? And the other thing is code always has bugs. So if you look at a car, you have 100 million lines of code. The ratio there is you have 15,000 bugs, right? And so when it comes to a car, it's really a mini cloud inside, right? And you'll have the chips that keep the keys, the enclave, and they sign things, right? But it's a balance of how do you segment all the processing, how does it go back, how much do you store? So there's always a challenge between performance and security, and it doesn't matter how small it is or if it's at the cloud or, So another question?
Great conversation. I really enjoyed it. My name is Jan Odegaard. I'm at the ION in Houston, but more importantly, the previous talk opened about sort of responsible AI and all of that. Ultimately, it comes down to trust because I had to trust him that he didn't save that video. Didn't matter what he said that, and I actually do trust him, but how do we build trust in these systems? Because it's not nice to say, yeah, I'm ethical, I'm responsible, and all of those things, but every camera in front of that bus, there's going to be people in it. What's the trust relationship I have with anybody standing up a corporate? And maybe I have more trust with a Microsoft than I have with a person just starting a company that's got one person show because they're desperate to create traction and build something. So can you have somebody address a little bit how you approach that trust?
That's a really great question. And just to dive into what he's sort of hinting at here, when we talk about responsible AI, AI can do a lot of good, but unfortunately, the way these things learn behind the scenes, especially if they're algorithms that are training themselves using things like deep learning methods, they can actually induce biases into their results, or they're, leveraging, I guess, what you could think as ways of getting to the answer that may not necessarily be fair for all people that are involved. Examples of this have certainly included in the past just through text mining, looking at resumes that go into companies that were getting flagged based on just certain things that people would have inside the resume. Maybe it was just kicking someone out because of a GPA, or it saw that they went to a certain type of college that wasn't on the list of approved ones, and these things are just getting flagged. It's the same type of bias that you would see just in general life. And so how do we actually mitigate those sort of things is, number one, having a commitment to that sort of thing, where if you're building these types of solutions, that you do always sort of employ a bit of a stance that you're going to try to build something that is fair and is not going to have consequences of privacy or unfairness or bias that's introduced. Now, this can't always be controlled based on how things are being trained. It's an interesting point that you made there, drawing distinctions between large companies and small companies and how they do this. So I'll go on the record and say that for Microsoft as a very big company, one of the reasons that we have to have a responsible AI mission is because if we did build something that went haywire, it would be terrible PR across the entire company. In fact, this has happened to us once before. I don't know if you remember the Tay Twitter bot that was able to be, we basically let a bot be programmed by whatever people tweeted to it. So if they tweeted it terrible things, it would say terrible things back. So classic example there, very quickly removed, but it serves as a great example and a great learning lesson as to what happens when you open up these systems to be able to be influenced in those sort of ways. But it's funny because you also mentioned that down at the smaller level that I felt like there was some implication when you said that they might be willing to let certain things go because they don't have as much to lose or they have to prove something. And this is one of the things that gets interesting. How much is what we're doing actually legal when it comes to especially computer vision types of systems? You know, if you're employing these in the medical industry, there's probably different things that you have to pay attention to. If you're employing these in different countries, for example, where, you know, GDPR or something is employed, how do you facilitate those? And what I've found working with startups that do work in the AI space, a lot of times what happens is they find out the hard way. They'll build something. Typically, when you're asking for trouble in the computer vision spaces, if it has facial recognition involved in it. So I won't name the company, but they were basically using faces as tickets to get into events. And that's not really allowed in certain countries. In fact, like very big name countries, I won't, you know, have to go off the list here, just won't let you do that. So you can't just come up with these ideas and employ these things and use them in a however you want to do. It comes back to the fact that really with all things that we do in life, there is some level of moral responsibility, ethical responsibility, et cetera. And I would recommend that if there is a college course for any of the students here that focuses on that, definitely pay attention to these because if these things go into the wrong hands and they're doing the wrong things, they can actually end up causing harm. So there's not an answer to this. It's more of a how we solve this problem is by being conscious of it and implementing that awareness where we can to ensure that we're creating fair and just systems when AI is involved.
I'll add to that a little bit, maybe push back slightly against Jan or just a different perspective, which is I think for some of the small companies, they potentially have the advantage of making their sort of value proposition being privacy and trust around some of this stuff. It's very hard. I think gaining trust is incredibly difficult. Losing trust is incredibly easy, of course. But you know, I did some work with one company that is centered on privacy, and they asked me about building a machine learning algorithm with their data. And you know, they give me the data, and I look at it, and I said, you know, is this all the data? And they said, yes. And I said, this is really all the data. You're not collecting any more than this. And they said, no. And I basically said, yeah, you can't build a machine learning algorithm with this. But coming away from it, you know, I was you know, disappointed that couldn't solve their problem, but I was actually reassured that they really actually were not collecting the data they said that they were not doing. And so I think there's potential there to do stuff. And you know, there's questions about how transparent can you reasonably be? I mean, you put your entire algorithm or training data set out there. In some cases that could work. In other cases, you know, that's giving away the company secrets right there. So there's a lot of trade-offs that people have to come up with. But yeah, so but like the earlier response, because there's no clear response, and it's very, but you know, it's something that people need to push on hard. And I think it's our responsibility as people in the industry, but also as sort of subjects, even maybe not even users, just sort of subjects out there that we need to push against this and to make sure that there is at least an ongoing discussion about, you know, how do we do things in a way that is protecting privacy is fair and you know, we'll get the trust so that we can get the benefits without too many downsides.
Yeah, I would like to add to that a little bit. So AI and ethics, I equate that to medical science and ethics, right? There are parts of the world where a medical researcher may combine animal DNA with human DNA. Well, there are parts of the world where that's not allowed. So that the last mile of the ethic is really about the entity, the humanity, the culture, and what you're going to do with it or not going to do with it. All countries have riddled histories about being on both sides of it. Some have experimented in a negative way, some have experimented in a positive way to benefit humanity, right? So it will change, it'll morph. If you were to move away from science and talk about geopolitics or ethics, and you'll realize we as human species give away a lot of our privacy compliance, and sometimes we pull back, and it's really a moving target. It's not really able to be gauged. But in computing world, I use what Paul said, their companies have to have a moral soul at the end of it, right? I'm doing a project at Microsoft, I don't know, Paul, if you've done that, where we have ability to, whatever I say in a written format, to be created into a video using my face and my voice without me having recorded it, right? So we have this cognitive service and video service that can do that. For me as an internal employee to ask for permission to even play with it required me to sign like a multi-page agreement that says I will not have malicious intent with it. And if you think about it, if you go into Twitterverse and look at it, there's this video of Tom Cruise speaking in Spanish, right? Nobody asked Tom Cruise for the permission of his video and likeness, nor did the person that's speaking Spanish behind the voice gave permission. Somebody created it, it looks funny, it's cool, it's comical, but there's malicious intent there as well if you use it incorrectly. So at a company like Microsoft said, hey, any company, including the customers, if they want to use those APIs and those gadgets, they have to comply to, at the end of the day, a legal document or a compliance document that we have put out there. There are parts of the world that don't do that. There's a country in the world today that due to the heightened security and terrorist impact that they have, they allow in the airports, but you don't have to take your shoes off. You don't have to go to a TSA line, but they use video images to look at your face and kind of interpret your intent. Imagine the science that goes behind it, but this country needs it because their security is always at jeopardy. But there's another country using the same technology that monitors their citizens with that to see if you're going to have malicious intent. I'm like, that's policing in a negative way versus securing the fact that you're going to get impacted by terrorist attacks versus one that just wants to know what you're doing all the time. I remember years ago, I worked at a company that had a closet in the computer room that was always locked. And I was like, hey, what's that? I was like, oh, that belongs to a major telecom company. I was like, why is it always locked? I was like, don't ask. I'm like, why? I want to see what's in behind. It's like, don't ask, don't tell, you'll get in trouble. But it turns out even friendly states, friendly governments, friendly companies are harvesting a fair amount of things for supposedly protecting our security and nation security. But what if they're not? And we've heard those stories. You know, you've heard of somebody that says you're collecting data on the phone and text messages, and then some whistleblower goes out there, and then you realize that was wrong and incorrectly done. We pass laws and rules to do that. So the AI ethics and medical ethics are very similar. You have to have an ethical soul to figure out if that is the right thing to do or wrong thing to do. If you're thinking it's the right thing to do in the wrong context, you know, there's a lot of movies that talk about all the fallout that happens for things like that. So it's really a slippery slope, and it'll be a moving target. There'll be no science that will ever fix that.
There's actually a correlation between your question about trust and that gentleman's question about security. There's no answer. There's no guarantee. What we can do is deterrence, 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 right? Have you heard about GDPR, the regulatory European compliance for data protection? What is it? It's a deterrent. It's not going to prevent a bad actor from coming up with your trust, right? But it is a deterrence. Look, it's a catch-22. I need your data to help. Unfortunately, I can use that same data for a wrongful purpose. It is. So all we can do is build deterrence. The PR situation, loss of reputation. What is it? Deterrence. A determined bad actor, whether in terms of trust or security, can still do damage. I have all these security cameras and Ring and all that in my house. Do you think it's foolproof and I can guarantee somebody not still break in? I can't guarantee that. That's why I have home insurance and life insurance, right? So I think deterrence is
All right. Well, that was incredible, y'all. So we'll take a quick 5-minute break, and then we'll come back and we'll do a presentation and have lunch. But please give them a really loud round. Thank you. Thank you so much, y'all.
Mr. Valerio, this is Mario Aguilar. Can you hear me?
Yes, I can. Can you hear me?
Absolutely, I can. Give me a quick second. I'm gonna get everything set up.
All right. Can you see my slides?
I can see your slides.
Okay, awesome.
Bear with me as I get everything all prepared for you. Okay, Mr. Valerio, you have the stage. We're ready to go.
Thank you, Mario. Hello, everybody. I am Gerard Valerio with UiPath, and my presentation today is on the future of work and the automation and AI ML opportunity. No process left behind. So who am I? I'd like to leave you with some memorable aspects of who I am. Life is full of learning and life experiences. Some of the experiences that have been meaningful in my life includes having an audition for a reality TV show. So for some of those who probably know The Apprentice, that's also probably dating myself as well. I love dogs, and I've actually given birth to a litter of dogs. I've also side hustled as an adjunct professor and data science bootcamp instructor. And then just for kicks, I've done also skydiving tandem over the farm fields outside of Chicago. And I've also ziplined solo down a Maui mountainside. So let's talk about automation and the impact that automation has on society. So if we take a look at global productivity, automation has the ability to improve productivity and make productivity growth greater than 50%. It also has the ability to improve job satisfaction by 50% as well, by taking mundane work or repetitive tasks that we all find a bore or a chore and automating them. And when we take a look at the impact to the workforce, automation actually has the opportunity to generate 60 million jobs, which translates actually in increasing the capacity of the workforce to make it feel like there's been 2.3 billion impact to the workforce. And so one of the thoughts around automation is that there's this fear that it will take away jobs, that it will basically eliminate jobs. And the reality is it does quite the opposite. It actually frees us up to be able to focus on higher value tasks and really focus on things that hopefully bring us greater career progression as well as greater career joy. So interesting aspect about automation and productivity. So what you see here is just basically the growth or the trend of productivity. And you can see that there are times when productivity has experienced gains, like in the 1980s. And then you can see that it kind of flattened out during the 1990s and then took a peak in the 2000s and then also decreased since then. And if we take a look at kind of what has happened, a lot of it is actually related to technology trends. So the early productivity gains were because of computing power related to the mainframes and actually the PC. So that's why you see kind of that uptick. And then fast forward to the 1990s, we now have applications that are helping with things like supply chain management, ERP or enterprise resource planning, finance applications. And so, productivity kind of levels out while businesses learn to take advantage of all of that. And that's also where, we move from very simplistic interfaces of yesterday to now GUI based, and basically people are getting acclimated to using Windows and graphical user interfaces. And then in the 2000s, we kind of find all of a sudden this scenario where essentially productivity starts decreasing over time. And what we do know that's happened from the 2000s forward is that we've seen the rise of the internet, greater use and adoption of mobile, and also cloud. So if we take a look at this and peel it back, what we actually see is what we refer to as the productivity growth chasm, which is up until the 2000s, a lot of tech and work was much more simpler, a lot easier, and we were able to learn and adapt to it. Fast forward where we now have so much technology coming our way that is basically helping streamline our things. We're finding now that we're in a more overwhelming and disconnected tech environment, and things seem more complex. So again, this is where we see this disconnect between the simple and easy to manage tech from prior to 2000s, and then the more sophisticated and also variety of tech that we're also utilizing post 2000. So why has this happened and what can we do? So if we think about the world today, there's millions of manual processes that are essentially being done across businesses and organizations. And as I mentioned at the very beginning, it's shown a decline in productivity growth by over 50%. And then there's a lot of time that is spent on the order of the magnitude of 10 billion plus on manual, mundane, repetitive tasks. And in the same time frame, over the last 4 years, there's been more than a 70% increase in applications that companies are adopting as part of their efforts to, modernize IT or otherwise achieve what we refer to as digital transformation. And the reality is organizations face a lot of different applications that they're trying to interconnect and work together. Things like financial close and reporting, where you might have systems that are in SAP, Salesforce, NetSuite, or if you're in the health and human services arena dealing with clinical trials and patient management and all of the different types of applications and data that are interconnected, or you're otherwise dealing in the financial markets with deal analysis and execution. Again, a variety of different applications that you might be using, or even simply in the HR world, where you're talking about basic things as managing your workforce, taking care of paychecks to signing digital documents. All of this, all the complexity is actually what's contributing to, again, people having to work with more systems, work with more data, and then trying to still get their regular day job done as well, in addition to all of these other administrative tasks. So automation has the ability to deliver so much of the work we don't like doing. And so UiPath brings to the table the ability to take automation plus artificial intelligence and machine learning to do everything from leveraging basically the ability to screen scrape applications, so AI and computer vision to read the screens, to suggesting to business analysts or IT administrators what actions take next by essentially using AI ML models, and then also automating the interaction across all of these applications to, again, replace mundane human tasks that otherwise take away from people's ability to focus on better and higher use of their time. So in 2017, McKinsey basically stated that automation is a new wave of opportunity that can actually, through the use of robotics, machine learning, and AI, essentially help organizations realize substantial performance gains and really take, the focus on productivity as well as the outcomes and the missions that they're focused on to another level. And so back in 2017, automation was deemed as the next disruption of work. Fast forward now to 2022, automation is the now disruption of work. And that is where we feel that automation really can truly benefit organizations. So if we take a look at different markets of disruption, when you take a look at, for example, internet first, right? Bookstores versus Amazon. In the early days, bookstores like Borders or Barnes were thriving, but then came along a new disruptive model that was based on the internet where people now could like do self-service, interact with each other through recommendations that are driven by people being able to rate the books they read or anything else that they buy, and then that has created basically the new normal for the book industry or even retail, basically allowing Amazon to thrive, whereas the retailers that are still stuck in the traditional bricks and mortar have struggled to survive. Same with the disruption in the mobile when it comes to the taxi industry, or where you have basically a company like Uber that's leveraged a mobile first, again, leading to self-service and making it the whole experience of getting access to transportation on demand to be able to get to point A to point B. And that has also essentially changed the taxi industry to rethink how they operate. And same thing with cloud first. So Blockbuster used to be, in their heydays during the 80s and the 90s, the source for where people would go to videos. And now with the cloud and the ability to stream, Netflix disrupted that industry and is now able to bring content on demand through streaming that people can then just essentially choose what they want and pay for it all in a self-service fashion. And automation has the same to do, basically benefit organizations. There will be organizations that will adopt automation as a competitive edge and hopefully break into new markets, new levels of performance. And then there will those that will, unfortunately or regrettably, struggle to survive. So when we think about automation and what UiPath advocates, it's about automation first. Basically thinking about how to reimagine work, the work processes, by leading with automation as part of the design, as part of the thought of continuous improvement. And essentially at the core of that is, if some particular task in an organization can be automated, it should be automated. It will again improve productivity. It will allow individuals in an organization to focus on better and higher value use of their time, and hopefully also improve their experience, their engagement, whether it's at the customer level, the partner level, or the employee level. So benefits of automation in general is about driving speed and efficiency, improving the experience of customers, employees, and partners, as well as the convenience. It translates essentially into increased revenue and lower costs. It also means that there's money and time saved. And also from a business management, business risk perspective, it's also about reducing compliance risk. So for the next 10 minutes, I'm going to share two videos. The first one is a UI platform tour, which is 3 minutes, and then taking that and showing how organizations can start with automation plus AI ML using UiPath's platform. Next, I'd like to share with you how easy it is for organizations to adopt UiPath. UiPath gives the ability to actually get started easily with identifying what to automate within an organization. It can then also capture what others are also identifying as they do their own analysis on processes that they're responsible for, and then can help organizations prioritize based on impact of the organization, even cost savings, time savings, and then really get the organization going on an automation journey to help with their digital transformation. So I would like to leave everyone with a closing thought regarding the opportunity of automation. So there are only so many hours in the day and so many years in your career. Make them count and make them matter. This is where leveraging automation in your day-to-day job can help you shift and reboot work so that you can free yourself from mundane and repetitive tasks using automation and AI ML to then spend your time with better and higher value use of your time, hopefully with progressing your career, and otherwise doing things that give you joy in your work. It's easy to learn about automation, the UI pathway. The whole opportunity to learn automation can be easily done by going to the UiPath Academy, where you can learn for free. You can also get access to Studio X, which is the citizen developer version that allows you to actually even automate stuff in your personal world as well. You can download Studio X and create a digital assistant that can then take repetitive tasks that you do personally or at work to help you streamline those type of activities. So I'd like to pause there and open the floor to questions, Mario.
Absolutely. We have two questions. The first question is going to be from one of the students here at HEC. They work at Apple, the retail store, and they were stating that they have about 3 to 4 different devices that they take home and they're constantly on. How would you recommend to leave all that alone and try to get some sort of, you know, disconnect from all those computer items they have on?
So that's actually one of the great things about an automation platform, right? It can interact with applications and different devices. So if there is something that is critically important that they want to automate and have taken care of so they don't have to take care of those devices, they could create the automation, schedule it, kick it off, leave the devices back at work, and then hopefully come back in the following day and get a confirmation that what they needed to do was already taken care of for them.
Understood. Got that. And the second question, it's more of a kind of a personal question. The students are asking that they noticed that you were trying to get on TV at a certain point, that you were trying to be one of the contestants.
The
Am I correct on
Apprentice.
that?
Yeah, that's an interesting question.
So what they're asking is, with the cell phones being so easily accessible and platforms like Facebook and Instagram, and you know how you could get real viral videos going on, what would you recommend for them to be on something like that, where they have to disconnect every once in a while so it doesn't become like an ego trip to them?
Well, that's a great question. So I think the question you have to ask yourself is, what do you want your brand to be? So in today's working world, especially what I found in my career has spanned multiple decades. The latest shift is how do you get seen, especially in a world where there's just a lot of, I'll call it noise, right? There's different channels and avenues to express yourself, even at work. So you can use one or you can use multiple platforms and just basically think about, what do I want to be known for, and focus on that. So if you want to be a thought leader on a particular topic, whether it's AI, ML, or automation, you know, come up with the content and then share that, kind of build your own community, or as they call it, followers. In this world, that this digital age today, all of us in some shape or form, in order to be able to interact with our colleagues, have, undoubtedly are building our own brand, and we can use those platforms, whether it's LinkedIn or Instagram or Twitter, even TikTok, from a professional perspective to get known. Part of the aspect too is share something for free and contribute to the community. That's how you get known, and that's how you'll also get appreciated and recognized.
Awesome, just awesome. Thank you so much for your presentation. I'm hoping that I could get those slides so I can present them to our students here. And if and from the bottom of our hearts here at HCC and CSA, thank you so much.
Thank you.
Ms. Yanzu,
Hello?
can you hear me?
Yes, can everyone hear me?
Yes, give me a quick second. We're going to set everything up, okay?
Okay.
All right, Ms. Yansu. My name is Mario Aguilar. I am the chief representative here at HCC Computer Science Association. I want to thank you for coming in, and the stage is now officially yours.
All right. Thank you for the invitation. And today my topic is AI for the people. I know, I guess the conference, has lots of topics about automations, right? We just heard one before me. And about how AI can boost efficiency and improve the running performance. So this topic, I think I will mainly focus on how AI and people together makes our system even better. And a brief introduction about me. I'm a data science manager at PROS. And PROS is a company headquartered in Houston. And in my spare time, I'm also the organizer of Houston Machine Learning Meetup. So first, briefly about PROS. So we are a 35 years software company headquartered in Houston. And our main focus is AI for commerce. And we are public listed as PRO. And we are about 1,400 employees in 9 worldwide offices. And we serve many companies. And we serve a variety of industries such as automotive, B2B, chemicals, food, healthcare, technology, and travel, such as airlines and hotels. So very interesting numbers of PROS. So PROS system impact more than half of global airline passenger traffic. So if you are ever purchase an airline ticket, it's most likely is priced by a PROS system. And we have more than 200 million prices updated daily. And we generate more daily forecast models than tweets. So just think about the scale of forecasting models that we have at PROS. Back to the presentation, AI for the people. So what is this really about, right? So it's like AI plus people, and we hope like all together, we can make more accurate predictions. And we can understand each other better, right? So the AI kind of understand the requests from the users, and also the user can understand what AI is really doing based on the data. So this way we can build a trustworthy system, and we can close business faster and drive revenue growth. So here is a flow chart of showing how human plays a role in the AI process. So in the beginning, we humans generate lots of data, right? So we are users on the internet, and And actually, the majority of the data, and of course, there's a large portion generated by the machines, but also a large portion of data is generated by humans. And we also label the data, right? So like for classification and for regression. And also we create features for the machine learning system to use. And next, we move on to model configuration, where we set the initial settings for the models, and all those parameters, the hyperparameters that's required for a model in place. And next is model training, right? So there's this, which model to use, or maybe we can even create an example of models to improve the accuracy. And next comes to the model evaluation. So we have lots of technical metrics for different tasks. And what is more important in business is how can we relate these technical metrics to business metrics. And sometimes things don't go well, right? And there are lots of extreme cases of data points to cover in reality. So there will be an exception handling an AI system to make it more robust to different cases or different scenarios to handle. And last, I think is very important is the model interpretation part, right? So I know machine learning model is getting more and more complicated and more advanced. And sometimes it's really hard to understand, why the output is this, why it's not the other way, right? So model interpretation plays a very important role to help us inspect the model, right? To see if there's any thing goes wrong, and also to maintain the fairness in the model so that we want to make sure that the models don't generate bias. And in the end, can, to make a trustworthy prediction from the AI system. So within the loop, I think it's trust. And trust is very important for any business, especially for the AI models to get adopted. And next is more from a system level of view, like what is a machine learning system, like major components, and how human plays a role in that, right? And so first we collect our data. So there's a big data storage system. And then there's a machine learning pipeline on our optimization models. And out of that is basically, it recommends some decisions, recommends some numbers. And based on that decisions from the machine, the humans needs to take actions, right? Shall I increase the prices or decrease the prices? And, shall I take the opportunity or take the recommendation or not, right? So I think we plays a large role in taking actions according to the outputs by the machine learning system. And once we take the action, we usually observe the outcome, which can be the revenue or that. So I think many of these steps, many of these components, they are still pretty manual. And I know there's AutoML coming up, but still, in order for them to really to get into production, many of these processes are still manual. So how can we make it more and more automated, right? So I think the way to do that is how can we learn from the feedbacks? So once we observe the outcome, and how can we let the machine learning pipeline to learn from the feedback? Right, so the feedback may tell us, okay, we need maybe more information. We need to connect to more data sources. And in the machine learning pipeline, this decision, maybe we need some user behavior modeling so that it fits our business logics better. And once we establish this feedback loop, many of these processes can be more automated and with less and less human intervene in the system, so that it really meet our needs. Okay, so next, I think I will walk into some examples of how we are going to achieve this. Right, so first, I think I'm going to show example of how can we do a model training for the user behavior modeling. Well, I think one of the most straightforward way is just do a direct modeling, right? So you have your features. So it can be a transaction feature, your user profiles, or any external data sources, such as the weather, right? And then we can train a supervised model, basically map from our input space to the target space, which can be the user labels or numerical values, such as the demand, right? The airline demand, and also the user feedbacks. The users can give accept or reject or thumbs up or down, and then we can take that feedback and learn from that. So we can build a supervised model to directly learn from the targets. So one of this is the simple model is the decision tree. So I guess many of you may already use that, right? So it's very intuitive, and it's basically automatically generate rules to create these homogeneous groups at the leaf level. So this just showing a simple example of, say, whether you will drive a car to a restaurant or you will walk to a restaurant. So it will based on the weather, right? Whether it rains or not, it will based on the distance and also how hungry you are. So at each node, decision node, so each node is a decision, right? So you will automatically figure out how to split the data set. So here is, if it's larger than 1 mile, you will drive a car. And if it's smaller than 1 mile, and if you are hungry, not that hungry, you may choose to walk over there. And all these rules and the tree will be generated automatically from the data connected. So that is one of the direct modeling. So next I will talk about more of this interactive modeling. So here, say we have two data points, like the data points from two classes, right? Green and red. And we want to learn a boundary to split these two groups. Well, say in the beginning, we don't have all these labels, right? So we don't have this green and red. And then what is the cheapest way to label the data and train a model on that, right? And getting all the labels will be very expensive or time consuming. So how about we just, sample a few data points and ask people to label them. So this may, what it looks like in the beginning, right? So we just randomly sample some data points, and these are the labels from the users. So it's not a lot to label, right? And then we train a model just based on these samples. So this is the classifier we learned in the beginning. And it's not perfect, right? Because the data points, the samples are not that perfect. Well, once we learn this, we kind of know about approximately where the boundary is. So why not we just sample or mainly focus on the boundary region and sample another round of data points. So here we are going to select better samples, and we will train a model again. And this way, it will refine the boundaries iteratively, right? So here you see the sample data points were more around the boundaries, and then the boundary learned from the model will get closer and closer to the ground truth. So here is a way of interactive learning, like how system kind of learns interactively, ask for labels from the users, and the user gives the output, and the model updates itself and asks the users again, right? This way is kind of solve the problem that when all labels are not expensive, will it be expensive, and how we can make it cheaper, right? Without asking the labels for all data points, but just mainly focus on the sample points around the boundaries. Okay, and last I want to talk about the model interpretation functions. So on the model interpretation, I think the goals of model interpretation, or what we can gain from it, is the first is trust. I think I mentioned trust many times. So the trust is about, does my model really work? Is it really relying on reliable features, right? So is it really match with business needs? And also the insights of what is my model doing, right? So we want to, although it will be complicated, but we still want to know, how the model comes up with that prediction. And last is improve. Say if you learn from the interpretation that, okay, this is not to what our expected, and then how can I fix the model so that it meets our expectations and remove the bias from the model. So usually there's a trade-off between the model prediction power and interpretability, right? So usually as the prediction power increase, the interpretability of the model will decrease. And so can we use this end of model to help with the higher end? And the curve looks like this, right? So we're trying to, when we maintain the same level of accuracy or prediction power, we want to increase the interpretability of the model. Now, there are many models that are designed to solve this problem. So one is called laymen. So it's basically using local models to explain the global complex models. So if you just pick a very simple model in the beginning, it may not achieve very good result because the boundary you see over here, right? So it's very complex, non-convex boundaries. It's not, a simple model cannot fit the boundaries. So how about we train a global or so-called black box model, say neural network, and then we locally approximate it, right? So within this local region, we can easily fit a line over there, and we can use this line to tell what these boundaries looks like locally. And this is a paper published in KDD, and I think there's many evolutions based on this paper. And the key idea is use simple models to explain complex models. And here's a very interesting examples of Husky or Wolf, right? So this is an example from there. So it's the image classification problems. And it looks like, wow, there's only one mistake. So is the model doing a really good job? So after running this line, and you see these are image pixels that the model relies on to do the classification task. And you see that basically it's a snow detector. So whenever there's a snow in the background, it detects its wolf. So model interpretation can help us identify the biases in the data and the model. So the model is not doing a good job, even though the accuracy looks good on the surface, right? And another very powerful tool is called SHAP, right? So you can use this tool to generate additive explanations for the predicted values. Say here is a Boston housing price prediction task, right? So you have these features, and this is the final, say, normalized house prices. And then you train some complicated models to predict that prices. And then you can ask the model, like, why is this number, right? So you can start from some global average. Say the global averagely, the house price is this much. And then you see this negative or positive impact from all these features, right? And this basically it looks like it's just a linear model, right? Just to explain this number. So you know like what feature is really important and how much positive impact or negative impact it has. You can also use that to explain the result for the images. So whether it's a dog features or meerkat. So the red is the positive impact of the pixels and the blue is the negative, right? So you see that it really relies on the faces of the animals to detect it's a meerkat, and also it relies on the head and this, to detect it's the type of the bird. So I think I have last 5 minutes. I want to show a quick real business use cases. It's a product called opportunity detection for B2B sales within pros. The motivation for this is the sales reps spend lots of their time researching on the sales opportunities, right? So majority of their time is searching for these opportunities. So how about we design a system and identify these sales opportunities for them? And these are the 3 major sales opportunities, such as declining, say there's a consistent revenue like in the past, but suddenly the revenue decreased this month. So shall the salesperson reach out and see what happened? And also the inconsistent purchase and also the gap. So gap is kind of like the in B2C world, like the Amazon, right? So when you purchase these, you see some recommendation from Amazon, you may also like this. So this is the same thing, but in B2B world. We want to recommend products that their customers may also want to purchase. So here, whenever we recommend these opportunities, we have this button of accept or reject. So the users can actually click on that and then let the system know whether this opportunity recommended is accepted or not. Right. So we learned from this study that both the data, the transaction data, and the user feedbacks are equally important to make meaningful recommendations. And before we modeling this user feedback, accept or reject, we see that like 65 of our opportunities kind of get accepted by the users. And after we explicitly modeling the user feedback, it increases to 82%. So users actually favor our system more. So learning from the user feedbacks increases the acceptance rate of the recommended opportunities. Okay, so the final key takeaways. So what I want to take home with you today is first, data is the key, right? Just start connecting data right away. Like whenever you trying to design the AI pipeline, like for any use cases, first of all, always think about what data you have and how can we get started connecting them, both the data and user feedback. And secondly, pick a function that requires lots of user input right now and trying to automate that, because this is usually the place where you can get the most efficiency. And usually AI plus people gets you the best accuracy. I don't think we really, or in some specific scenarios, I don't think we never want people out of the AI system, because it's just not the way to do it according to our observations, right? So according to our observation is, you have some part of automations, but you still need people to guide the system to your business needs. And AI plus people usually gets us the best accuracy. And we can start simple. So when I just showed that AI system, that loop, right? The loop from the feedback, learning from the feedback. So that is a loop. You can build a simple system in the beginning. And once that loop is established, this system will evolve and learn over time. And AI itself can build trust with the people, right? So never ends with, okay, this is it. This is the most complicated algorithm model that I have ever proposed or researched or in the past, and that's it. That's not the end. The final round is always about, model interpretation. Think about how, to help the AI system gain trust from people, so that we can utilize it better, so that we can remove the bias and bring fairness, to the AI system. Yeah, that's all of my talk today. And again, I want to, of course, bring back, my employer, PROS, here, and it's also a great place to work in various kinds of countries. And check us out, the products and also the career opportunities at PROS. And last but not the least, I want to mention the meetup that I'm organizing right in Houston, the Houston Machine Learning Meetup. And right now we are 2,000 members strong, and we are very active, to talk about all different kinds of use cases, different kinds of models. And also, if you want to contribute a talk to the ML community in Houston, feel free to reach out, and we are happy to arrange a meetup for you as well. Yeah, that's it. Thank you. And I'm happy to take any question.
Thank you so much for that. We will be participating in the meetup. We're going to see if we could get some of our representatives there with you. We do have one question. It's kind of a big question. And it is from one of our students. Her name is Amira. She is from Pakistan. She is the first woman that is going to be learning AI here at HCC. Her question is, being not from the US and not knowing a lot of people, how can she network and participate in a lot of different things when she doesn't know anyone here? And
Well,
being a woman, she is a little bit different compared to everyone else, of course. She understands that it is kind of a male saturated environment. So she wants to know how she could stick out and be different from everyone else.
Yeah, so yeah, I think that's a very good questions, and I think I will try my best to give you that answer. So I think the first question, I think the answer is very straightforward, the meetup, right? So in the meetup, you can meet, people from, different companies or from different schools, different majors. I think this is really a great place to, get started, to get connected to people. I think this is also the reason why I start this meetup, because like 5 or 6 years ago, when AI is still not this, hot topic, I want to get connected to people in a similar background or connected to people who have the same passion with me in AI and machine learning. That's why I started this meetup, and right now I know, so many people, it's a very, like from 5 years ago to now is, the community grows much larger and larger, right? So I think the meetup is a great place, and not just Houston machine learning meetup, also we have the Houston data science meetup and the data visualization meetup. Like you can find all kinds of meetups there, and it's a great place to meet people mind alike. So that's the first. So the second question, well, actually, I don't really feel it's a male-dominated field, especially, at pros. So in the pros, the science team, I would say the maybe 70% to 30% in the science group. And right now I'm a data science manager, and actually I have two wonderful ladies, two wonderful data scientists, female data scientists in my team. Right, so I actually, maybe the most straightforward way to think about that is actually just forget about that bias. Just be yourself, right? And just get your voice heard. No matter is, I want to get connected to people. I want to, use this algorithm. I want to present something to others. Just forget about that, whether you are a female or male, right? I think just as I mentioned, the ML, we want to bring fairness to ML. And of course, we want to bring fairness to all the, job market and company places in that. Although technology is still like male engineers and male scientists still a large portion, but I do see like more and more females are getting more active in this field. Right, and actually, my manager is also a female. It's a senior director in science. So actually, I don't feel that difference or give me any pressure like that. So I never feel that way, and I hope you don't feel that way too. Here.
Thank you so much. So we need to be ourselves, go to the meetups, and network with people. And the last thing we have is, how can we connect with you?
Oh, how can I? So I think I can have my one quick way is, of course, the meetup. In the meetup, you can message me, right? And also you can search me through LinkedIn. Just search my full name. Just search my full name, and you can just get connected with me. So my full name is also just 5 letters. Should be very quick to search. And also my company email address. Yeah, just search this name in LinkedIn. It should be pop out very fast over there, and we can start there. And my company email is just yxu@pros.com. Just the first letters, yxu@pros.com.
Perfect. Thank you so much for participating. Thank you from the bottom of our hearts from HCC and the Computer Science Association. We will follow up and post on our social medias about the meetup and see if we could get some personnel out there to help you guys out. Is there, other than that, thank you so much and enjoy the rest of your day.
Thank you so much.
All right. So we'll get started with the panel discussion, AI and energy. We have a wonderful panel today, and I'm very excited about it. I know y'all been waiting for it. Aruna, sorry, your last name is long. Vishwanathan will be moderating, and enjoy.
Thank you so much. First of all, thank you all of you out there today to attend this event, and we look forward to a great session. This has been an exceptional conference. We've got a lot of questions that we're expecting from the audience, but you guys need to wake up because it is after lunch and it is now the Energy and AI panel. And we have got some great industry experts here who are going to talk to you about the areas that they have been working in and what they see for the future. My name is Aruna Viswanathan. I'm the co-founder and chief operating officer for Alpha X Decision Sciences. We are an energy AI software company. And I have a question for you guys. So the first is, how many of you are here in a industry capacity? You work for the oil and gas industry. Okay. We've got a couple. How many of you are university faculty or researchers? Okay, combination there. And students? All right, fantastic. All right, that will help us with our context of the answers here. And I'm going to start off by giving you a little bit of the difference between energy and AI versus tech, healthcare, and everything else that you've been hearing about at this conference. And that is that we deal with hard science problems. And in that, we have to, in applying artificial intelligence, unwind 100 years of physics. And that is a very interesting challenge in getting AI into the field. And I'm sure that that'll come up in our discussion today. But if you imagine the people that we work with, the geoscientists, the petrophysicists, the engineers, they've all been using physics. So we come in with a very different way of looking at how to solve problems. Now that's an interesting challenge, but here's a challenge we don't really deal with. We don't deal with problems related to, for example, bias in diversity, inclusion, or equity, because we're dealing with hard science problems. So for those of you who love hard science, you're in the right place. Now, our panelists, the way we're going to do this is I'm going to introduce a panelist, and then we're going to have them give context and answer the question. And then we're going to go panelist to panelist like that. And so we're going to start with Dr. Phanindra Kondapi, who is here to my immediate left. He is both an academic and a subject matter expert from the industry, having worked in oil and gas for over 20 years at FMC, KBR, and Wood. He is also the founder and CEO of Digitide.ai, which specializes in Industry 4.0 solutions. So students who don't know what 4.0 is, you definitely need to learn about that. He is a member of UH Energy and an affiliate faculty of the Colorado School of Mines, and the founding director and assistant dean for UH Katy campus. So Dr. Kondapi is a subject matter expert in subsea engineering and has served as the director of the Subsea Engineering Center and professor at Texas A&M University, and has been the recipient of numerous technical and professional awards. Welcome, Dr. Kondapi, to the panel. So our first question, a question that we're having everyone answer today is, can you give us your thoughts on a topic that is prescient to this industry, unique to energy, that we can share with the audience today?
Thank you, Aruna. That was a wonderful introduction. Yeah, as Aruna mentioned, my name is Phanindra Kondapi, and I work with University of Houston, as she mentioned, and I also started a company last year, that is Digitide.ai, which are specialized in Industry 4.0 solutions. So what Digitide.ai does is like basically coming up with the Industry 4.0 solutions for the energy industry, especially like remote monitoring performance solutions and energy management solutions, as well as digital logbooks and operational logbooks. So those kind of solutions that we do at Digitide.ai. And coming to your question, Aruna, so it's very interesting because right now we are in a phase, especially for the energy industry, where we are trying to do the digitalization transformation as well as AI, applying the AI into the energy industry. So if you compare with the other industries like healthcare or retail or especially the aerospace industry, the energy industry is still at the embryonic stage where we are still doing the baby steps towards the digitalization and the AI, using the AI applications. The reason behind that is because the oil and gas industry and especially any energy industry, if you take the downstream industries like refineries or petrochemical industries, any of these energy industries, they have complex operations. So that is one of the things. And the data that is coming out is humongous. So where you see the other operations of other verticals, you have the data, but in this particular energy sector, so the operations are also complex. So how do you come up with that, right? And what we are doing right now seeing is that we are going through the digitization to digitalization and then digital transformation process. And during the course, we are also trying to apply AI in that aspect. But the one other complex operation that we see during this process for this is like how do you integrate information technology and operations technology? So the additional component that is being added to the energy industry. So that is what is making more complex to the energy industry when we are talking about this AI, applying AI and digitalization. So during the course of this one, so how do we come up with that? So just to give you a note on that, so if you look at the last few hundred years, how the industrial evolution came up, right? First machinery evolution, which is the first industry revolution, industry 1.0, which we can call it now, right? And then came the technology revolution. So where we saw the airplanes, railroad, and the transportation, everything, and the manufacturing. And then came the digital revolution, which started around 1950s. So during the digital revolution, we saw the coming of the internet, process automation. So all these being applied until recently. And what we are seeing now is Industry 4.0. In the last 15 years, the way the technology has grown is tremendous compared to the last 100 years. So this Industry 4.0 is going to be actually outdated soon, and we are already talking about Industry 5.0. Right? And whereas the other industrial revolutions were like, they were lasting for 90 to 100 years. But this industrial revolution, what we are seeing, Industry 4.0, is very short. And then we are talking about Industry 5.0. So how do we cope up, especially the industry, energy industry? So there's a pressure on the energy industry to increase the efficiency, to have the connectivity between the IT and OT operations. So in order to do these things, we need to come up with innovative solutions, come up with newer models and newer algorithms to apply to make sure that energy industry is operating smoothly. So with that, I think I'll pass it on.
Thank you very much. And I think it bears understanding that every asset, whether it's a well or a windmill or a solar panel or anything out there in the field, is streaming data back. And that is what he's talking about, is streaming data real time. And that is that volumes and volumes of data that is being applied with AI on a consistent basis. Okay, thank you for that. Sunil Garg is the founder and CEO of Data Vedic, a Houston-based AI and machine learning startup. And they are building a hyper-converged data and analytics platform for the energy industry. Mr. Garg has a very deep understanding of oil and gas data, data science, and machine learning, undoubtedly gained through over 20 years growing the data management systems, big data and analytics businesses for Schlumberger, which is a major global oilfield services company, in their software integrated solutions area. And Sunil, thank you for joining us. He's a fellow board member at TI Houston with me. And that is an organization that fosters entrepreneurship through mentoring and networking. He's also an angel investor in startups. Sunil, we look forward to your thoughts.
Is it working? Yep. Okay. So, I primarily focus on two things, and both of these contribute to sustainable living. And when I talk about sustainable living, given my oil and gas background, right, people often ask me, you work in the oil and gas industry, so how is that sustainable living, right? So, and my answer to that is, this is the industry, oil and gas is one of the industries where we can make a major impact in terms of reducing the carbon footprint and the climate action impact that it has on the world. Why? Because it has also been one of the industries which has been contributing a whole lot to the carbon footprint around the world. Right? So that's one of the reasons to play in the industry. And a lot of the workflows, let's say, that I focus on are focused around optimization of the operations, reducing the cost of the operations, reducing the amount of chemicals that are used, prolonging the life of the equipment. If you think deeply about this, each one of these actually leads to the reduction of the carbon footprint of those operations. And oil and gas companies may or may not have looked at it the same way. Right? They always looked at these as a way to cut costs or to make more money. But given the ESG pressure in last 2-3 years, right, everybody has started looking at this and say, yep, this is also reducing my carbon footprint. So that's one side of my focus. The second one, which is more focus on the individuals and the families to motivate people to reduce their own carbon footprint. Because there is a lot of focus on, industries to say they should reduce the carbon emissions, they should reduce the carbon footprint. But unless every one of us contributes to it, your climate impact is not going to change, right? So every family needs to contribute to it. And that's where my second action comes basically at. And towards that goal, I'm a member of, Houston Climate Action, Mayor of Houston has a bunch of climate action subcommittees. I'm a member of a bunch of these subcommittees looking at how to motivate people, how to track their carbon footprints, and then how to reduce those carbon footprints. I also apply some of those actions, at my own level, in my family in terms of, optimizing our own energy consumption, reducing the waste that we generate, reducing the impact in terms of the landfill, what goes to the landfill by, reusing a whole lot of stuff, composting stuff, as well as recycling a whole lot of stuff, right? So those are the two focus areas that I have. And I think oil and gas industry, right, is one of the prime areas which will actually contribute to not only, just reducing the carbon footprint by optimizing their own operations, but you also see all of the oil and gas majors expanding into renewables. This is where the major investment towards the renewables in the wind industry, the solar farm industry, geothermal industry, this is where the major investment is coming from actually, right? Which is a very positive step overall. Right? So that's all I have right now.
Okay, folks, I hope that you're generating questions for the panelists. Sunil has touched on the fact that energy is not simply about oil and gas production, but it's also about managing issues around carbon footprint, managing issues around consumption, and also solar and even wind. So it's a very large industry as it relates to, of course, everyday impact for every one of us, which is, again, back to your point about how we look at our own footprint and what do we do individually. Okay, so we're going to have I'm sure, some very good questions for you coming up. We're going to move next to our third panelist. We have Becky Thomas, and Becky is the Chief Operating Officer for I2K Connect, and this is a software company that creates value from unstructured data. I've known Becky for about 2 decades now, and I can hardly believe it, right? She is actually one of the technology community's biggest champions. Really an honor to have you here. Her work experience spans over 25 years of commercializing technical software products from startup companies. And if you have not ever tried to commercialize a product from a startup company, you have no idea how incredibly difficult that is. She is responsible for the delivery of ITK Connect's AI platform within the energy industry, where it has been successfully implemented at the Society of Petroleum Engineers and also in Schlumberger's Delphi cognitive E&P environment. So congratulations with that. Becky is a very active volunteer and mentors young professionals as well. Thank you, Becky, for joining us.
Thank you, Aruna. It's great to be here. Great to be with the distinguished panelists that are joining us today. How many of you have a cell phone? Do you know how much data you create every day personally and how much you consume? Now, think about all of the businesses out there that are just in the energy industry, whether that's oil and gas all the way out to the utility companies that are putting the energy on the wire for us. Multiply that by 1 million times, and that's the kind of data volumes that we deal with on a day in and day out basis. So not only yourselves are part of this AI revolution that we're going through now, you're going to continue to contribute to it. So how many of you are interested in getting into a field of artificial intelligence in some form or fashion? So you know that there are very different disciplines that are available for you to focus on. And one of the free resources that I want to tell you about right now is a website called aitopics.org. This is a platform that our company donates to the Association for the Advancement of Artificial Intelligence. And that organization is called AAAI. And AAAI is one of the first organizations in the United States that was founded back in the early 70s that is about the dissemination and the peer review of all of the new things that are coming out from an artificial intelligence perspective. If there's one thing that you do, you need to go and subscribe to their weekly email, which is called AI Alerts. We wrote a really cool algorithm that will deliver 10 unbiased articles on the news of the week in the industry of artificial intelligence. So now let's talk about energy. How many of you drive an electric car? How many of you have solar in your homes? How many of you drive a gasoline-powered car? How many of you fly on an airplane? Okay, so there is going to be a continued dependency on hydrocarbons throughout our lifetime. You will continue to see the electrification of many things that we have in our industry. And from an artificial intelligence perspective, you're going to have the need for companies and products that we've just heard about from the two gentlemen here that are very data-centric, where data is, and I'm going to call it structured data, sensor data, all the data that's coming in from the different pieces of equipment that are out there. Maybe you've got robots that are out in the field because you don't want to send engineers out there and rise your risk of injury on the site. You may have information coming from engineers who are actually inputting it into a database or into their handheld PDA. All that data is being brought together and put into databases, and algorithms are being used to answer questions and to solve problems on a day in and day out basis. A lot of these examples are available out on open source and in GitHub. So if you are interested in getting involved in this area, you need to go get you a free profile on GitHub and just start banging away and doing some self-teaching in Python and some of the other applications that are out there. Our company specifically is focused on natural language processing and computer vision, where we are taking and automatically classifying content for specifically around oil fields, basins, extraction areas. Think about, even from an electrification perspective, it requires batteries, and those batteries have to come from natural resources. And those natural resources are extracted from our natural resources that we have around the world. And what we really do, we're reading and analyzing all of the data that has been analyzed and put into semi-structured documents like PowerPoint and Excel and Office documents that are going up to the executives who are saying, yes, we will spend $45 million on that capital project so that we can extract this many tons of this natural resource so we can build batteries for Elon Musk. So you have to think of the full life cycle of where AI is going to fit into your problem statement and how you're going to answer the questions that need to be answered with the data you're gaining at the edge and that has been analyzed and synthesized for decision making. And I'll be happy to answer any other questions as we go. Oh, one more thing, diversity. Okay, diversity and equalism and whatever else within the AI industry. We need to stand up for ourselves. If you want to be in this industry, there are lots of avenues to get here. I knew nothing about AI, nothing, until I joined this company in 2017. And now I know more about it than I would ever want to know. So it's all about putting yourself and opening yourself up to those opportunities and understanding that.
Not sure that everybody completely knows. Does everybody understand the role of NVIDIA in AI? A little bit? Okay. Well, I actually come from the electrical engineering background, so I actually can really appreciate the fact of how hardware has revolutionized the ability for AI to actually come into being. And so Ken has a unique experience as a solutions architect in high-performance computing. And many people may not know that the energy industry was really the forefront of implementation for high-performance computing. And Ken, I'm sure you were on the forefront of it yourself because you were with Compaq and Dell, as well as Halliburton and Blueware before you came to NVIDIA. And you've been there for now, looks like 8 years, having had worked in the energy industry itself as a technology expert for over 15 years in data science and software architecture. Thank you for joining us and providing your perspective.
Yeah, great, thank you. And I think it's great that we have a lot of young professionals here asking and learning a lot about AI. I do spend a good portion of my week talking about geophysics and mathematics. Like we do sort of make that a foundational aspect of our practice at NVIDIA for energy. That's largely because that's been the dominant software application suite that's been able to leverage the GPUs for compute. And so, so you sort of build this practice around it. But these, as we sort of have evolved over the last 2 years and really saw the power of AI, and that really comes down to this huge amount of research that was done out of the universities that enabled us to sort of revolutionize the way we actually do things like waveform propagation. So we do, in our practice, spend a lot of time sort of investigating physics-informed neural networks, Fourier network operators, these sort of advanced AI applications sitting inside the geophysics or subsurface space. But as NVIDIA goes, we don't just focus on one thing. The energy industry for NVIDIA goes from subsurface, sort of seismic reservoir simulation, all the way through midstream, downstream in the refineries, even to the power generation and power distribution, which is really where we're focused today. Like, if I'm not doing geophysics, I'm talking about the electric grid. And that's really the area that most of us should feel passionate about getting involved in. Because, I saw one EV hand go up, and then the rest are probably like trying to get it up, not really sure whether they should admit it. But nonetheless, we're expecting this large electrification of our auto fleet by 2030. Today's transformers can take 3 EVs, yet they supply power to 10 homes. So how do we do that? And that's not something we sort of program our way out of. Those problems don't don't just happen by applying physics and sort of mathematics. So we have to start looking into better solutions, and that comes down to edge and far edge AI, so that we can learn a lot about how you're using the grid, but what you're expecting from the grid as well. So that's sort of the one aspect of the AI. But it's sort of been pointed out here, like this mission to sort of decarbonize our footprint, that includes sort of the homeowner as well as and the consumer, as well as the industries that produce those hydrocarbons. And so, we sort of look at now at electron delivery efficiency. We lose a ton of those electrons in places that we have no idea. And so we're working really hard to build AI models that can not only simulate the energy distribution from source to consumer, and that includes your electric vehicles, but also how do we bring in alternative energies to do that? Most people don't realize solar, wind are non-dispatchable power sources. Like when it generates the power, it has to be consumed. And so if I can't push it downstream to someone that can actually take it, it has to be grounded, thrown away. And so we're trying to find best places to put batteries. Again, these large problems begin to grow. Yes, those are sort of an HPC compute problem, but the AI behind it's what's enabling it to actually happen in our time. Not 50 years from now, not 100 years from now, but we need it to happen right now, because we are expecting a lot out of what we can create. And now we're seeing countries turning off their coal, and they should. Like, it's a terrible way to sort of generate electricity if you're really worried about your carbon footprint, but they're also downing the nuclear reactors as well. And then sort of this ability to now ship the entire load over to our alternative energy sources and actually transmit that across our high wires, that's also a big problem to solve, because it overloads those wires and they end up shutting down. So now we really need to sort of bring AI back all the way into the data center. Our cloud providers are key here, for this large-scale data collection, but we have a lot that's going on in our industry. And so this is sort of what we spend a good amount of our time on, is how do we get that power from our sort of hydrocarbon sources or alternative energy sources into the hands of our consumers.
All right, thank you for that perspective. And I know it's a lot of a mix of things, right? Because energy has so many different sources of energy, but when we turn on a light switch, we just expect it to work. And people have gotten very used to the idea that things will just work. But what it will take to make it work, when it's not just fossil fuels generating it, but when it's a whole mix of other things generating it, some of which don't have the ability to store in the same capacity, is a very different problem that needs to be solved. And AI is definitely involved in helping provide the information required to get the right mix of things at the right place at the right time. All right, so I think we are at 1:34. We've got 15 minutes, and we can definitely pull some questions as well. So I'm going to ask the first question, while whoever wants to ask the next question can come up to a microphone out there. And the first question is going to be to the panel, and anybody can answer the question. And that is, I was scrolling through my LinkedIn feed last night, and I saw an ad from Airbnb, and they were looking for data engineers and data scientists, okay? And the ad said, here's your design for living and working with us. And it says, you can work from home or the office. You can move anywhere in the country you work in, and your compensation won't change. You have the flexibility to travel and work around the world, and we will meet up virtually to gather and work together. And my first and foremost question is how are we, the energy industry, going to attract these folks in the audience when we got to compete with other industries with this sort? Give them perspective, because they don't know all about how our industry works.
That was a good one, Aruna. So my first answer is, I'm going to quit energy industry and I'm going to go to that job, whatever that you described. Okay, that looks very lucrative and very flexible, where I don't have that option right now. But on a serious note, definitely the energy industry is not that flexible. You have some flexibility that you can work from home, or you can get some perks, definitely. And so far, at least until the oil boom has gone down in the last few years. Our industry was relatively high-paying jobs for some of them, definitely. But things have been changing the last few years, especially after the pandemic. So many people are allowing to work from home if there is no need for them to be on site. But for the field technicians and the engineers who have to be there on the field, they don't get that luxury at any point of the time. But some of the jobs, because of the digitalization and because of the AI, definitely they can be the flexibility, because people who are supposed to be in the control rooms, they don't have to be in the control rooms anymore. So they can be working from any place. They can work from home, or they can work from office, or they can just go to a park and work. They can enjoy the nature, or they can go to Switzerland and work, because that's how we are connected, especially in the last few years. Right? I mean, if you look at that, that's why we are calling this as the internet revolution. Industry 4.0 is internet revolution. Industry 3.0 is digital revolution, right? So this is the age we are living in. So definitely there is some flexibility, but not as the other industries. So I will pass it on to others for their comments.
Yeah, so we've seen this sort of large retirement from the energy industry. It's sort of unnerving to see the number of people that have left the energy industry. And now that COVID has come back, it's sort of changed people's views after spending 2 years at home. Do I really want to go to the office? And the ugly truth of it is some people in the industry work with billions of dollars worth of data. And the oil companies, if they let it go to the house, they fear that they may lose control of that data. So we have to sort of be innovative in our space, enabling people to work from home, particularly as it sort of relates to our young professionals coming into the industry that don't really want to go to the office or don't want to drive to downtown Houston. I'm there, I don't want to drive to downtown Houston either any given morning. But some problems they're just not going to let that data out of the office. So we really work with some of our customers to help them bring in sort of remote desktop capabilities so the data never really leaves the facilities. Some companies are interested in that, some aren't. So there are some jobs that we're just not going to get out of the office. But then there are a lot that we can actually bring home. And sort of challenging the management infrastructure, my belief is, and what I'm seeing is a lot of the management infrastructure has been challenged, particularly recently when they saw that the people really could be productive at home. Like they actually were more productive at home because we didn't have them for 6 hours a day because the drive was an hour each way, but we sort of had them now for 9 hours a day. And they realized, well, they could actually still work at home. So we're seeing that change. I don't think it's going to be immediate for some of the industry, but I think it's going to happen.
I will just give the software perspective on it. So we are a machine learning and AI company, and we have been distributed right from day one. And it's not just distributed here in terms of working from home, but we have teams in multiple countries. So for us, it hardly matters. I would say flexibility goes both ways. So it can be a great positive motivator for a lot of people. But I've also seen comments like, after 2 years of pandemic, people itching to come back to office, at least for a part of their time. One of the ways where I found at least, in-person collaboration a lot more important is when you're brainstorming on something new. That is where I find people sitting in one room can save a whole lot of time and can do it much more quicker. On the other hand, for your normal work, as long as we have effective means of communication and collaboration, right, and some ways to protect the data, which can in fact alluded to, because in the energy industry, companies are very sensitive about their data. So at least at my end, we use a combination of, you can say, on-prem hardware and as well as cloud-hosted systems, right? And again, for us, it is kind of distributed all over the place. So as long as, you can basically outline or you can define some boundaries around the data to make sure the data is protected and people have a means to collaborate, I think energy industry will continue to basically move in that direction as well. Of course, there is nature of the job sometimes demands you to be in office. So if it's a field engineer in an oil and gas company, they can't really do remote work, though even there, because of the automation, lots of the jobs are becoming like that people are really not sitting in the oil field doing that job. They are either doing it from home or from their work, from their office anyway.
I think one of the things that's interesting about Houston is so well positioned. We are the global gateway for not only the energy industry, we have one of the major international airports here in Houston, and you can be on either coast within 4 hours. And so from a company perspective, you have great flexibility living here in Houston, and it's all about negotiating with your organization on what your work-life balance looks like. You know, I'm not going to sit on the freeway for an hour both ways and then go into the office, and that's so unproductive. I've been remote since 1997 when the company I worked for at the time sent us a letter and said, here's a box, pack your stuff up. We're getting rid of our brick and mortar. You can be more productive. And this was back in dial-up days. Y'all probably don't even know what dial-up is. So y'all are, you know, you're so lucky from the fact that we have instant access to information, period. And artificial intelligence plays such a major role in that. Think about how far we've come from even when y'all were born. Your mom and dad can now say, Siri, find John and see where he is on the freeway. And Siri can go out there and find John by triangulating his cell phone through Find Friends and tell mom and dad where John is. That's all artificial intelligence. So, you know, there's so many different applications that are being used out there. So I hope each of you will make a commitment to the Houston community to help build the energy industry here. And going back to the space, you know, we're diversifying so broadly here. And with us going back into space, with Johnson Space Center being the center of that, there's lots of things going on from a subsurface and searching for next generation resources that are out in space. So there's a whole future out there and beyond.
Yeah, no, that's fantastic because people don't think of this. I mean, the word subsurface may not be familiar to most of you. It's actually what AlphaX, my company, spends the majority of our time on, which is to understand what is subsurface, which that means what is under the ground, which changes as you go down and as you go across. It's consistently changing from its properties. And so when you can't see something, you can only figure out so much. And that is a lot of the information that we have to figure out in order to understand subsurface, whether that is for oil and gas or for, in this case, carbon sequestration, or maybe as we shoot seismic into the surfaces of other planets to figure out whether we can find water. And so there's a lot of the skills there. But I think one of the interesting things, again, is that this is a hard sciences field. And for those of you who really enjoy problems of this sort of magnitude, it's a really fun place to work because there's no shortage of problems to solve in any of the different disciplines of energy. Okay, do we have any questions from the audience? Denzel? Yes.
Hello, Giovanni Thompson from Texas Southern University. So how would the energy sector face and deal with the inevitable? So I'm specifically mentioning like the law of diminishing returns of a finite system. It's always approaching. So there's only so much data that you can extract and analyze before it outweighs the costs of advancements and improvements that you're making in the oil, gas, petroleum industry. So how will the oil industry adapt to sustainability, or will it cannibalize itself in the pursuit of exponential optimization?
Okay, Sunil, do you want to try to take that?
Hello. Yeah. So good question, right? So I don't think, oil and gas industry will cannibalize itself, right? I think it going the other way. So at the end of the day, what you need is a good mix of, renewable energy and fossil fuels to make sure that you can supply enough energy to everybody. If you look around the world, the economic development in any area, right? It's dependent on the energy richness, or what we call as energy poverty, right? A lot of the poor regions in the world are poor because of the energy poverty. Not sufficient energy is not available. right? And there isn't a fast and a quick way of fixing that. So it will be a good mix of, let's say, wind farms, the solar farms, for, traditional ways of generating energy like we do today using the fossil fuels, right? Using a good and intelligent mix is what is going to solve that problem. You also have to remember that, each one of the fuel types that we take, whether it is renewable or non-renewable, it may not be available 24 hours a day, right? So we know the, wind farms, right? They are suitable for particular places where you can get. Similarly, solar farms are good for generating the energy during the day, right? Of course, you can't generate during the night, which means you will have to put some storage facilities, right? And in addition to that, combine that with the traditional sources of energy, and that's a good way to balance out things, right? What is going to change more and more is the ways in which these energies are being produced today, right? That is where a whole lot of, I would say, initiatives are around. Even the current operations that we have, right? Can we reduce the emissions footprint of those operations by changing maybe a mix of the materials, by changing in the way the operation is conducted, and also by changing, let's say just the operational efficiency, just doing it faster, cheaper, and a more cleaner way.
I really think this is a great question because we do face this sort of outward pressure from other into the energy industry from other places to sort of understand, why are we still producing oil? And if we sort of look at the projections out through 2050, only 27% of the world's power comes from alternative energy sources, and that's because we currently don't have the ability to replace oil as a major form of energy source. It's largely because in other parts of the world they're still evolving, they're still industrializing. Like they need huge amounts of power and energy so that they can actually come out of third world status. And so they're going to continue to rely on this oil. And what's crazy is that we actually need to increase the efficiency of our ability to generate oil by 30% over that same time frame. So at the current pace we're going, we can't possibly over-optimize our processes, because to come up with 30% additional capacity out of our existing oil production is huge. And so we're working hard to simulate our refineries so we can improve their efficiency. And we're grabbing on to 1, 2, 5, 8% whenever we can get it, because we got to get to 30% as a global economy on oil consumption and usage.
Thank you for those statistics. That really frame it. I think we have one last question. So,
hello, my name's Mark Garcia. I'm with the U.S. Air Force. We've got a number of projects that we're fixing to kick off. With the Gulf Coast being a primary sweet spot, if you will, for geothermal applications because of the sedimentary rock that we have beneath us. Can you guys give me some good practical examples of where AI has been used in the geothermal industry?
So my recommendation is for you to go to the Society of Petroleum Engineers website and go to search.spe.org. And that's I2K's platform, who has categorized and digitized and auto-classified all the content that's out there. We have, I think it's like 32,000 papers just on the application of geothermal technologies and how that's going to be used in the future. Matter of fact, we're presenting a paper on it next week at a conference at Shell with the Wood Creek, at the Wood Creek facility. Artificial intelligence is being used specifically to look at the structure, the subsurface structure, the faulting that's taking place associated with those areas, and where the geothermal is going to be able to be extracted and utilized. And the other thing is doing predictive analysis around trends in earthquake and other risk issues that have come out of some of that technology as well. And AI is doing predictive analysis on that, and also helping the engineers look at the structure of the basin in order to say, these are areas that would produce geothermal at a capacity that would be cost effective and we would see a return on investment. And so those are some of that I'm just doing very high level general, but the papers that are there go into the science and the math and the physics and the things that you're probably more interested in seeing from an in-depth perspective. And I can give you some details after this.
I think that's a very good summary. Did you have another?
Yeah, let me just take one quick one on that, right? So geothermal is a great example of closed loop production optimization, right? So this is, again, one of the places where AI is largely being used to say, especially depending on your mode of geothermal production. If you're doing a closed loop production, you want to make sure that what you inject in the well, right? Typically a fluid is injected, right? And then it is getting heated up and coming out, right? So, and that's where you are deriving the energy from. How much to inject, when to inject, right? So these are great places to optimize basically. So this is one of the other places that I am aware of, at least, where AI is being used in geothermal.
Okay, folks, I think we need to wrap it up, but I think that the question provided a very good opportunity for the panelists to explain the mix of science and engineering and application to AI that the industry does on a regular basis. And I'm going to have to say that we need to take additional questions afterwards. So we'll come down there and ask any question, feel free to reach out to the panelists after the meeting and we can talk more. All right, thank you so much, everyone, and appreciate your attendance today.
Do we want to get a picture? You want to take a picture? Someone...
Hey guys, how are you? Good. Felix Bradbury. Good to meet you, Nish. Felix Bradbury. Nice to meet you. Felix, good to meet you. I guess we'll be talking shortly. Oh, yes, it is now. Thank you, sir. You're the best. I'm fine.
All right, everyone, if we can have a seat, please, we'll get started right now. Please have a seat. And now we have Dr. Felix
Hey,
Bradbury
everyone.
from MITRE.
It's really wonderful to see all these young people here who are so energetic and so interested in artificial intelligence. I've got a little list here, though. Before I begin, I want to send a special thanks to the people that made this very possible and pulled everybody together. I think that's important. Let's see. So I'd like to hear a round of applause for Neethi, Denzel, Dean Saber, Dr. Swan, Dean Barillo, Christina, and Zaid. These are all the people that have personally helped me get here. So thank you all very much. Second point, it's just after lunch, been about an hour since you ate, so something called postprandial somnolence is setting in. And what that basically means is you get a little lethargic, a little muddled, and may not want to pay attention. And typically, these keynote speakers are people that either talk about, they might be motivational, they might be educational, they might be informative. I'm going to try and be all three. I don't see why those need to be mutually exclusive sorts of ideas. So we're going to talk about artificial intelligence in healthcare. We're going to cover a fair amount of ground. All right, let's see. The next question that comes up is, who is MITRE? And I work for MITRE, the MITRE Corporation. MITRE Corporation is a federally funded research and development corporation. They were founded by MIT sometime in the late 50s when the federal government went to MIT, who had Lincoln Labs at the time, and said, hey, we need to beef up our defense system around the country, our air defense space. And so MITRE, well, then Lincoln Labs, created a project called STAGE, which basically established that safe space and the infrastructure needed to make that happen. Do you all have GPSs in your phones? Who here doesn't have a GPS in their phone? You don't? Well, okay. Yes, you snooze, you lose. What can I say? MITRE developed that. All the airframes that you see on like the F-18 and the F-16, those were MITRE specifications, later built by Northrop Grumman or Lockheed Martin or whoever built them. Air traffic control systems, again, MITRE. Autonomous vehicles, also MITRE. But today we're going to talk about AI in healthcare specifically. My background, I'm a registered nurse. I was in oncology nursing by training. Then I grew up, I like Spock better than Kirk. For those of you that are older, you'll know what that means. I also grew up in a very nerdy family. I've got one cousin that was a physicist at Brown. He was the chair of the Ford Foundation at Brown, and another who's the president of the American Mathematical Association. So I grew up around the nerdy types. And so it always made sense to me to use data to make decisions. And so I have a doctor of science in basically what is medical economics and outcomes research. And then taking that and applying it to data science made all sorts of sense. So operationally speaking, one of the things I wanted to suggest to all the students here, Hagel is great to know, Medium is great to know, and GitHub. Use all of those resources. Get on them, steal all the information you can from them. Well, it's not stealing, right? It's the web, it's open source. Python is very important to learn. Why? Because it's open source, it's free. I don't know a company that's not using Python. So without further ado, let's dive right into it. So I think this quote from Einstein's actually very apropos in the healthcare field. Healthcare is usually about 20 years behind other industries. There's a whole historical reason for that. I could talk a whole hour just on the history of healthcare and why it is where it is today. But in essence, healthcare is way behind, say, oil and gas or finance or other industries for a number of reasons. I'll give you one that's really straightforward. In the 60s, as insurance evolved, and it actually started here with Baylor and first Blue Cross plan and paying teachers paying 25 cents a month to get hospital insurance. Insurance started to insulate people from the cost of care. And so what happened in the 60s, and doctors submitted claims and they got paid. 70s, doctors submitted claims, they got paid. And so we've gotten to this point where healthcare is 18% of gross domestic product. And we're working very hard, and that's one of the reasons where I think many of us are here, to slow down that that explosive curve of expense and cost, because we cannot compete on a global scale if 18% of every dollar we have goes to healthcare. Or as Lee Iacocca said once, that he's spending more on healthcare than he is on steel to make cars. I had a chat with the CIO for the Department of the Defense not too long ago, and he told me, I've got to change this because I'm spending more on healthcare than I am on tanks. And I'm an Army major, so that isn't going to work. So we're here to talk about some things we can do and how AI can help some of that. So some takeaways. First, all this stuff that we do, the advanced analytics, however you guys want to define advanced analytics, statistics, the Snowflake, Cloudera, Amazon Redshift, all the tools, all the infrastructure. At the end of the day, if you take nothing away from what I've said except this, it exists for one purpose and one purpose only, and that's to support the physician and the patient at the point of care. Everything that gets done in terms of analytics in health. There's things that make things more efficient, better billing, all that. That's frosting. The main relationship, the sacred relationship, is between a patient and a clinician, whether that's a nurse, nurse practitioner, social worker, or physician. That's first and foremost. And AI is a tool. It's a tool only. And we'll go talk about the definition here in a little bit. It is not a humanoid colleague. It's not the little dog out there that was robotic. It's not going to, I don't see it replacing surgeons anytime soon. And I'm not sure that I would want to. Benefits must always outweigh the risk. Now, several people brought up questions about where AI can be used nefariously. That's true, it can. There's a really not good example. Has anybody ever heard of let's see, what's it called? NextCore. It's a NextScore. NextCore. Anybody ever heard of it? Okay, so it's a score that's associated, it's like a FICO score for opioid use. Because we've had this opioid crisis in the country, right? You hurt your back, you start taking Tylenol #3, and everything goes south in your life from there. So there's basically a risk score for addiction. So this young lady, her name is Elizabeth. She was a graduate student, about 32 years of age at the University of Michigan. She had endometriosis. So endometriosis is where you get growth within the uterine lining that's very, very painful, excruciatingly painful. And during menses, it ruptures and can be very painful and very horrible. Anyway, she went to the hospital. Doctors treated her. They admitted her. They put her on basically some IV opioids, say morphine drip or Demerol or whatever. And after 3 days, she was still in severe pain. The nurse came and said, "You can't take anymore. We can't give you anymore. Your score, it looks like from what we're seeing that you've got some other mental health issues here and not just pain." And she's like, "What? I don't understand." And she didn't. And then her OBGYN cleared her. Her OBGYN said, "We're not going to see you anymore." Sent her a formal letter, certified mail, all of that stuff. So she started looking into it because she's smart and a grad student, and And what she found out, she's got 2 dogs that she adopted, and both of the dogs had some unique, were taking opioids. And the opioids are associated with the owner of the pet. So she was getting this score on this NextScore thing that made her seem like she was very much a substance abuser, when in fact she was not. So another simple example I've seen where these models, if a person is taking an SSRI, Zoloft, let's see what else, Paxil. These are selective serotonin reuptake inhibitors used primarily to treat depression. What happens is the model will go, okay, this person's depressed, and lo and behold, a disease management or case management nurse will call them and say, hey, you're depressed, we're worried about you. Well, no, actually one of the secondary uses for that medication is peripheral vascular disease. So the person had peripheral vascular disease, the model was wrong. So you have to really understand how you're using these models. You can't just deploy them. You have to really understand who's using them and who's looking at them and how to evaluate. So the people that have stood up here and talked about the model building, absolutely great. Learn all you can about Python. But if you also know the subject that your healthcare or oil and gas, if you have the subject knowledge, that domain knowledge, I can't emphasize that enough. That'll make you much more valuable than just somebody that writes. All right. Last but certainly not least, I think Houston's an ideal city. I don't think Austin should have all the fun. I don't think Silicon Valley should have all the fun, nor do I think the Research Triangle in North Carolina should have all the fun. So I think just by seeing the number of people here, the energy here, we're very well suited to lead the way in artificial intelligence, not just for Houston and not just for Texas, but for the entire country. I don't see any reason why we can't do that. So this is very informal too, guys. So if you have questions or need something en route, let me know. So here's our agenda. It's very straightforward. What does an AI-driven utopia of healthcare look like? What could it look like? What problems could we solve? Exactly what is AI? What is it not? The term AI gets tossed around a lot, and oftentimes it's wrong. I've seen recently Coke set out a thing where it said, oh, we've got a new cherry Sprite, and that's a big deal, and we used artificial intelligence to come up with cherry Sprite. No, they did not. They used some machine learning, and a dude cranked out some reports through some SQL code, and they decided, oh, wow, we sell a lot of Sprite, we sell a lot of cherry Coke. Maybe if we combine them, we'll get some synergy. There's no artificial intelligence there. There's no artificial agent there. That was basic reporting and analytics. But they call it AI because it sounds good. I'm careful about that because we did the same thing with big data. Anybody know what big data is? Data that's high velocity, high volume, high variety. That's it. It's not a magic bullet. Neither is the Internet of Things. Neither is AI. You know, a lot of the companies I've dealt with, some of them are household names. They want the magic bullet. Yet they don't have revenue codes in their healthcare data. You know, or you ask them to send you a data set and it's, 12 million members and they're all female. Like, huh? So we know that you've got to get, what is the data? Is it accurate? And AI, things like AI and the Internet of Things are not a magic bullet. There's a lot of heavy lifting that has to be done before you can start to use this data in terms of artificial intelligence. I want to talk about two use cases, one clinical, one operational. A little bit about the future of AI in Houston, since that's what we're all here to discuss. The potential barriers to the adoption of AI. I think you all have experienced some of those. Some of them are AI specific, some of them are more specific to general constructs. All right. So what does a utopia for AI look like? And I've segmented this into patients, providers, commercial payers, and federal purchasers and regulators. Now, I have not touched on Medicare and Medicaid. There's one reason for that only. That's because they're my client. And if I wanted to get it through them, I'd have to be on the phone with somebody at the head of CMS, and I'd still be on the phone with them. I wouldn't have gotten here in time. It just wouldn't have happened the way the government works. So for patients, what does artificial intelligence mean? Genomics, proteomics, customized medicine, the ability to find out information faster, continuous monitoring. A lot of the, if you guys have a Fitbit, and if you have congestive heart failure and you have a Fitbit, some of these technologies are going to start monitoring specific diseases and sets of conditions. They're also being used to help modify behavior. So things like Noom and Reset, very powerful tools for helping change human behavior, because that's one of the things that's the problem in healthcare, quite frankly. You can squeeze all the money from the providers, you can squeeze all the money from the hospitals, you can squeeze money from employer groups, but at the end of the day, there's a lot to be said for changing human behavior. How do we eat? Do we exercise? Do we get enough rest? All of these things that are behaviorally related that we don't necessarily do, but we need to. Okay. On the provider side, early detection of disease. So, and we'll talk about one of those use cases here in just a second. Being able to find out disease earlier, being able to create clinical pathways that are intelligent so that if you have, let's say you have a 72-year-old diabetic female, what's the best path, and she needs a hip replacement. What's the best clinical pathway down to whether you use 3 mil Vicryl or 5 mil Vicryl for surgery that results in the best outcome for that patient, given a whole series of inputs? What does that look like? And because of things like big data and because of the computational horsepower and torque we have now, and because of artificial intelligence, we can get to some of those answers. And there's actually organizations that just specialize in that. On the commercial payer side, one of the big things healthcare as an industry is trying to do, historically, they've been a fee-for-service gig. Pay money, get care, move on, whether that's you paying out of pocket or an insurance company. So, and because of our history, there hasn't been, until the 80s and 90s, a whole lot of real pressure to move towards paying for value and generating value for what you get. We are, if you look at the World Health Organization and what we pay for healthcare and the quality of that care, it's less than ideal. So what we're trying to do is move from fee for service to pay for value. One of the things that AI can help with is understanding what are some of those leverage points so that we can make that transition and providers don't lose their margins and patients get the value that they're expecting to get. Evidence-based medicine is another opportunity, as well as things like artificial intelligence applied to prior authorizations and utilization review. There's a whole gamut of administrative tasks that can be handled through the use of artificial intelligence. And last but certainly not least, federal purchases and regulation. So one of the ways that AI is currently being used is faster drug development. AI can look at the way a molecule, it can look at the way I'm not sure why that's doing that, but anyway, AI can look at a drug and look at drugs that have been used historically and how they interact with the cell. And they can be, that you can train the model and you can take that data and help it to learn other chemicals and be able to bring drugs to market faster that have the same efficacy. And you can also hopefully get drugs through FDA a little bit faster. All right, some things to consider if you're an organization looking to deploy AI. Because this goes part and parcel to the big data, the Internet of Things discussion I was mentioning earlier. First and foremost, figure out what the question is you're trying to answer. What is the use case of what you're trying to solve? You know what that use case is. I see a lot of people that I say, well, what are you trying to solve? And they talk for a long time and don't say anything, really. You want to know, is it readmission risk? Is it one of the projects I'm personally involved in is teen suicide. Who here knows that that's the third leading cause of death in this country for young people? I didn't know that. I do now. So you got to understand what is the question you're trying to answer. Then second, and real important, do you have the data to answer it? Most of the time, a lot of people don't. So if you don't have it, that means you either have to grow it, which takes time, or you have to buy it, which costs money. And if that's assuming you can actually buy it. So that's the second problem. The third is, do you have the analytics skill sets to do it? And you guys are here because you're interested in growing those skill sets. The unemployment rate for people with doctorates in economic fields is half of 1% or less. This is a great place to be. You're going to be highly employable. So, there's a huge shortage there in this part of the workforce. So the more you can learn, the more quantifiable it can be, the better. So you need to understand how to use the analytics, and it's equally important, be able to talk to the end user. You can't just talk to them about, let's talk about a convolutional neural network and a descending gradient applied to this. Will that help you? They don't know what you said. You need to be able to take their concept and apply it to your concept and speak their language. And you need to be able to take their data and make it and put it into your language. So you need to understand whether the data is continuous, discrete, oracle, whatever, and be able to talk their language and help them make sense of it. Because a lot of the end users these days, it's like they're Honda, right? They just want to get it in and turn the key and go, or push the button, push the button and go. They don't want to know what's going on under the hood. You guys need to know that because you're the engineers. They just want it to work and they want to know it's going to work reliably and correctly. That's where you come in. So, all right. The other question I ask is, does the organization have the ability to actually execute on the change? Because I find a lot of organizations, I say, well, I can give you a solution to that. Do you have the resources to execute it? And they say no. So why are you even bothering? And then last, and certainly not least, you've got to be able to measure the impact of what you did. Not only the impact of the work, but what it cost you to do that work in terms of resources and capital. I had an organization once that came to me and said, we spent $1 billion on employee wellness, and we're in a good position to monetize that. We don't know if it worked. And then they spent that over 10 years. And their CFO finally decided, that's a lot of money, maybe we need to add. So when you're starting programs, you need to think about how you're going to measure them at the end of it. So if it's an AI project, how are you going to measure the value and the impact of what you did during the course of that project? I'm sure your CFO can tell you in terms of hard dollars, but you need to be able to tell them in terms of cost benefit, cost effectiveness analysis. All right, the definition of AI. I really like the second one, intelligence that is not biological. And that's from an MIT professor, no less. Okay, so I keep it simple. I think of AI as any sort of computer science solutions that does something that a human would otherwise do, either in terms of a physical action or a decision. That's it. So that's my 2 cents on that. All right. So what are the things that currently that AI does? One of the things it does is it cures drip. Anybody here know what drip is? Data-rich, information poor. And healthcare has been notorious for that. Data-rich and information poor. Lots of data, lots of claims data, lots of EMR data. None of it speaks to each other, but that's a separate issue. So turning that into actionable intelligence and for physicians and nurses and patients at the point of care, now we're beginning to see the light at the end of the tunnel there, partly because of AI, partly because of things like HL7 and fire. So image recognition, that's the other big. A machine learning, natural language processing that can allow a physician or a nurse to dictate notes, makes it and gives you part of an electronic medical record rather than having to write everything by hand and nobody can read it. I remember having to call doctors in the middle of the night, and that's always a pleasant conversation, and say, hey, is this say Vicodin or something else? You need to know that. When it's electronic, it's a lot easier. And of course, robotics, we'll talk about that, and speech recognition. So what are some of the promises? Well, definitely the one I said about curing the drip syndrome, but early pattern recognition. I'm going to show you some examples of that. Also, great improvements in terms of operations and things that we would call operations research. I don't necessarily mean surgery, although surgery is certainly included. Basically, increased efficiency of care and removal of what's called non-value added work. In other words, wasted time and energy for mundane tasks that you can let a computer decide. So for example, prior authorizations, one of my favorite subjects. You either receive authorization or you don't. If you have a denial, it's one of two reasons. One is you don't have covered benefits, and that's called administrative denial, or your doctor failed to substantiate medical necessity. And it's easy enough to figure out the medical necessity. You just compare what the doctor wrote with what the medical necessity, what he should have written or she should have written, and look for the difference. So AI can help with all of those things. And of course, AI is also used in managing wait times and queuing systems because you can model those. All right, now this is a real cool example. This is from Mass General. So there's a lady up there, I think her name is Brazile, and she's a data scientist. She teaches data science, but she's also was into art, and she's also into natural machine learning as applied to images. What she figured out was that she could take a mammogram, and she had some students assist her, and train the mammogram or train the computer to look at the mammogram over time and see what happened, and look at women that had breast cancer and those that don't. And what she found out is just stunning. She actually has an algorithm now, it's in the research literature, that can detect breast cancer a year ahead of time through a mammogram, through an image, because the computer is looking at that image and going, there's a certain pattern to what I see. The doctor can't see it, the radiologist doesn't see it, the patient certainly can't feel it, but the computer recognizes. Sees a pattern there and goes, I've seen this pattern before. When I see this pattern, it goes to this, and becomes breast cancer. Now this person has a year lead time. That's phenomenal. That's a miracle. So that's some of the horsepower behind AI, and that's really some of the benefit. Okay, let's talk about clinical labor. This is more of a administrative operations research type component. So I'll give you an example. FedEx, right? They've got, let's say they have to deliver 365 million packages in a year. So basically 1 million a day if you take the average, which is just what Nurse Ratchet, the charge nurse here, did. She took, a couple of years of data and averaged. So what happens is the FedEx guys are bored out of their minds for most of the year. Then Thanksgiving comes and their heads are on fire because they've got a whole lot of packages to deliver, because the distribution is not like that. It's something else. And nobody took that into account. So one of the things we struggle with in healthcare, and we certainly saw this during the pandemic, it certainly heightened things, is aligning clinical resources, nurses specifically, to patient demand. So that's a number of factors. That's acuity of the patient, the number of people coming into the hospital, the number of people on a certain floor, because you've got service lines, right? You've got med surg, you've got neurology, you've got orthopedics, you've got cardiology. You have to be able to staff to each of those service lines, and you need nurses with different skills. A NICU nurse, I would not want to waste the skills of somebody that's had years as a ICU nurse or a NICU nurse in a general med surg floor. That's a waste of good skill. So it's a matter of, you can use linear programming and artificial intelligence to align supply and demand to help forecast out the demand, because you've got years of historical data in terms of who's coming into the hospital, what floors, how many, and when, and the acuity of those patients. And you can forecast that on an individual service line level and come up with a staffing model. And that staffing model says you need this many type of nurses on 5 West at this time of day, at this day of week. And what happens is, you look on the right-hand side, these are real numbers actually. So you can see there, it optimizes the mix of nurses. So you're trying not to have a bunch of contract nurses. You're trying to reduce the amount of overtime. So you're basically mixing and matching your pool of nurses. You're optimizing that labor force and saving yourselves a lot of money. Well, first and foremost, it ensures greater patient safety. Why? Because you put the right nurses, the right patients at the right time. That's first and foremost, patient safety. And the second is they actually wind up saving money because you're not having to hire contract labor or do overtime that you might not necessarily need. All right. So a little bit about AI in the future here. Huge opportunity here. You all are here. I think we've got all these other universities. We've got one of the largest health systems in the world here. You also have residential infrastructure that's important. You've got residential infrastructure downtown in the heart of Houston. So all of the big cities that do tech, like Austin, have that. So the young people that want to, go to work, walk home, they can do it. They're near all the fine restaurants, they're near their friends, they're near where they work. It's very geographically centric. The other thing that we have in common with places like Austin and Northern California and Silicon Valley and North Carolina is we have a frontier mentality. That sort of carpe diem, seize the day. You all are here as representatives. You want to get it done and make a difference. All right, I won't belabor the point here. So you can see here, this is pretty simple graphics. The capital spending for R&D for the top high-tech companies versus the usual Fortune 500. Basically, the tech companies drive that. They're leading that. They're pushing that envelope a little bit more every day. All right. So what's my vision for us, for Houston? I think, no offense to the energy people, but on a national level, oil and gas is 3% of gross domestic product. Healthcare is 18%. We need healthcare. We need to reduce those costs. We can't compete globally as long as healthcare is 18% of GDP. Not sustainable. I think Houston has a lot of bright people that are willing to learn and grow and make the difference. You've got the real estate, you've got shipping, you've got healthcare, you do have oil and gas if that's the way you want to go. I love seeing all the STEM education and the technical talent that's out here in the community. I loved hearing a lot of the questions that people had today. So really, really insightful questions. So we need to invest in you guys, not only as young people and as a growing community, but as a workforce. And so part of what I would say is not just learn Python, but learn neuroscience, learn psychology, learn nutrition. You have to understand how people think. There's a really good book written by Daniel Kahneman, who won a Nobel Prize in economics, called Thinking Fast and Slow. Write it down, Kahneman, Thinking Fast and Slow. What's this year? That came out in 2012. And he talks about how people process information or don't. If I give if I ask a question and give a relatively easy answer, people are likely to glom onto it. Why? Because the brain is inherently lazy. So what you need to do is understand how humans think. That's a key part to, if you were trying to automate and build artificial intelligence, you have to know how we think. That's one of the problems with all of this is if artificial intelligence and intelligence were so easy, you'd understand it, you'd be so stupid that you couldn't. Does that make sense? It's true, you can't. And on the brighter side, you know what was, say 20 years ago, do you know the most common question asked of people with advanced degrees in computer science and analytics? Would you like fries with that? And that's not the case anymore. We've got, the people in this room and all sorts of, the nerds are winning, what I'm trying to say. So some potential barriers to the adoption of AI. Trust, that's probably the biggest. Maturity of AI. And one thing I would say, just as a cautionary note, just because you have a technology doesn't mean you need to use it. I've seen it many times where big data was a classic example. People came to me and said, I want a Cloudera stack in my organization. Well, your data sucks, and no, that won't really help you. You're just well off with SQL until you can fix your data. Doesn't make any sense. Ego, garbage in, garbage out. Adding artificial intelligence as a layer to garbage in, garbage out just means you've made artificially stupid decisions. It doesn't help you. Maturity of AI, that goes back to what I was just saying. Your organization has to be analytically mature. I would read Competing on Winning by Harris and Davenport to understand that. They did a lot of work around understanding what makes top performing companies in terms of analytics. Data quality. This is the bane of my existence personally. Healthcare data is not good. I'm trying to be politically correct. Usually when people ask me about healthcare data, I say, if you want consistency in healthcare data, try Metamucil. Because the data, not good. I've seen it time and time again. I spend a lot of my time is just cleaning data, correcting data, recommending how to remediate bad data. So you have to work on that. That also comes into infrastructure and costs. And then last but not least, integration of siloed data. I mean, if you guys, I assume a lot of you are familiar with Epic. I know these guys over here are. Epic and Cerner and Allscripts. I can't even get an Epic system within a system of hospitals, one instance to talk to the other. It's like you guys. You guys are in the same room, you can't talk. So it's, and on a national level, it's even worse. But we are trying to overcome that with things like HL7, which is a health level internet. It's a standard for healthcare interoperability, and something called FHIR. So those are standards to help move the healthcare industry away from sort of the silo structure to building something where your medical record can be available anywhere, and it's owned by you, and that information is easy to share as you need it without violating HIPAA and all that. All right, so where do we go from here? What I was saying earlier, you know, study Python, yes. But if you really want to get an edge on the competition or the guy next to you, or just want to be that much more competitive in the job market, or type A personality, learn some other things. Learn neuroscience, learn psychology, learn as much as you can about data science. You know, my son over there is interested in analytics. And so do you guys know who leads Yahoo and Google and all of these companies? Have you seen what they're not their names? I don't care the names of the people, but do you know their backgrounds? Have you ever looked at their backgrounds? They have PhDs in applied mathematics, theoretical physics, economics, very quantitative field. So I can't stress that enough. Math is your friend. Math can help you all the way to the bank. So learn more, be more quantitative, make a lot more money, be happy, have fun. I mean, I enjoy coding in Python. I don't know about you guys, I do. I think it's pretty cool. It's slow. I prefer SAS and Stata and some of these other tools I grew up, but Python works. So that's it. You can find me on GitHub under X5 Legion, but for MITRE's purposes, you can also find me there. So are there questions? I don't know how we're doing on time. Looks like we're running over. Questions?
This thing on. How you doing, Dr. Bradbury? Denzel Wilson here. You talked about the future of Houston and AI, and basically how we are set up to be a leader in this field in the future. How much does that have to do with us having the Texas Medical Center, and how do you think we can mitigate the issues with innovation, you know, with slow processes in politics and policy, that things that can hold us back? How do you think we can mitigate things like that?
That's a great question. I think the best way to handle that is through what I call proof of concepts, small wins, figure out who you want to work with. You know, what I typically do with healthcare executives is I invite them to lunch, sit on the board of their healthcare executives, so that does help a little. But I ask them, what keeps you awake at night? You know, talk to people. It doesn't have to be health, but you're asking a healthcare-oriented question. Ask them, what are their issues? You have to understand what the problems are you're trying to solve. Put a use case around it, like that framework I gave you. What's your question? Do you have the data? And then you work to solve it. And start with something easy, something relatively light. You know, how do you use AI to move more people through your emergency? It's, you know, pretty straightforward. But predict the number of people that wander through the eel? How do you, what are some of the bottlenecks? So people will give you more credibility and thumbs up if you have a win. So find a small project that you can get your teeth around. Don't try and solve entire healthcare on day one. It's impossible. I've been in healthcare way longer than I plan to be, and learning more every day. So find a project, find something scalable, and work on it. Other questions? I just want to know, did I keep my word? You guys everyone was trying to entertain, inform, and motivate. Did I or no? All right. All right. I think we have a number of panel things coming up.
Thank you so much.
How do we need to do it? Do I stay up here or get down or?
Picture?
Okay. Oh, sure. Oh. I'm not putting that off. No.
Okay, well, our moderator today is Doreen Rosenbach, Dr. Doreen Rosenbach, I'm sorry. And she'll be moderating, so enjoy.
Hello, everybody. Everybody had a time to stretch. Health is your new wealth, right? So good food is over there. Feel free to drink some water. We are so excited to be here today and to serve as your panelist on the topic artificial intelligence and healthcare. And we have some announcement to make. And the students, if they're here, I would love for them to stand up. Juliet Manning, Nathi Anand Gangidi, Denzel Wilson. So look at these students. These are your future leaders. They coordinated this in a very short time frame. So thanks to them, we are here today and we're very grateful. Thank you for having us. Now, I would love to for you to meet our panelists. I'm giving the microphone over to Dr. Bradbury, and tell us a little bit about yourself. You already did somewhat. And how did you get here? AI in healthcare.
Great question. I'll be short because I just talked about this. I liked Spock better than Kirk. And it just made sense to me to apply analytics to healthcare to make better decisions. And everybody needs healthcare. Everybody has a family and loved ones. And if we can use analytics to make that whole process better, get to better outcomes and better experience and lower costs, I'm all for it.
Hello, everybody. I'm Scott Schlotz, and my journey to healthcare may be a little different than others. Started off in what we used to call data processing. So that was what it was called, I don't know, 50 years ago, 40 years ago. Bottom line is, I started my career as a database analyst, got more involved with as everything evolves, we always have to change the name. So, eventually now, we're working with IT, have been blessed to have started a couple of different companies that provided consulting services across pretty much every industry, and did a lot of work in the healthcare industry during the 30 years we were building and selling those companies. But about 11 years ago, had an opportunity to divest a large health plan for a health system in St. Louis, and really just decided to just focus on healthcare. So specifically, how I got to AI in healthcare is, Dr. Bradbury mentioned that, this industry is about 20 years behind a lot of other industries in automation and moving things forward. And so the opportunity to help propel that is really just my passion and my focus. So that's what gets me on the stage today. Thank you.
I should say, my name is Chaitanya Vempati. I'm the Director of Data Science at Memorial Hermann. My journey is equally different. I'm actually a master's in engineering from University of Texas with specialization, back in the day in numerical methods and data science and AI in mechanical engineering. So trying to recreate a human thought process that goes on in every engineer's mind, and trying to get the computer to do the same thing. I got hired on into oil and gas, and I spent almost 14 years in oil and gas, so I could have served in the previous panel and talked about oil and gas and AI and data in the oil and gas. But through the COVID, I had a change of heart. I wanted to pursue something different, make a difference in people's lives. So I said, okay, let's just move on and choose a career that in healthcare. So got hired on as the Director of Data Science at Memorial Hermann. So quite a bit of journey from oil and gas, and hope to be an inspiration to get you all to choose healthcare over oil and gas, right?
Hi, I am Maleswar Enugu, CEO of Bytelink Systems. I also have similar story like Chaitanya. I did PhD in geophysics from University of Houston, which is oil and gas. I worked for a few oil and gas companies, but later on slowly switched into data science, AI/ML, and I started working for Anthem. I did a couple of projects for them, and that's when through my company Bytelink Systems, we developed one product called AI MedScan, which actually scans the chest X-rays to predict pneumonia or not. So that's where we used all deep learning algorithms. So even though I am from a different background, I worked for oil and gas, but now I switched to healthcare. Maybe after a couple of years, I don't know where I will switch to. But, this is, again, motivation for all of you, students especially. Learn data science so you can end up any other industry, whatever you like. Thank you.
How are you guys doing? I guess we should change this thing to changing oil and gas to healthcare. I think it would be a good idea for Houston. My name is Manish Vakil. My background is very different than everybody. I own a couple of different companies that I started when I was 26. So now I'm 45. So been a while. First one I started, which is the one that you'll see in the book there, is a kids obesity, to fight children's obesity. It's called Tumbles, and we franchise. So this is a complete analog company. And the idea was, the secondary was, I wanted to create a visual report card for parents to show how the kids are growing. And we created a second company that we have now called Healthbotics, which is in the AI ML space. We're going into actually scanning postures, posture analysis, movement analysis, and we're taking GitHub, and we took a lot of data sets from there in order to analyze and train our algorithms. But the best idea was, why create our own when we can get Microsoft and use their connects when they already created them? So that's what we're doing now. So it's a combination of a complete digital company and going into the analog company in order to provide these services to children around the world. And the idea is to democratize data so we can take this data and eventually have each individual person own their own data. And that's our goal.
Thank you so much. So my name is Doreen Rosenstrauch, and usually I offer several perspectives because I wear several hats as an educator, as a nurse, as a physician, as a healthcare executive, as a scientist and researcher. And sometimes I'm the only woman in the boardroom. So kudos to the female students here, and I'm empowering you to keep going and never give up. Now, a question for our panelists. So how are you incorporating right now artificial intelligence in your organization?
Everything we do is around open source, so we do a lot of work with artificial intelligence, a huge focus at MITRE. One of the ways we're using it is to look at I mentioned teen suicide earlier, and so we know that several things predict, and there are models out there already that predict teen suicide, but they're not very particularly potent or robust models. We know several things predict suicide: depression and bipolar disorders. That's one thing, and then also hyporeactive sweat glands. That's another strong predictor, and in fact, there's been some research published fairly recently that shows a 97% accuracy on the latter. So we are working to combine those to help first identify young people at risk of suicide, and then to use natural language processing against peer-reviewed literature to find the best processes, practices to make sure that they get the right care in the right place and how to help manage that. So that's a simple example.
I recently joined Kelsey Siebold as their director of digital health, kind of under the mission of, here again, as we talk about healthcare lagging other industries, to just bring a broader, more robust digital platform to the organization so that would enable a much broader delivery of virtual care services. But ironically enough, sometimes before we get to the important part of treating patients, we have to figure out how to successfully provide access to them. So one of the areas within Kelsey Siebold where we're heavily investing right now is just in the area of conversational AI, so a digital assistant. Over the next few years, our footprint across the Houston metro area is gonna increase pretty dramatically, 60–70%. And so we spend a lot of money on contact center staff, 24/7 contact center. And, we can either double that expense as well as the corresponding issues of turnover, training, those kinds of things. Or we can introduce a very, very robust conversational AI model so that we build a very, very effective digital assistant so that our patients don't necessarily have to talk to a live person, right? If they don't want to. Now, if they do, we're not going to route you through, the never-ending cycle of questions so that, we don't have you talk to a person. So that's one area that's very administrative, but is going to drive a lot of value for the patient experience as well as just to our bottom line. Another area, so we go to the other end of the spectrum now, and I have a passion about building effective programs where our chronically ill patients can age in place at home. And so we do that with a bunch of Bluetooth-enabled devices, a dedicated clinical care team, but we've recognized for a couple of years now that we can identify and better understand individual disease progression based on the clinical data that we receive. But we also understand that we can't analyze that data as a human as quickly as we can train a model to do. So with the availability of a lot of shared data, we're going to focus on building a model that really helps us understand disease progression related to diabetes and congestive heart failure initially. And so, stay tuned. In 12 months, I'll have an update for you.
For me, I represent Memorial Hermann. You all are familiar with Memorial Hermann, nonprofit, community-driven, healthcare provider here in Houston, one of the largest healthcare providers. A couple of, I see a lot of students there. I was hoping to hit on, what would be really appreciated by the students is that we built some deep learning models that would predict readmission risk, contrary to popular belief. Memorial Hermann doesn't want patients to come back to their facilities. I mean, a lot of people think like, hey, we want more patients. We actually don't. Once we treat them, we want you to be healthy. We want you to be happy. We don't want you to return to Memorial Hermann. So we predict the readmission risk. It's a fairly standard use case across, fairly standard, deep learning model to predict the readmission risk per patient. So we're able to better take into account their conditions when we actually discharge them. The second case is what Dr. Bradbury hit on, is we're using also NLP, natural language processing, to take care of and catalog and categorize our data better. So converting and physician's note into codes and better tie it all and produce a horizontal record of a patient across all of their various encounters, various places where you actually touch our system, right? So that's a couple of use cases. I mean, I could talk about all the others, but this should really be very, very much close to what you guys are learning in schools, pretty much.
We actually developed one product called AI MedScan, which uses deep learning algorithms on images. And now we are extending the capability of the same tool for dentists as well. Because whenever we visit any dentist, initially they take, X-ray, isn't it? We are using the similar deep learning CNN, convolutional neural network algorithms, to identify the cavities from dental X-rays. That's where we are in the development of our tool. And we are also helping one of the Southern Florida hospitals, like Chaitanya just mentioned. One of the use cases is hospital readmission. No hospital wants their patients to come back, especially not within 30 days, because it's a reputation for the hospitals, and there is also risk of not getting paid from the insurance companies. They will hit by 3 to 5% hit there. Financial, risk is also there. And also we are helping them once the patient walks in and if they get treatment, when the patient should be discharged. Is it tomorrow? Is it after 1 week? Or is it after 1 month? We are using AI algorithms, which is structured data, because they have all the patient's information, tabular form, based on the medical condition, based on different readings, health condition, when this patient can be discharged. So for students, this is structured data where we are using classification algorithms, we are using random forest, XGBoost, etc., to predict when this patient should be discharged. And also another use case we are chasing is how can we reduce the ED times? When a patient walks in, from the patient walks in, seen by the nurse, again seen by the doctor, it can be few minutes to few hours. So hospital, our client, they want to reduce that information. They want to have a better understanding. Once the patient walks in, based on that, they want to have better understanding on the number of beds. Whether can we allocate a bed in the ED room to the patient just walks in few minutes ago. So, which is again like a time series analysis. So we are using time series algorithms like LSTM in deep neural networks to better understand the allocation of the beds in the hospital. So these are some of the use cases we have been chasing. We are helping, we are developing our clients as well.
So our company for the health robotics side, currently, we have two different areas, right? So one is we have to collect data, new data on kids in order to see how they're physically developing. So we scan the kids in our physical tumbles facilities. And we're using those data sets to train our machine learning algorithms to become more accurate, right? So the AI is there, as you said, it's the underlying technology that we're using that we need to find better data sets are more accurate, as they say. So how can we predict how the kids are going to grow? So kids have, you're looking at them when you go into the doctor's offices. These gentlemen here can tell you a little bit more about that. They have knock knees. Their feet are a little bit further out. But those things, you don't recognize them. Parents don't recognize them until you have a problem later on in life. So how can you have a proactive approach to finding solutions to these things? So our goal is to scan the kids in a physical facility, and then before they go in, we can tell them, hey, if you have knock knees, your knees are a little bit further in, you can do these exercises and have a predictive algorithm that's going to tell them what exercises you need to do so you don't actually end up going at any of their hospitals. And that's the key case, because if you look at the basic things for kids when they're playing sports or anything, the biggest reason is hand-eye coordination or clumsiness is why they fall. So if you look at the biggest reason kids end up in the hospital is for, baseball season starts, football season starts. That's when kids get hurt. So our goal is to start from the beginning. And if they don't have these issues, then they won't end up, because they're going to be better at hand-eye coordination, better flexibility, better agility. And so it's a completely proactive approach. So we don't want to be reactive. These guys are there for reactive. We'll try to send less people to them. And that's the goal.
Thank you so much. Now that we know who you are and what you do, the students want to know your why. Why are you doing what you're doing? What keeps you going? Usually as an entrepreneur in an organization or an entrepreneur like yourself, things can get tough and there's a lot of change management in place. So what keeps you going? What is your why? What keeps you motivated?
An opportunity to make a difference in a large number of lives. As I said, I started my professional career as an oncology nurse. It was I worked for a large regional medical center in a small town in southern Georgia. And I remember getting my hair cut, and the lady said, "You ain't from around here, is you, boy?" And I said, "No, my subject and predicates agree." I learned quickly that what patients need there is somebody that was, and this was years ago, very good with administering Demerol and Phenergan in a very timely manner. And the way they rewarded nurses was by giving them $20 bill, crisp $20 bill, every time a patient or if their family members remembered the nurse's name at the time of discharge. So I made a good amount of money doing that. But what I took away from that is I could make a difference in the lives of an individual. And so as my career progressed, I wanted to take analytics and apply it to a larger segment of the population. And now I do.
So I'll echo Dr. Bradbury's sentiment. Healthcare appeals to me at a lot of levels, but it really is trying to make a difference. And as I've gotten older and in the area of the virtual chronic care platforms that we build, I make the joke that I'm just trying to build the platforms that I'm going to need. But in the meantime, what we've learned over the years is that, for instance, every chronically critically ill patient that we figure out how to help them effectively age in place at home touches 4 or 5 other lives, their primary caregivers, their next door neighbors, the other folks. So there's that multiplier effect there. And the other part of it too is that, so I've become kind of a virtual care guy over the years, is that there's so many underserved communities across this country. And so once we better identify ways that we can use virtual care more effectively, and especially to plug patients into specialty virtual primary care visits, driven by kind of neural networks and some machine learning, here again, it just provides enhanced access, which kind of speaks to the passion of trying to serve others. Thank you.
Well, for me, it's, I mean, I've always been passionate about solving problems. I mean, whether it be in oil and gas or in healthcare, like when I see a problem, I empathize with the people who have problems. And I get a lot of reward when I see a solution being applied, when I see something physical, I mean, whether it's been, using a particular model or whether you're making changes in people's lives by using data. And that always is the best motivator for me in terms of the work I do. I mean, whenever I see a problem, I really get excited and I want to jump in and help him. So I'm fairly hands-on and I want to go in there and help him. That's what keeps me going. I do want to add one thing though. All of the students out there, I mean, one of the things, if it doesn't motivate you, we'll all be cynical. Healthcare pays well. So, I mean, it's a great place to be. I'm continuing to sell healthcare here.
My father used to work in a hospital in India, and he used to take me there a few times. And India being a developing country, the patients used to lie on the floor, and I used to feel very sorry. But I never thought of becoming a doctor somehow. But after coming here, doing PhD in oil and gas, when I learned data science, I have the options to choose either oil and gas, financial, or any other sector. But I came to know about one concept called Ikigai, which is a Japanese concept, IKIGAI, which says that if you're an expert on something, please try to help the humanity or the people that are suffering. When I founded that concept, I thought that, okay, now I know something about data science, AML, and this is the problem I have been feeling for many years. Then I started developing a product called AI Scan, which helps the doctors to better diagnose the medical condition of the patients. That's what we are extending it to dental as well. So that's how I choose actually medical field to help the patients as well as to help the hospitals or organizations to better serve all the patients and all of us. Yes.
So my answer is going to be a little bit more philosophical, I guess, because for me as an entrepreneur and anybody else who's an entrepreneur, if I tell you guys this, no matter how well your company does, my daily struggle every day, I wake up thinking my company's going to go bankrupt every day. Not kidding you. Doesn't matter, right? So the difficult part is, how do you move forward, as you said earlier, every single day? What's my motivation? Well, I don't want my company to go bankrupt. That's a pretty good motivation, right? Because there's a lot of people who rely on the company doing well, right? But the main mission was originally philosophical, as I was saying before, was, one of the things originally, so I wasn't the smartest student in school. So to all the students, tell you, I didn't learn to speak English until I was in 8th grade. So I came from India, I didn't know anything at that point. I was in basic skills math until 9th, okay? So it was Houston's pretty nice for a part of the areas. Where I grew up in Jersey, yeah, not so nice. But looking at it, I came up and always said, my parents always used to come out and say, like, what do you want to do? How do you want to do things? A simple line, like, leave the world better than you found it, all right? Now, what better thing than to help kids, right? So we have a mission statement in our company that we thought about for a while, then I came up with originally, was like shaping the minds and bodies of the future, right? So minds and bodies, all my companies focus on that mission. So what can we do today to serve that mission in order to achieve that mission, and whatever decisions we took, does it further that mission, right? And that's the main goal of every single day of saying, okay, we're going to go into healthcare. That's a really good way to come up with anything proactive that you're going to help. And if it helps someone else at the same time, which is healthcare in this country is one thing, but healthcare worldwide is absolutely a pandemic, if you want to call it a pandemic. That's been going around. It's getting worse. So if you think COVID's bad, looking at that, that's actually just absolutely enormous that everybody has to pitch in and help. So if I can do my one little part, and I think we had that conversation just a few minutes ago when we were sitting down saying, if I can do my little part and help a few people, then you know what? It's all worth it.
Thank you so much. Yes, I can relate. My why is actually the next generation, to pay it forward to them, to you, and the young man over there was right behind you, studying AI, and he wants to be a lawyer. So the students sent us some questions before, and we're going to go around the panel and try to answer them. If you have additional questions later on, please come to the mic and ask them. The first question is, the healthcare system in the United States apparently is not the best one. It's very expensive, but the outcome is very poor. So AI can help in many spaces. But what do you think, and the question is for you, Chaitanya, is right now the application in artificial intelligence which has the highest impact?
For me, I mean, I guess to sort of extend what you said earlier in terms of healthcare system in the US, right? I mean, you all have realized over the last 2 years, how the number of cases as the, COVID's gone up. You've seen in the news that we are having shortages of nurses, we're having shortages of primary care physicians. This is a short-term problem. However, if you just look at what's going to happen in the next 5-10 years, this is only going to continue and it's going to get worse. Like, a lot of people are going to get older. We're going to see a lot more ailments, and a lot of people, will come on board on Medicare and Medicaid programs. So there is a lot of need for people requiring healthcare, right? And the number of doctors and primary healthcare providers, nurses, isn't going to rapidly increase at the same pace. As consumers, all of you are now demanding customized experiences. You do not want to go in, stand in a booth, a doctor comes in and says, this is what's wrong with you, and walks out. You don't want that. You want a personalized experience. You want a connection with your primary care physician and do, and have a personalized healthcare plan that's suited to you, right? That's provides you a lot of benefit. Both of these don't go together. I mean, doctors, you can't have a doctor and primary care shortage and have a personalized healthcare program, right? Which needs time. This is, I think, one of the biggest areas of opportunity and the biggest challenge that you all probably, when you choose healthcare, will get to work on. How do you assist, first, primary care physicians, nurse practitioners, care providers, whether it be person checking you in at the front desk, how do you make them 10, 20, 30, 40 times more efficient than they're right now? How do you provide contextual information that enable you to give you the personalized experience that you want? And second, how do you prevent people from coming into the hospital in the first place? How do you improve your health at the location where you're in, where it is, providing healthcare at the, at homes? So these two would probably be the biggest opportunities. If you look at the entire Houston area and US as a whole, the biggest opportunities that AI can directly help to change the trajectory that we're in, that we find ourselves in with respect to healthcare in Houston and in the US.
So now we're living through a pandemic, and Dr. Vakil is asked to answer the question, what could be the role of artificial intelligence actually to maybe prevent another pandemic or assist us in a future healthcare crisis like the pandemic?
So, I think originally, Dr. Bradbury, you had a nice slide up, right? That was showing someone who actually had the CT scans that we're doing to do the breast cancer research, right? So originally we were looking at the pandemic side, and what Chaitanya just mentioned right now is we're gonna have a shortage of, at least at a minimum, over about 1 million nurses in the next 10 years, and then not to count the physicians and all the other medical providers, nurse practitioners, to everything else. So AI, in terms of looking at it as a tool to give doctors more time. So if you want personalized healthcare, if you're able to use AI or machine learning or any of these tools to shorten the time frame to get to a conclusion, or the data sets that provide more information to these clinicians to make better and faster decisions, that's going to give them more time to see more patients. So now at that point, we have to bridge that gap of how we're gonna provide healthcare for everyone with a shortage at the same time. So that's quite difficult to do. So in going forward, I think mRNA technology right now that they're utilizing, how they were able to come up with vaccines so quickly for the next pandemic, we're able to utilize some of this technology that's coming out in what? I mean, normally it takes 10 years to come up with a vaccine, and they did it in like 2 years, which is absolutely amazing. So they're using this tech already. So in the coming pandemic, hopefully there isn't one, but if that's the case, then we can be way further ahead if we embrace this technology and have more people. So going back to the students, go into the math, go into the sciences, go into any of these areas. I don't have a degree in any of these. I have a business and finance degree, right? Economics degree, but you can still go into it and you can approach AI from all different angles, from a business use case, from a data standpoint, from a science standpoint. So all of those things combined is what makes a company, and it's a collaborative mind, right? So we're going to need everyone's mind again, to go back to it, in order to help with the pandemic. So you'll be able to utilize AI and everyone's help together. We can hopefully find a solution or keep creating new solutions.
Thank you. The other question is, who has heard of Da Vinci in the operating room? The robots, right? It's used right now. However, the hospitals only get reimbursed when the surgeon is on site. Initially, it was thought that in the combat field, it's deployed to the soldiers, and the surgeon is somewhere else in the world and performs the operation. But right now, it's not possible for several reasons. But the students would like to know from you, Dr. Inogo, how can we trust then a robot to do the surgery without any human supervision?
That's a good question. So it's like pros and cons, okay? Robotics are derivatives of artificial intelligence, which helps actually the doctors for better precision of the surgeries. And also it saves a lot of time that involves in doing any surgeries as well. But the challenge here is expensive. I'm not sure, for example, Memorial has how many, of their operating rooms have robotics. But recent studies shows that not many hospitals are using robotics, even if they are using only certain percentage of, operating rooms have these capabilities. The reason is they're very expensive, and only one company is actually leading it. They captured the market. That's why it's like, if any hospital wanted to have a robotic operating room, they have to spend millions of dollars in having one single room, since only one company is the leader. Hopefully it will go around, the other way very soon, when there will be more competition, etc. Because since it's expensive for the hospitals, getting operated on, it's expensive for the patients as well. But the technology is good because it gives more precision, especially when doctors wanted to do small type of, operating procedures in our body, under, other consequences. But right now it's expensive, but it's one of the best technologies that are derived from AI.
So during the pandemic, our ERs were overflowing with patients. We tried to help everybody as best as we could. So Dr. Bradbury, this question is for you. How can artificial intelligence help us in the emergency room?
It's a number of ways, and there's several different approaches to that, or several different parts to that solution in my mind. The first part is you have to get rid of the non-value added work. So if you have a workflow, whether it's an ER or doing what FedEx does of getting a package to the right person at the right time at the lowest possible price, the logistics theoretically are the same. So the first part I would do is something called DES, or discrete event simulation modeling. I'm going to be a little nerdy here and a little tech talk. So discrete event simulation modeling looks at workflows and lets you simulate a workflow using Monte Carlo simulation modeling, so that you can, and you can run, so say it's people going through an ER. There's a software called Arena. Google it. I think you can get a freeware copy of it or a trial version for 30 days. You can have a person or people going through that ER thousands of times in very quick simulation, and you know the steps. You have to understand the steps. So you have to actually go into the ER, work with the people there, understand the steps from when the person walks into the door, how much time is dealt with, they do the wallet biopsy, and then they get triaged, and then on through the, they go to, they see an ER doc, and they get either discharged or they get wind up in the hospital. Every step in that process. And you can, from that, you can take out the non-value added work, the wasted time, the paper handoffs. I've seen sometimes when software is down, for 5 minutes, that's going to affect the patient because something isn't working right. So you get rid of that first, and then you can apply AI and accurately figure out how much time it takes, the demand from the time of day of week, the staff that are there, and model it and improve the throughput. Sometimes part of the problem is downstream of the emergency room. So somebody else hasn't been discharged from the hospital because the doctor's, I don't know, playing golf. If that's the case, you've got a backup there, and you've got to know that, and you have to have a way of working around and making sure that that gets addressed. Otherwise, you're stuck. So you've got to really understand from the time the person walks in to the time that they are discharged, every step of that process, and then you can apply AI to find the weak points and improve it.
So now AI in healthcare and in a hospital, what if artificial intelligence makes a mistake and affects the well-being of a patient? Physicians have to carry malpractice insurance, but who is then responsible for the error artificial intelligence inflicts on a patient? And this question is for you, Dr. Yunubu.
It's that's a very tough question, but it all comes at the end of the day, like practicing ethics, because there is a lot of discussion going on in terms of AI. How far can we use AI? This morning when I was giving a presentation, I was showing the fourth aspect of AI is decision making, thinking and decision making, which should think like us, because we all think differently and take decisions differently. As of now, if you look at all the applications, what we are doing in the world is we are providing some data, historical data, and AI is predicting what is going to happen, isn't it? That's the only thing. What if, without providing any data, if AI thinks on its own, it will become one of the movies, like in Terminator, So we don't want to have that. And recently, when Google CEO Sundar Pichai said, because Google is one of the leading tech companies, they have very good research labs, etc. They don't want to cross that red line. But we have seen Tom Cruise video speaking in Spanish. Definitely that guy who developed it don't have permission from Tom Cruise, isn't it? He just developed one video and posted there. But there are independent developers, data scientists who can cross the line. Even the governments can cross the line. But we have to be very, very careful there. That applies to even to healthcare as well, because here we are dealing with the lives of the people. So we know how precious everyone's life is. We should be very, very careful. Of course, there are regulations from the governments. We, usually hospitals or doctors don't, cross that line, but it can still happen. I don't think we will achieve 100% success there. There are, few pitfalls as well, because every technology comes with few, drawbacks and pitfalls. We have to be able to accept it and be ready for that.
Then, Shantaya, the students also want to know from our experts here who are very accomplished, do I need a PhD to work in healthcare, especially when I work with artificial intelligence?
Unequivocally, no. Partly because I don't have a PhD either, right? I just have a master's degree, and I mean I should probably tell you that I mean there was a famous in LinkedIn post recently where they were discussing all the various areas from which people are coming into AI, right? And you might come in from the math background, statistics background, who tend to be more sort of probability based AI people. There's people from the computer science world where they're all about algorithms, programming, and so on. There's an emerging area of people coming into AI from the business and operational. Like I would say the nurses of the world want to get into AI, the technicians of the world want to get into AI, and that is also key. I mean, it's not to say that there is only one track to get into data science or AI. All tracks are equally important to make anything successful and make the adoption 100%. The only thing you all need to remember is that you have to be continuously learning in this field. This is an emerging field, and this is changing quite a bit. When I did my master's, there was nothing called data science. There was no degree called data science. It was just either stats and math, computational research in some of these academic universities, right? That is it. Now there is data science and there is programs and so on. There might be new programs out there 5 years from now by the time some of you, do and leave your first jobs. All you need to do is just keep learning. And, there wasn't, and I mean, you, Dr. Bradbury, you talked about Python. I mean, it wasn't, I mean, when I graduated, even, I mean, for students who know, NumPy wasn't, widely used, right? Now, you can't imagine doing anything without it, right? So it's just, keep up the pace, get yourself involved in communities, AI communities, open source communities, see what they're developing, see the pros and cons, keep using, keep learning, and that is all I think you need to get yourself to success in this field, nothing else, right? Degrees, less important.
Now that we got this out of the way, that PhD is not needed, students want to know from you, Scott, what are still skills and competencies they have to find a position in AI in healthcare?
So clearly, advanced training and understanding of how to build models, that's a foundational requirement. But just like really in any other discipline, understanding how to be collaborative, how to get to the heart of the why. Felix mentioned that in his discussion, that you have to know the mission, because first you got to know the mission, you got to know how to measure it, and then you have to understand how to test and validate that. So key skills really are foundational training, but then that continued inquisitiveness and continuous learning, because so you guys, I'm 63, and when I started in data processing, we developed in some cases our own compilers. So I mean, that's laughable today. So to think about the 20-somethings in the room today and what this world is going to look like in 40 years, I mean, I'm getting off topic, I realize that, but start that journey. But really, foundational training, and don't be afraid to ask questions. So, we've got one mouth and two ears. We learn a lot more by using our ears. So do not be afraid, to really, in some connotations, the word ignorance is detrimental, but it shouldn't be. That's just a lack of knowledge. So please do not be afraid to ask questions, and also to to seek out mentors who you can build trust with and who can build trust in you that will help to foster kind of your, maybe a challenge for continuing that discontinuous learning. So I hope that helps.
Putting back the humanity into artificial intelligence and healthcare, that's going to be our superpower, right? Because AI is going to be smarter than us, right? Every 3 months, medical knowledge doubles. So we will not be able to keep up. But we as humans can put the human back in artificial intelligence with soft skills like teamwork and collaboration, helping each other with kindness. So then we have another question for Vakir. Will AI replace the jobs of physicians and nurses? Do we have to be afraid?
Yeah, that's, I think what I mentioned earlier, that's a great question, right? I think a lot of people are scared, like you said, Terminator, AI is going to come in and take over the world and we're going to be, was it the overlords, I guess? That's what it is, right? Is that the term? So in our case, looking at this, I think Chaitanya was mentioning earlier, we can't even get Google or Siri or Alexa to do one thing right. And if you're worried about AI to go and taking over this thing, I think we're a little bit far away from that. But getting back to the question of saying replacing doctors and everything and nurses, no, I think it should be used as a tool, right? I don't see it replacing anyone anytime soon. If you're going to be replacing some things that are mundane tasks, as we mentioned earlier, yes, that is going to hopefully free up people to actually help the doctors and the nurses so we can bridge that gap, as I mentioned before, because we have a massive shortage. So going back, if I want to say, become a doctor, go into the medical science, AI is great, obviously, and go into the AI healthcare side, that would be very helpful. But yeah, see it taking over jobs in the fields? No, I think it's going to be used as a very good tool to actually assist. So it's going to be a very nice companion as opposed to a replacement for anyone.
Yeah, I agree. AI will not replace us, but the physicians and nurses who do not embrace AI might be disadvantaged. So here we go with the next generation. Dr. Bradbury, this is for you. So please answer the question of one of the students. Why should a student who's studying AI right now pursue a career in healthcare, actually?
I don't know who asked it, but great question. I got to think about that for a second. There's really, to me, you can't make, and there's no place else you can make as big an impact as there is in healthcare. We all need healthcare. It's central to our lives. Everything else is, if you don't have your health, everything else just sort of fades away, doesn't it? So, and as I said before, healthcare is 18% of our gross domestic product, which is an insane number, much more so than any other developed country. So for those reasons alone, I would heavily suggest getting into healthcare, and the more you can learn about it, the better. It is a very unique field when you compare it to other industries. So for example, manufacturing, oil and gas, retail, they all have something around, they have this basic theory around capitalism that assumes a certain amount of transparency of information around cost and quality. I can compare a Lexus to an Infiniti and make a purchasing decision for myself and my family based on that information because I have the transparency of that information. I don't have that in healthcare, not very easily. And that there's a number of historical reasons for that. One of the things MITRE does work on is help building that infrastructure and moving organizations towards that transparency. Until we get there, I think people are going to struggle with healthcare and making decisions, especially around elective procedures. So that's it.
Yeah, I agree. So the US Bureau of Labor Statistics actually says that the healthcare industry is growing. There is actually a worldwide shortage of nurses and physicians, and there's a shortage of people who understand AI. So that's your opportunity right there. So Scott, But what might be a possible disadvantage for one of the students who now are masters of AI when they would like to go into healthcare? Is there a disadvantage?
So not knowing what we don't know, okay? So as a technologist, it's always fun to implement the newest, coolest tech, because first of all, if you enjoy learning, right, you get to learn. And the second thing, if you're somewhat focused on advancing your career, having the latest tech and the latest buzzwords and all of those things on your resume, right, never hurts. So the disadvantage of moving into not only just healthcare, but really any industry straight out of obtaining this level of training is that there's this old saying that when the only tool you have is a hammer, everything looks like a nail. So if your training is in artificial intelligence, machine learning, deep learning, some of these other advanced processes, don't lose sight on the fact that, hey, maybe just a plain old, really, really complex decision tree is going to solve that problem. And we don't have to go through the effort to train a decision tree. We just have to test it from A to however many steps there are. So I think that sums it up.
Yes, thank you. And one thing I would like to add is the disadvantage of any kind of technology is what is the Achilles heel of artificial intelligence? It's electricity, right? So if we don't have any, we cannot use technology. Cybersecurity, that's something we really have to be concerned about, especially when it comes to patient data, and a stable internet connection. Yeah, you cannot wait for 20 minutes for your program to load. So now we have hopefully answered the questions for you. If there are any additional questions, we would love to answer them for you right now. If not, please connect with us on LinkedIn. We're all on LinkedIn, and we love assisting students in their professional endeavors. Reach out to us. We're here for you. We thank you very much for having us, and we look forward to the next year. Oh, I apologize. We have one. Go ahead.
Yeah, got hands.
Please tell us who you are and what you're aspiring to be, and then I'll ask you a question.
Thank you. I'm Jeremiah, computer science student at HCC. My question was partly answered to some extent, but I'll ask it regardless. Surgery robots are currently on the rise in the healthcare spectrum. However, they are faced with a limitation, the ability to only operate logically and not empathetically, which is, until proven otherwise, exclusive to a human workforce. What is, according to you, the likelihood of machines being programmed to develop emotional intelligence and have a more human touch? And by the same token, if that happens, what are the potential threats and disadvantages that we will face having machines that have a higher cognitive ability than us, having emotional intelligence? What will happen? Thank you.
That's a fascinating question. I don't know that we're going to get to that level of emotional intelligence. I'll tell you personally, so I know a few neurosurgeons, one that I grew up with his son, he was trained at Harvard. I care less about their bedside manner and more about their cutting skills if I need that level of care. So there is that bias, I'll put that out there. I think it is very difficult to train that emotional intelligence, sort of what you're referring to as warm fuzzies, essentially, into a computer. When I watch the the robotic dog out there. And then I went home and I saw the dog and the cat that we have at home. I thought, it's a hell of a lot easier to program the dog, right? Because the dog is not, it's not as graceful, it's not as smooth moving, it doesn't jump 5 times its height, but the cat is not. And so I think it's sort of the same problem when I think in terms of code. How would you program emotion? Maybe you can use sentiment analysis, some, certain words. I think maybe you could get there a little bit. But I don't think you're going to get quite to the warm fuzzy level that you're thinking. I'd rather have it trained to learn to understand when when it needs to use 3 mil Vicryl versus 5, for example, and things of that nature.
Any other question? Oh, yeah. Go ahead. We would like to add some more.
I mean, you talked about what would happen, if we tried to go down that route. I'm pretty sure all of you have like Instagram or TikTok or anything like that, right? You see a cute video of a dog, and you go into their profile and see a few more dogs, and all you see for the next 1 week are videos of dog, right? Now that's that is as good as of an emotional cue or your likes or your dislikes, an algorithm trying to predict it. And we laugh at it. I mean, we're all laughing, but that's what the state of the art is. So now that should give you a perspective on how long it'll take for us to get a little bit more warm and fuzzy on predicting what you would want and how you would actually feel and empathize with a certain thing, right? So just to put that context out.
So while we in our generation might not be able to experience emotional intelligence, empathy in AI, we're counting on you to develop that. So please go out in this world and be the change you want to see. This is your world. So thank you so much for having us.
Hi, everyone. We'll take a 15-minute break and resume at 4.
Hello. Good evening. First, I would like to thank everybody at HCC for this wonderful event and for the opportunity to collaborate, present, network, not just talk to each other. And thanks for inviting me here to this session. So I'm Ramesh Prabhala. I'm the founder and CEO of Inteltide Corporation. We are a data science and data management solutions and services provider. We are based here in Houston, but we have staff all across the country, and we also have a few employees in India and Australia, and I think a couple in Ireland as well. So we are a startup, although we started, we founded back in 2017. We have more than 25 global customers at this time, more than 60 employees, and we are a pretty fast growing company in this data space. And I would also like to give a shout out to our partner, Precisely EnterWorks, that's co-sponsoring this presentation. We have quite a few partnerships, but that's one of our very, very important and key partners. In case you're not aware, Precisely is a data quality provider. It's a pretty big company with about 12,000 worldwide customers. Just one more slide on Inteltide, and I'll move into the main topic. So like I said, we are a MDM, Master Data Management and Data Science company. Our experience, we have done more than 40 global MDM and business intelligence and data science implementations. We have a lot of MDM and analytics talent within our company. We don't particularly focus on any one industry. We have customers in distribution, manufacturing, retail, healthcare, food and beverage. We don't focus much on oil and gas at this time, but we would like to for certain in the future. And we have a very high customer satisfaction rating, and some of our customers are US Foods, American Tire, Richline, ADI, which is a Honeywell entity. So we'll get into the main topic right now. So, like I said, we are a provider of master data management solutions. What has that really got to do with AI? I'm going to come to that point if you would allow me in a few minutes. So, first thing, before we correlate data management, master data management with data science and AI, I need to tell you what master data management really is. So for that, I need to tell you what master data is. If you, for those of you that were in my session earlier in the AI panel in IT, I had alluded to this example. If you go into any Amazon, if you go into Amazon.com and pull up any product, 90% of that data that you're seeing is mastered. The product descriptions, product attributes, images, taxonomy, price, variance, those are all examples of master data. What that means also is just the sheer volume of data that Amazon really has to deal with, which brings into question, is that data of a high quality? Get one image wrong, and that's a really bad experience. Get price wrong, bad experience. Miss a variant in that example, and potentially it leads to loss of sales for the seller, right? So data quality, and you have been hearing this throughout today and potentially yesterday as well. It is incumbent for AI to work, have to have a high quality data. Just volume of data is not enough. And that's what really IntelliTrade is. That's what we do. We improve the quality of the data, and then we apply analytics and AI. We don't just do things in silo. So why do we need master data management? Now that you all understood, hopefully, what master data means, why do we need master data management? In a typical company, in a large enterprise, you will most likely see different sources of data. ERP that has product information and inventory information, vendor information, stuff like that. Customer relationship management, CRM, like Salesforce or Microsoft Dynamics has customer data. And many companies typically have vendors and suppliers that supply products or parts or materials. So they need to manage those vendors. So they have vendor management systems. These are all sources of data, and these are all disparate, spread out sources of data. So what MDM does, it collects all of this information spread across various systems and creates a single source of truth. So you have one source where you can dedupe your data, you can enrich, you can create data governance. That all attributes to a high quality data source. Once you do that, then you can syndicate that data out to Amazon, to any other e-commerce channel. You can print your catalogs. If you receive Macy's catalogs, you know that that data, product data, is coming from somewhere, right? Or you can syndicate back or send that data back into ERP to clean the bad data that may be in your ERP or your CRM. So MDM is really a data quality solution. Now, once you have that, which means a majority of your enterprise data, you bring it into a high data quality shape and format, now you can apply analytics. So you kind of get the correlation between data management and data science, right? Hopefully you do. So, like I said, typically companies have disparate sources of data spread across different systems, potentially leading to low data quality. The MDM pipeline improves the data quality, so the outbound systems receive high quality data. That you can then channel that data into analytics, data warehouses, however you want it. So why is MDM important? And this also speaks to data science, or at least the workflow around data science. You're kind of getting the correlation now between data management and data science. So some of the steps involved in data science, it's integration of data sources, modeling data and cleaning it, enriching data with rich content, and then you get to the analytics part, which is statistical analysis, mathematical modeling, all that stuff. But look at the first three steps. It is collecting data, preparing data, improving the quality of the data, and then the data science part, which is the statistical modeling, the machine learning modeling, applying the algorithms and things like that. And then you validate the data, and finally, you will apply your visualization, reporting, and things like that. So the workflow is define a problem, integrate your data sources into one, improve the data quality, then comes in, right? So now that I just laid out the correlation between data management, MDM, data quality, and analytics or advanced analytics and AI, I want to focus on some of the use cases, the problems that we are trying to solve as a company. Many of you in the data science courses, students here, you are probably already aware of this, the different types of analytics that correlates to the maturity model. There is a descriptive analytics, diagnostic analytics, predictive analytics, and the prescriptive analytics. AI really talks about prediction and prescription. But to get to that point, we still need to do descriptive analytics and diagnostic analytics. So descriptive analytics is about describing data, the what, the where, the why of a data. And I have an example here. Let me see if I can browse it. I switched the screens, but I'm still showing my PowerPoint. There you go. Okay. I think I just had to come out of the presentation mode, switch the browser. This is an example of descriptive analytics. It's a visual representation of it. I really want you to focus on what we are seeing here. It is describing, if you look at this particular source here, MDM, Master Data Management, the blue, we are basically scoring data quality. That's all we are doing here. Visually, we are representing data quality scores of items or products within an enterprise. The blue means an item has a higher data quality score, the red, a low data quality score. But this is, it's describing a problem. Do I have really a problem or not? The red means I do have, anomaly, I have a problem with my data quality. The blue really implies I probably don't have much of a data quality problem, right? So I'm describing a problem. That's all. I'm not diagnosing it at this point. Now I do want to diagnose it. I take the next step, right? What do I do then? As I drill down more and more, now this breaks down my data quality scores by certain metrics. I'm looking at my fill rates. I'm looking at my error scores. I'm looking at different KPIs. Now I get to the part where I'm being able to diagnose why I may or may not have a data quality problem. If I have a data quality problem, is it because a lot of my products have erroneous content? Is it because the fill rates are low? Or is it something else, right? So I showed you an example of a descriptive analytics. Now I'm getting down to diagnostic analytics. And the next step I'm going to take after this is predictive analytics. So going back to my presentation, predictive analytics. So I'm going to show you a few examples of some of the work we have done on the prediction side of it. Prediction and classification. So look at this example. This is a typical AI classification problem. Remember that example I had mentioned when I was talking about that Amazon example. If you categorize that product in an incorrect category, you're going to lose sale because customers that come looking for that product are not going to find your product in that particular category, right? Now, as a seller, if I was dealing with 10 items, it's an easy problem to solve. I can just manually go into each item and I can basically just validate if it's in the right category or not. But none of my customers sell just 10 items. The smallest of my customers deal with 300,000 items spread across multiple categories. This is a huge problem, just dealing with the sheer scale of the data. It is impossible for any human to go item by item by item across 300,000 items, validate the category, then do it all over again in the next season or next year. Very difficult, right? Now, 300,000 is a very small data set, by the way. We have worked on data management solutions where some of our customers have 30, 40 million items, 30, 40 million SKUs. Amazon itself would be dealing with millions and millions of SKUs, right? So you're talking about a massive problem. AI can help. And this is that use case of classification that can help. What we are trying to do here basically is the blue dots and the red dot. The dot is really a product. This machine learning model is scoring, looking at various inputs. It is trying to indicate if the item is in the right category or in the incorrect category. It's a scoring. That's all it's trying to do. So the blue dot indicates that the model thinks that the item is in the right category, and the score is basically its confidence level. The red dot is an anomaly. The model is saying the item that you map to a category, I think is in an invalid category. And I am that much certain that it is invalid. So this map here gives the human an ability to go and look at those red dots and validate. That's all they are going to do. Validate if the item is indeed in the right category or not. And then the model is learning. It is a supervised feedback learning model. Now, the other classification of problems, ties to the classification AI, is image classification. I think you have seen, you heard a couple of panelists in the past today talk about image classification. It is a problem of scale. It's very similar what we have done here to the taxonomy classification I showed you before. Basically, we take images, we do image detection, image classification. We use things like the Google's Vision API, and the model basically validates if the image is in the proper category or not. And the probability here, like this image 595, it is mapped to a category called beats. The model thinks that it should really have been in a category called settings. And the probability, the model says, I'm 99% sure that you map that image to an incorrect category, right? That's a classification problem. Again, this comes in supervised training models. Now I'll show you a prediction problem, a prediction use case. I spoke about this in the morning in the AI in IT session. You're seeing this quite a bit in our own industry. Companies entering wrong pricing, right? And it is really difficult to validate a price attribute because you could be discounting a particular item to such an extent that there's a big deviation. It's a valid use case. We have seen circumstances where some user went into an ERP system or maybe on the e-commerce on their website, entered an incorrect price. Customers ordered against that item, and then somebody found out that the price was incorrect. It was deeply discounted. And now my company is in a pinch because they have to recall the item, they have to reimburse the amount. It's a customer satisfaction issue. It is a lot of loss of sales. You have heard this over and over. I'm pretty sure about this. I mean, come Thanksgiving, you will hear in the news a lot of this happening, right? And we have seen this with our own customers too. Once again, AI can come to the rescue. What in this model indicates that particular product, at the top, each bar is a product. It's telling me this particular product has a current value of $21, but the predicted value is $121, which means there is a 100% deviation between current price and predicted price. Now, it's again not telling the user whether that is correct or incorrect, but it gives us the intelligence. It gives the human the intelligence to go look at the deviation and determine if there is indeed a problem or not, right? That's a prediction model. Again, these are all supervised model. So to get to this point, the data quality is extremely important. So that's what we do. Like I said before, collect the data, analyze the data, apply intelligence, analytics, AI, then you apply the visualization and the production of that model into the application. Now, if you are as students, there are job opportunities in each of this workflow that I just mentioned. Describing a problem needs business analysts, project managers, data analysts. Integrating data quality needs data engineers, it needs programmers. Then comes the data science, the AI part of it. Obviously, it needs AI, advanced analytics skills. You need that data science math guys, the statistical guys. And then the visualization part, right? You would need Power BI, Tableau, or just pick any choice of your reporting solution. So just because many of your students don't just focus on just the statistical Python, all the cool stuff, all across the spectrum, you have opportunities to learn, you have opportunities to apply for jobs, right? So I'm going to wind this up with just a very visual representation of that predictive model that I just showed you from the data. We apply AI, we applied for that particular use case, we applied AI-based feature processing. So we took different attributes or properties of that item. We took description, price, weight, suppliers, and a few other attributes. We build the model in such a way, we fed the data to it, all of these attributes, the model learns, it is supervised, and then it applies that model to real-time data, it scores, and then offers a predicted category, and any change of that category by the user, right or wrong, goes back into the model. So it's a supervised learning feedback model. So that was what I wanted to talk about. I didn't want to take up too much time. Hopefully I just shed some light on some of the use cases of AI that we are trying to solve. I mean, there are a lot of cool things out there, right? We are talking about AI in oil and gas, IoT, driverless cars, and all that stuff. But there is AI's application all across the board. It's not just that stuff alone. So I'll take a few questions and we can wrap up. Thank you.
Anyone has questions?
Just quickly, how many iterations would typically satisfy a customer that it's good enough to go to the show?
Yeah, that speaks to the validation of the model itself. First thing is we set expectation with customers early on that the model is not going to be perfect. Typically what we have seen is we get about 75% efficiency the first time, but our holy grail aspirational efficiency is more than 90%. It does take a lot of iterations to, what we see is the volume is really important. If you have 1 million records, just updating and changing 10 records is not going to move the needle as far as the model's validity is concerned. So it takes time for us to keep collecting the data over and over. Sometimes it can take months before you see the model moving in terms of the efficiency. So we do set the expectations, and that's where the human interface is really, really important. So there is no magic here, right? Everything that I showed you today has to be validated, reviewed by a human before a decision is taken. So we are not at a point, at least as a company, we are not at a point where everything I told you about is descriptive, diagnostic, and predictive. You will notice that I did not talk about prescriptive. We are not there yet. Our models cannot prescribe a solution. It can show you anomalies and stuff like that, but it's ultimately the human that needs to take the decision.
Okay.
Yeah, we are close enough. Yes. So there are three types of data that's really important, and I should have maybe mentioned this in the beginning itself. There is master data, product descriptions, names. I mean, my name, your name, our SSN, address, these are all examples of master data, and products have master data too. Then there is transactional data, purchase orders, inventory. These are examples of transactional data. And then there is reference data, which is data that you just cannot free text. It's data like states of this country, right? These are called reference data. The data is fixed. You have to select from the list of values that are already there. So big data encompasses all of this. The problem is that's a part of data science, even in the academic domain, that people don't kind of focus on. They make it sound like every data is the same. It is not, right? Each data has a character to it. You have to separate out and identify master data and transaction and reference data and apply it differently. But yeah, to answer your question, it's all part of big data. Yeah.
Question here.
Yeah.
I'm curious to know what type of translation APIs you use. Say, if some of your data is in Indonesian, for example, and you want to translate it to English.
Yeah.
What APIs do you use?
Well, we are just getting into natural language NLP processing. There are engines like Google Translate. Today, we haven't applied it necessarily to AI at this point. We are just using it to translate our data into multiple languages so consumers can consume it in different languages. We are just beginning to get into NLP and all of that stuff, but we are not there yet. Sorry, I wish I could have answered, but I can connect you with my data scientists. We have done things like that in previous projects. We can help you out. If you have questions, I'll be here for another 5-10 minutes. Please feel free to hit me up.
Thank you so much.
Thank you. Hey, thank you.
Johnson, and she'll be leading the charge. And take it away.
Thank you, Dean. As he said, my name is Maturia Johnson. I work in digital information technology, COE. Also, I am the program advisor for women in technology. And so it's an honor to be here. I want to, first of all, say to CSA that I'm extremely proud of you all. I remember when I received the LinkedIn message from Denzel. It was at night. I really hadn't been coming out because of COVID, but because as a student, he asked, and so I responded. So thank you very much. It's been a good journey. As Samir said, that our topic is diversity in AI. But first of all, I also want to tell the Dean thank you for helping all of us. So last week, the Dean and I were at the Greater Houston Partnership State of Technology. And the CEO of Greater Houston Partnership, Bob Harvey, he made a statement. So I'd like to read it to us. He said that a couple of months ago, or maybe last year, he had an interview with the CEO of HP. And as you all know, HP has moved their headquarters to Houston. And when Bob asked the CEO why, this is what he said. Antonio Neri stated, Houston's diverse talent base and low cost of doing business was a key factor which caused them to move their digital hub and global headquarters to our city. And I just thought that that was a great statement since we're talking about diversity. The other thing is on the healthcare panel, we kept hearing them say, we're going to need everyone's mind to solve the problems, that there was a massive shortage in AI. And so that's how I'd like to kick us off. So next, would the panelists please introduce yourselves, and then we'll take it from there.
Good evening, everyone. I'm so happy to be here. My name is Nargis Tibari, and I've been in the teaching profession for 32 years. However, another job that I have is a lifetime learner. And before being a teacher to my students, I'm a teacher to myself. I'm very happy and proud of, I see the organizer, these are my students. I know how busy schedule you have and may not have been sleeping for the last week or two. Greatly to be happy here and greatly appreciate that.
Thank you. So good afternoon. My name is Jean Leah Njoroge, and first, I am delighted to be here. And second, I think I was asked, a colleague of mine asked me, hey, Jean, do you want to speak at the Diversity AI conference at HCC? And I was like, oh, okay. But then I asked, what day is it? They said it's Saturday. So I've been working diligently with Ayomide, yeah, to help me, to guide me through this, the whole conference. And as soon as he said it's Saturday, all I knew it's Saturday at about 4:30, and I was like, okay, I can drive from Austin to and be here. So I'm happy to be here. So in terms of my career journey or my background, I'm a director of conversational AI and natural language processing at Lowe's Home Improvement. And prior to that, I was a principal data scientist for Dell Technologies. And in both positions, I have stood up the data science and AI departments. And that's what I'm doing right now at Lowe's. And of course, I'm looking I'm hiring some people. But my background is I have a PhD in computational material science. I used machine learning algorithms before everybody started using that. I used CUDA and NVIDIA technologies way back then, right? But I'm an engineer by training. I'm a Bachelor of Science in Chemical Engineering and my PhD in material science. And of course, I have some sort of business background as well. So diversity in AI is a topic that I can speak about all day, every day, because it's something I live in, it's something I fight about, and it's something I'm passionate about.
Good evening, everyone. I am so excited to be here. Thank you guys so much for inviting me. My name is Angel Bush, and I'm the founder of Black Women in Artificial Intelligence. I took an unexpected route here in terms of artificial intelligence. I actually did not study artificial intelligence, and that's, we're going to come back to the importance of Black women in artificial intelligence in a minute. In terms of my background, I have a master's degree in administration with a concentration in community development. I attended Central Michigan University, and I also attended Harvard University. So again, I'm certainly excited to be here and share this conversation with you guys.
Good evening, Ariana Smetana. I'm also excited to be here. Thank you, Samir, and for involving me in this wonderful panel. Kind of like most of the ladies, my path hasn't been really straight to that. I have an economics degree. I'm actually at the moment a consultant, which is focused on strategy and advanced technologies on urban developments and design. I have been in the corporate world and in energy, being in Houston, and then I shifted into my own business as an entrepreneur and continue developing in the AI field as my last 2 years been studying and working with developer to implement AI strategy in the business. But my passion is actually also diversity, and then I was part of Women in AI last year as a partnership director. That's how I got involved with HCC and Samir and Denzel, and really enjoyed introducing my passion into my work and bringing diversity topic to forefront. Thank you for having me.
Ladies, for the introduction of yourself. So the first question is, what does diversity mean in artificial intelligence? And Ariana, would you please take the first question?
Yes. So the diversity to me means a couple of different things. Certainly, it's not only what typically we go towards is gender. It could be, different minorities, but it's also, diversity of thought. And I believe that in machine learning and AI as application, it's really about problem solving. And in problem solving, we need to have diversity of thought and diversity of people to solve the problems we're facing today. Machine learning and AI I see as a tool. And most of all, it's important that we have diversity of data. Sometimes the data, like we all heard it before, if garbage comes in, garbage comes out. So data is an important factor, making sure that the right data comes in, we're solving the problems with that data, and machine learning is a tool for that.
Diversity to me is certainly diversity of thought, diversity of intellect, but also diversity of experience. When we talk about diversity, I know we focus on gender and race and all of that, but we also have to understand that there's going to be a diversity of intellect. There's going to be diversity of abilities. We've all been born with various abilities, but they're different. There is a diversity in that, and we have to bring that in order to solve the world's problems. We have to bring that diversity into AI.
Jean?
So I think both ladies have answered, diversity in AI, thought, experience, just demographics, and I think it's also important to just have like diversity in problem-solving skills, right? When people get together, some people are creators, some people are critical thinkers, some people are just visual, right? And so having, just diversity in the talent pool or in solving a problem, because what a problem is not linear, right? There's so many dimensions to it, and injecting diversity in the skill set, I think, enables us to build better AI solutions.
Me, the diversity is the cultural and geographical diversity in AI. For example, it is the same data set. You process it, you manipulate it, you run the machine learning model, but the conclusion that you get, it's different from culture to culture, from geographical location to geographical location. If I do the same process to the same data set in my country, most probably the conclusion that I will extract from it, it will be different from the need that we have here in the States. So I see diversity, cultural diversity.
I think that is a great point. Marcus, you have the next question. It says, why is diversity in AI important?
So when we look at diversity, from my standpoint, I look at it like a child. When you feed the child the right food, it will grow, the child will grow to be a very fruitful and effective person. Diversity and diversity, the British accent and the American accent, I've been exposed to both, so diversity and diversity. So the diversity, it's also like a child. If we feed it right in an institution or an organization, it is going to have a very positive, effective output to the company. However, if we don't meet the purpose and the need of diversity in a company, it can easily lead to bias. And that is a harmful and negative effect. So cultural diversity, population diversity, IT need diversity. Okay, I am an experienced person. Do I need a junior data analyst in the company? Of course I need. That comes to experience diversity. So in my opinion, diversity is not just an important part of the AI, it's a must for the right growth for the future of any company or institution.
Very well. Jean?
I think diversity is important in AI because we're dealing with people, right? We are building solutions, we're collecting data that we want to get into the brains of people and understand how they're thinking, what their buying habits are, right? And so being able to remove the bias out of the data, out of the algorithms, and being able to understand that however we're building these solutions, it's people-oriented. And usually sometimes I just like to call it augmented intelligence because as much as we say it's artificial, I don't think we'll ever remove the human, the human aspect of it in AI. And so removing that bias in the data, removing the bias in the algorithms, and I think a good, I don't know if any one of you have seen the documentary on coded bias in Netflix. I think that's a good example of just why AI is important, where the student at MIT, was trying to have her facial recognition, to use a facial recognition software, and because she's a Black woman, the software wouldn't recognize her face, because the algorithm was built with a training data set of a Caucasian. And so there was no element of, the black face being recognized by the software. So those are some of the things that, to me, why diversity in AI is important, because it injects different diversity of thoughts of humans in all intersectionality of what we exist.
Diversity in AI is important because we have to understand that this is not a black box. Someone is behind the scenes, whether you're creating a robot or whether you're creating an algorithm. So there is a person in the loop. And as the doctor just talked about, when we read the books of algorithms of oppression, when you Google Black women, try that at home. Don't do it here, and don't do it on your work computers. Google Black women and see what comes up. It is important that we understand what these algorithms are doing and that we work to mitigate what will happen in terms of facial recognition and things of that nature. There was a young man in Detroit who was arrested because the algorithm said, "This is you," in front of his family, right? So he had to prove that he was innocent. And that's not how our justice system works. At least that's the last I was told. It doesn't work like that. So we have to ensure that there is diversity when we're coming to these tables and creating these algorithms, because when you don't have diversity, you have issues like this where people are harmed in a way that how do we get him back his freedom? How do we get him back his reputation when he's been placed in jail because of something of no fault of his own? So it's clearly important that diversity is very important in AI.
Like all of you said, I can echo the same sentiments. And I would add to that it is important because also the type of problems typically certain groups will be solving. They might not be interested in the problems that other groups may have. And if we have diverse group of people working on problems, we will have much more input from that group. Likewise, we will solve those problems. Women's problems often are not addressed in medical field, or they're been tested on different groups that truly don't represent what women are and certain groups are. So there's many levels of problems that data itself is the problem. And then we have our human bias injected based on the people who are working on those problems or who are in the field of data science or engineers, which typically are not representing the diverse group of all the people who will be addressed in these solutions.
You have the next question. How can we achieve diversity in AI?
That's a big question, and I think it will take lots of minds put together and discuss this, and hopefully between academia and enterprises, and likewise all the minority groups, which might not be represented typically in those two categories, needs to be part of the conversation. One of the organizations, like I was involved before, was Women in AI, certainly Black women in AI, and there is there is AI for All, which is another organization trying to be very inclusive and educational about what AI is, make it accessible to people, first understand what it is, applications, what it means, and then also, opening these STEM fields to everybody who can be educated, who wants to be a part of this. And not only through the academia, maybe even courses or certifications. Like myself, I went to certification route instead of getting a degree. And I think the not limiting to be technical, I think needs to be various fields involved as well in this process of using AI as a tool.
Angel?
So how do we achieve diversity in AI? That was a question. So I think for me, it starts with the data, right? The data sets that we are creating, because most of the time that's where the bias begins, right? And so from a practitioner perspective, I'm very much interested in areas where we can start identifying and looking at the data in a more in a more raw format, in a way that we're identifying some anomalies that can help us understand if there's bias in the data. So that's the first one. And so the second one is within the models themselves, right? We're building this, we're using these algorithms to build these models, and we can also inject bias there, right? And so instead of using black box models, I think it's important to approach it from an explainability perspective. And I know there's a lot of body of work in the maybe last couple of years where trying to understand explainable AI in a way that the common person is understanding what the algorithm is doing and why they're doing why it's doing what it's doing. So there's a whole body of work that includes the explainability of AI. I mean, and of course, the third one for me is just a diverse talent, right? When we build these teams and when you're in a position of power or, of leadership, making sure that you're looking at your team in some sort of diverse way, diversity of thought, diversity of education, diversity of, demographics and geographics, in a way that everybody is heard and they understand that there's a whole aspect of when we build solutions, it affects the human race.
So how to prevent or how to achieve diversity in AI? Okay. Right. In my opinion, the same way that we actually prevent a machine learning model from being biased toward the data, and we work to make the model more intelligent, we need to do the same with ourselves. We need to be vocal about diversity in AI. We need to advance our knowledge. We need to raise our intelligence the same way that we do it with the model for machine learning. So we need to do the same in our living environment to actually push in diversity in our environment.
Very Angel, the next question is for you. You have a very interesting background, and so would you give us a living case study on diversity in AI?
Well, a living case study would be actually Black women in artificial intelligence. Black women in artificial intelligence, the genesis started in March of 2019. I attended an Internet of Things event, and I looked around and didn't see a full reflection of myself or a full reflection of what it would take to allow access and opportunity in this space. And so as I'm looking around and I'm hearing, artificial intelligence, it's the fourth industrial revolution. And again, I'm looking around, not seeing a full reflection of myself. And it came to me, you can't have a revolution without Black women. And that was the genesis of Black women in artificial intelligence. We've been in existence for 20 months. And we're on 4 continents: North America, South America, Europe, as well as Africa. We have established wonderful relationships with Amazon, Capital One, you mentioned NVIDIA, as well as Swoon and Expedia and other companies. We are a living case study of diversity in artificial intelligence. And our mission is to educate, engage, embrace, and empower Black women in this sector. And one of the things that we make sure when we're going into our partnerships is that first, when people come to us, and certain people come to us in different ways, but when they approach us, we tell them, we want you to know the vision, educate, engage, embrace, and empower. We want you to understand the vision, educate, engage, embrace, and empower. And lastly, but certainly not least, we want you to trust the vision, educate, engage, embrace, and empower. Because when you trust the vision, you will tell someone else about it. So that is the living case study of diversity in artificial intelligence.
Thank you. Thank you. Any final words? Jean?
So my final word to me is this is a very interesting field. It's growing. You know, I've been in probably working with data for maybe 10 years now, and AI 10 years to come will be what we're seeing right now. And I think if you're studying in this different field, so think about establishing yourself in a domain expertise, right? Have, you know, healthcare plus AI, or, you know, energy and AI, because then AI will be part and parcel of each domain, but then we'll still need the domain expertise to build these systems.
Marcus?
So my last word for, I see a lot of people here, but students, not very much. However, I am going to make the suggestion to the students. So if you are going to the AI field, AI brought with itself a new concept of a work environment, and that is the remote environment. So working in a remote environment needs a highly soft skills, teamwork. Therefore, if you're planning to go to the AI area, although it's one of the loveliest area so far for me, but you need high soft skill and teamwork, because you may work on a project globally. People are everywhere and you are working on the same project. So teamwork and soft skills comes very, very much handy in this area.
Ariana?
My closing remark would be that, you know, AI is just on the brink of really changing the landscape for any industry. And it's not only energy, it is not only healthcare, it's dominant maybe in Houston, but it will change the landscape of every industry. So just look for your passion, look where you want to apply your knowledge, and you can be part of AI regardless of your degree. And that's my belief. And, you know, just get engaged with the right organizations, enterprises, and academia, and we can all make a difference and change.
Very nice. Are there any questions? Yes.
This is a question. Bush. On TikTok, there is algorithm where users, I'm a little nervous, Black and brown users are being bombarded with videos of the mistreatment and suffering of people of color, while white users are being shown videos of dancing and challenges and things like that. I guess my question would be, how would these corporations react when a person of color working for them would bring up this issue and try to fix it? Would it be denial that this problem in the algorithm doesn't exist? Or would it be to listen and actually try to fix this issue?
That's a very good question. It depends on the company. I think it was Microsoft. They created this bot on Twitter. And within hours, the bot was racist and said a lot of things. You know, again, this is Twitter, so it's tweeting out all of these different things. And they had to shut down that. So the response is based on the company and their corporate culture. And that's why it's important that there is diversity in AI. So somebody can tell you, as someone mentioned earlier, it's not always important to create something. You should ask the question, should I create this? Is this important? Is this algorithm that I'm creating, is this important? Is it going to move, you know, really, is it going to move people forward? And so unfortunately, that's the best answer I have, because I really believe it's based on the corporate culture, whether someone's going to say, we need to stop this, or, hey, you know, we're making money and that's what it's about.
So there's a whole body of work that's coming up within the ethical AI space, right? And most technology companies are starting to incorporate a department within the ethical AI space. In addition, I think the Congress, you know, they're starting to think about policies within, you know, the whole aspect of ethical AI, because we can't just create like, you know, unruly bots that can go, you know, and tweet whatever they want. But anyway, maybe Elon Musk will get rid of the bots and authenticate the humans. So we'll see.
Anyone else?
First, I just wanted to salute the ladies on the panel. Thank you all for coming and being here and sharing your knowledge. I wanted to add to Ms. Angel's point and ask a question. She mentioned, you know, the fourth industrial revolution can't start without Black women. I agree with that, and I will add, I don't think it can start without Black men either. We're all gathered here today because a Black man took initiative. Let's remember that. But what I wanted to ask you was, specifically for Ms. Johnson, Dr. Jean, Ms. Angel, what can we do for our community specifically to better help the youth get involved in this space, in AI, and STEM in general, since we know we're lagging behind if we look at the numbers? What are some of the things we need to start looking at to make sure we're getting young Black women and men involved and not left out of the conversation?
Okay, so this whole area of AI, for me, it's not only just STEM, right? It's the creatives. One of the things that you know, we are seeing in the industry, and I'm also a part of like Back in AI, you know, Chris Hopper and all those women in tech, is I think maybe in the past 10 years, we've pushed STEM so much, right? At the expense of the arts. But the arts is a creative element of it where we visualize the data. So visualizing the data has been one of the challenges that we are facing within the industry, because we need the creatives, right? It's been almost 6 months for me trying to hire a visualization person to help the data scientists be able to visualize and communicate that aspect of, you know, of the AI solutions. So I think, to me, it's a balance between what they're passionate about. If somebody is very good at playing games, hey, why can't we push them to create the games, right? These are the games that they're playing. And those are the people that help us understand how to create new features within the games, right? But why can they be the one to create the games, right? So put them in gaming camps, right? Or if somebody is just, I have my niece, she's very good with like the drawing and stuff, like the creative aspect of things, creating videos and what have you not, right? Put them in some sort of creative elements, because all those things come together within the soft skills. But I think it's a balance between the AI. So we've pushed the STEM so much, but I think we are seeing the creatives and the arts coming up to balance that.
I would say, and thank you so much for organizing, stepping up and organizing all of this. There is an organization called Black in AI. So you certainly can join that organization. So we aren't going to leave you out, sir. Definitely not going to do that. But I will say that artificial intelligence has a PR problem. When we think about artificial intelligence, we often think about the technical aspects of it, and we kind of give this, again, black box high level instead of speaking to people where they are. And I think that's how you attract anybody, really, to artificial intelligence, and you provide that access and opportunity. And one of the things that I tell our members is, I will never guarantee you a job, never, but I will guarantee you access and opportunity. And I think that same vein works when it comes to inviting younger people into artificial intelligence, whether that's via robotics or data science, although we know data science is not artificial intelligence, just for the sake of the conversation. I think those are the best ways. Work on that PR problem with artificial intelligence and bring them in and attract them that way. But I do have another organization, and I'll tell you later, that you can work with that's working to bring more minorities and young people into artificial intelligence. They had something to do with the versus thing, so I'll let you know about that.
That's a great segue. Denzel, I saw you, you all know that I'm very proud that my whole Willow Ridge class was here yesterday. And I'd never taught at a high school before, and I was nervous, and it was COVID, and I hadn't really been out, And so I got over all of that, and it's been a wonderful experience. I'm teaching them our database concept, theory, and design, and I'm using Oracle Academy. And the first part of it was all theory, and I had to do all kinds of things to keep them awake, yada, yada, yada. So over the semester, we're coming to the end, and Miss Johnson has worked all of her magic and used her superpowers to make them fall in love with me, okay? So much so until they had a big yellow bus out there, okay? But you did something yesterday. I always go around the room and ask the students what they want to do when they grow up. And one young lady, she was Hispanic, okay? And she said out of all of these computer science people, she wanted to be a neuro something something. I'm like, I don't really know what to say to her. But she came to me yesterday and she was hunting and looking for you. And so I brought her to you. And your whole demeanor changed, standing there talking to that young lady and telling her about stuff, artificial intelligence and whatever you was talking about. I was like, oh, that's just too heavy for me. So I turned around and I walked away. But then I pulled out my phone to videotape. So part of the answer to your question is that you have to be involved and give back. CSA, you all actually owe Willow Ridge at least a virtual thank you or something because they were thrilled to be here. So you have to start and think about what you can do to help your people. And I'll leave it at that. Yes.
So, second, Ms. Johnson, about the getting the youth involved and making them interested in the area, we need to start from early stages. There is no doubt about it. Knowledge will empower. We used to say, oh, everyone is saying knowledge knowledge is power. But in these days, it's not just a saying, it's a reality. When you have the knowledge, you are empowered. I'm talking out of my experience. Being a woman, sometimes in a room with all male, but I can feel the confidence when I have the knowledge. I can stand up in the room with all male and talk when I know what I'm talking about. If I don't know, I will be feared to stand up even. This is one thing that we really need to start the education from early stages and change the culture that you can do it regardless of if you are a girl or boy, you can do it. Second, we need really an inspirational role model that we can look up to. That is also, when I see my mother or my sister is doing it, why not me? I can do it as well. So these two areas, we need to really work on them. And thank you. I thank you for these questions, Denzel.
Ariana, close us out. Take whatever you want. Do our second closing, okay? And address Denzel if you like, whatever, however you want to wrap this up for real this time, you have the final word.
That's a little pressure.
Exactly.
Well, I have to tell you that don't be scared about AI and start from any end you want to be involved in. I come from, like I said, I have an economics degree. I was creative, so I'm still creative. I'm also, left brain, right brain thinker. I like to kind of, go from one end to the next and learn. One thing, actually, the most important thing is just learn. Continue learning, be curious, and that will take you anywhere you want to be. And don't fear about the age, the color, or anything like that. Even though, sometimes on the surface, you think that I would have all the advantages, but I don't. I get judged on different levels. So we all have some prejudices against us. So don't fear that, just move on and find a group of people that will understand you. Like I found Women in AI, like my other groups that I'm part of. Continue learning and you will find your path and success in your life.
Wow, they got really deep, y'all. That was great. Well, let's take a picture of you, please, if we can, and of you all, front, please. Yeah, standing together.
Come on, any? Go in the middle. Yeah, anyone else? Dana, Dina. Yes, yes. They saved all the best for last.
Thank you, ladies.
Thank you so much. It was really a great panel. So much for that.
Thank you, Angel.
Thank you. Thank you. Yay, finally you guys. So nice, actually.
You see, these are my students. They're thanking me.
That's wonderful. Okay.
Come on, my student. Come on, let's take a picture. Oh, yeah. Samir, can you take a picture of
Always in the class.
Y'all did amazing, by the way.
Students always teaching in the class.
Yeah, really. Come on, come on.
Keeping students in the class.
I had to ask.
Then come on.
I had to ask.
Oh, where is it? Oh, you don't.
No data science students.
Come on. Oh,
But really, guys, very great though. Everybody's
He just said he had.
After 5 minutes.
Yeah.
I know you.
Therefore, I was thinking, Maya, oh.
I see.
Oh, okay, that's what happened?
Can we call? We're done?
Yes, it's done.
I mean, let's take a picture. Can you? Oh, yeah. Okay. I want to take.
All right, y'all. Well, we're gonna say a few thank yous. It's been a long 2 days, but so worth it. Just endless hours. I'm amazed at the amount of teamwork that happened to make this happen. We're not a professional agency that just does this. Remember, they're students. We are now. They're students that, they work all the time. They're studying, of course. And they were planning this, in between hours, So just really thank you to all of you. I'm so happy about all the connections that we made. And, we're really connecting the dots. So we are changing Houston's future. Just proud of everyone, really. And, like I said yesterday, these two, if they don't get a job tomorrow, I don't know. Those companies are just losing their minds, So I know they'll land something, big soon. And in like 2 years from now, they'll come back as like, super something. And yeah, just really, really proud of them too. And all the board members, of course, CSA. If you're a student interested in getting involved, please join CSA because really it really has been our diverse power that's made this happen, really. From Denzel, really motivating everyone during COVID, bringing everyone together. And just these two have a sort of bond now that they'll carry on forever. And, I've worked with so many people in my life, and I can tell you these are top 10. So they're like family to me now.
First, I want to thank everybody that came over these past 2 days, everybody that Sat through these long hours, these panels, we got some great information. We started planning this in January. Usually these things take 7, 8 months of planning. We did it in like 3.5. We promise next year will be better, more organized. But the turnout that we got, the amount of relationships that I've seen in my face that got built, you know, people, CEOs, data scientists, machine learning engineers, people that were here presenting, that were able to connect, that had no idea about each other before this event, will now be able to walk out of here with connections, and they can do business moving forward. And that's why I wanted to do this. This was for the students. This is so they could get information, this is so they could learn about AI, this is so they could get a foundation in AI. And I just want to thank everybody that helped put this together. Got to thank the CSA, all the board members that worked hard for months, neglecting homework, neglecting sleep. Sometimes we didn't sleep trying to put this together. We still owe some of our professors some homework. We'll get that to them as soon as we can. And just everybody that put in effort. Women in technology, they helped us. LSAMP helped us. The faculty helped us. Like, everybody put some sort of effort in. Even the HCC Foundation, Miss Christina back there, she did an excellent job. And just so many people put time and energy into this. And we just want to thank them. We're going to do this again. It's going to be something we do annually. And I'm glad we're able to kick it off. We're able to start something. And I just want the students to know, don't ever be shy about creating something. And don't ever feel inferior because you're a community college student. We just proved today that you could do anything. You had people up here that talked, that went to Harvard, MIT, all these schools, Rice, that people that dream to get in or dream to go to or even walk on the grass at their campus. And they got to be here and they got to talk to you all and they got to give you information. So just take that with you moving forward, build some relationships, keep networking, make sure you get some of these people on LinkedIn so you can stay connected with them. And we're going to keep doing this, and everybody just join the CSA as well if you're an HCC student, and just continue to work, continue to learn, and continue to grow. It's all about trying to become the best version of yourself. So I just want to thank everybody that came out, and I can't wait for next year, and we're just going to keep on moving.
Pretty much Denzel has spoke about me. Okay, firstly, thank you everyone, especially the sponsors, volunteers, and all the attendees, the panelists, presenters. Everyone, thank you for attending for the 2-day conference. This was relentless work, relentless sleepless night work, strenuous effort by everyone, task force, board members, Dr. Barillo, Dean Samir, Denzel, Zan, Christina, everyone, Ms. Johnson, everyone, Dr. Nargis, everyone has like put us all strenuous efforts for hours together. I can never forget, like, we were sitting like around 20 hours each day, late in the night, 4 a.m., all in the Teams meeting, working on the brochure. I can never forget these memories. Then today is the last day to work out for sleepless nights. I'm not going to do anymore. So that was really great. Zen has put a lot of effort in that, in making the brochure, sitting all the nights together, getting sick. But this is all for a cause. This was our first inaugural conference, which we all have dreamt in November, and here it is. It is so successful. I'm so happy. I myself have spoken to many of the industry professionals here, academic professionals here yesterday. Everyone was like, we got like so many offers saying like, we want to make a conference with you in November. Are you available? Are you free? So that shows the success of this first inaugural conference, like how much hard work we have put in. And this is all we really wanted. And I would also thank Dr. Brown, Mrs. Brown, putting all the efforts in this and you motivating us. And the professors, really sorry, we are delayed in the homework a lot. We really want to sleep on Sunday. Please give us a Sunday. We want to sleep well. We'll be back on schedule again from Monday. And there were days like we used to go and just nap in the class because we never had a time to work on our personal things or homework. So that much strenuous effort we have put in this. So everyone like CSA, WIT, Dr. Barillo's team, Dean Sami DIT team, everyone has put into these efforts. The best part was everyone has taken it as their own event. It's not like a college event. It's my own event. I need to put efforts in this. So that shows the team success. So that I'm really proud of it. And I really want to thank HCC and CSA for giving me this chance, because without joining HCC and CSA, I would have never been here. I would have never done all these things. So I got a great networking contacts today. I hope all the students would have got that. many companies were really shocked, and now AI program is known by everyone that HCC has the best AI program. HCC is the #1 in all in the whole Houston, which is doing such a good conference. So everyone was so amazed by the conference. The compliments which we got today and yesterday, that gives us a lot of happiness than anything. So we always say the whole CSA board, they have relentlessly worked for hours together and all. So I really thank everyone, especially the volunteers, CSA and all. This is going to be an annual event. We will work for hard again next year. You will see much more success, much more good upcoming events and from CSA and for the AI conference also. So thank you for giving me this opportunity. Thanks, Dean Samir. Thanks. Thank you. Thank you all. Have a great day.
Clark,
Get up here, Clark.
it's not just us. What is this? Or is there anything you want to say about the essay, your experience? Dina was huge help. Then, of course, Robert, Ray, phenomenal job. The AV team. Let's clap for the AV team, really. Yeah.
Yeah, you have to come in better.
Oh, yeah. He's on the.
Call Mari.
Hey, Mario, I know you can hear us. I know you're on the camera. Come on. Go on the stream, bro. I know you hear it. Yeah. He'll be here in 30 seconds. Got $1 million for you, Mario. Listen. I need this. He's coming. Dr. Brown and Mr. Dr. Brown.
I'll need to come up. Oh my God. I'm sorry.
Oh, yeah. All right. There's one more person. Is it over? Hey, come. This is the moment. It's all right. All right. Be right here. Like 10 seconds.
Where's Mario?
10 seconds. He's coming. I just called him.
I know he heard us on the stream.
10 seconds.
I know he.
Mario. No, move. This is off the stage. Oh, there's Dr. Brown. There you go. Yeah. Mario.
Yes.
Dr. Brown, turn it. Mario. You've been waiting for. You can't miss no more pictures.
Y'all gotta switch. One step closer. Okay. One.
Alan.
One, two, three.
She said it means the ball.
One more, please.
Thumbs up, everyone. Let's do a thumbs up. Let's do a thumbs up, everyone.
This will be on the front page of the Wall Street Journal.
Yeah.
At least on the Houston Chronicle, at least. Right, Zen?
Yes.
Who promised me the $1 million? I heard it.